So, what is Tor? Tor is short for the Onion router, and it's basically a network of computers or servers designed to improve anonymity and privacy. It's the most common anonymizing network with the most amount of users, and it also allows connected users to offer hidden services or onion services. So these are basically deepnet or darknet websites, and that's what most people refer to when they're talking about darknet or the deepnet websites, even though it could mean many other anonymizing networks and hidden services networks. I should also note that Tor relies on onion routing. This is a technique that was designed by the US Army in order to protect their intelligence communications. You might want to use Tor even if you don't want to access the deepnet. You can literally just use it if you want to protect your privacy and anonymity. So why you might want to do that? Well, let's see what happens when you connect to a website. So let's say, for example, you open your browser and you navigate to google.com or facebook.com. By default, without really doing or trying anything, these websites will be able to see your location, your browser version, your operating system, and much more information. And it doesn't stop there. For example, because you use Google to search for a lot of things, Google can see everything you search right now and even everything that you searched before. Not only that, but again, big websites such as Google and Facebook, they can even potentially access your activity outside of these websites. They use this relying on the features they offer to other websites. For example, any website that would have a Google or a Facebook share button would have a piece of code from Google or from Facebook running on their website, and again, Google and Facebook use this code in order to see which websites you visit, and obviously they use that in order to serve you ads related to you. We all know that. You search for something and you start seeing it everywhere else. But it doesn't stop there. We've all read the Cambridge Analytica scandal and how they were able to access private information about Facebook users, and it doesn't even stop at this. There are several reports reporting that websites such as Facebook create ghost profiles, so profiles for people that don't even have a Facebook account. So you might think, okay, I don't have a Facebook account, they can't really track me. No, they still probably have a profile about you because, like I said, any website that you visit that has a Facebook like button or a Facebook share button will collect data about you, and Facebook is not gonna stop there. They will create a profile, they'll add some name to it or some identity to it, and they'll have all the things related to you, what you like, what websites you visit, what did you purchase recently, and so on. This is only what's been reported, so you can only imagine what's happening without getting caught and without being reported. So, what's the solution? Well, Tor is actually a pretty good solution to prevent this. So, when you connect to Tor, you can imagine Tor being this really big network, and it has a large number of servers. So, each circle in here is literally a server in the Tor network. So you'll connect to Tor, and let's say you want to go to google.com. What's gonna happen is your request is gonna bounce over 3 different servers or 3 different nodes before it goes to Google. So Google can only see the last node or the last server or the last computer that the request was sent from. It can't see you or the original user. Keep in mind that these servers are shared, so at any point of time, there would be millions of users using the Tor network, so there would be lots of requests going in and out of each node. So when you're going into this node, you're not the only user accessing this node. So there are lots of requests coming in and out of here, same in here, and same in here. So this node could potentially be sending thousands of requests out to a number of websites. Therefore, whatever website these requests are going to, it is very hard for it to profile that request or to know where that request came from. Also, data sent within the Tor network is always encrypted. So you can see the green arrows in here. These represent encrypted data. And the only 2 times where your data is sent unencrypted is the red arrows. So it's when you try to send something to the Tor network, and it's when data leave the Tor network. This arrow right here is not very important because if the target website uses HTTPS, or if you're using a browser plugin that forces HTTPS, then this data right here will be encrypted by HTTPS, by SSL. So the only point where your data is sent unencrypted is when you're sending data to Tor. Also, keep in mind, whenever you're sending data to Tor, even to your internet service provider, they can see that you're trying to access Tor, but they won't be able to see the websites you're trying to access. So all they'll be able to see is this person right here is trying to access Tor, but they won't really be able to see that you're trying to go to google.com. So even if there was a hacker or even if there was censorship in place, they really won't be able to see which websites you're going to. They'll only be able to see that you're accessing the Tor network. In the previous lecture, we learned that Tor is an anonymizing network that we can use in order to protect our anonymity and privacy. We learned that it works because it has a number of computers or nodes connected to the network, and then when we send data through the network, it'll bounce over a minimum of 3 nodes before it goes to the destination. Now, I also mentioned in the previous lecture that Tor allows connected devices to host or to offer services. Now, these services can be a simple website, and because these websites are connected to Tor, they will benefit from the anonymity that Tor offers, and therefore they're usually referred to as Tor hidden services or onion services. So this diagram right here would usually look more like this in real life. So you'd have some nodes or relays which you can use in order to go to a certain destination on the internet. But at the same time, some of the connected nodes or some of the connected devices are actually acting as onion services. So these are similar to normal websites that you see on the internet, but they exist within the Tor network. They also use a really smart protocol developed by Tor, which is designed to hide the identity of the server offering the service and the client trying to access the service. So whenever you try to access a Tor service at any point of time, both the client and the server offering the service do not know where or who the other party is. So let's say instead of trying to go to google.com, you try to go to this onion service right here. What's going to happen is you're going to connect to the Tor network. Again, connection right here is not encrypted by Tor, but the ISP, like I said, the internet service provider or any other entity trying to censor your connection, they won't be able to see that you're trying to access an onion service. They'll only be able to see that you're connecting to the Tor network. Then, once you're in the network, you're going to bounce your request over a random node. You're going to go to a second random node. And finally, instead of going to a third node, then out to the internet, to another website on the internet, on the surface web, you're going to stay within the Tor network and you're literally just going to go to your onion service. Now, whenever you try to communicate or connect to an onion service, the process is actually much more complex than what's shown in this diagram. It is done over a really smart protocol that is developed by Tor, so that when you connect to an onion service, you won't be able to see or get information about the server offering the service. At the same time, the server offering the onion service or the hidden service will not be able to get information about you regarding your location or anything that can identify you. Again, all of this done in order to protect the privacy and anonymity of both the server offering the service and the user. Now, in the next lecture, I'm going to show you how to connect to Tor, how to access a hidden service, and you'll be able to understand this better. Okay, so now that we understand that Tor is basically a network of devices connected to each other that we can use to improve our privacy and anonymity, the question is, how can we connect to this network and use it? Well, the answer is actually very simple. You can configure your computer, regardless of what operating system it uses, to route all traffic through the Tor network, and that way, hopefully, everything will flow through the network, protecting your privacy and anonymity. Sadly, though, this is not always the case, as you probably have a lot of programs that I don't even know of that could leak information about you, potentially revealing your location, your IP, and more information. Not only that, but you could be running an unpatched version of Windows or Linux or even OS X. Also, your browser could leak information about you, even if you think you properly configured it to use Tor. Also, a lot of us use browser plugins and browser extensions, which also could potentially leak information. And finally, we have the exit node problem. In the previous lecture, I already mentioned that when you connect to Tor, all the data in green in here is sent encrypted, and at any time, none of the nodes know what website you want to go to. They only know the address of the next node so they can forward the data to the next node. But as I mentioned, the red arrow in here means the data leaving in here will leave unencrypted unless HTTPS is used. So you'll have to go and manually install HTTPS everywhere to force data to be sent over HTTPS. Also, we have this node right here. This is known as the exit node. And the problem here is anybody can actually configure a computer to work as a node in the Tor network. And if your computer is an exit node, you will be able to see this data leaving unencrypted. So you have to trust this person if you're really using the Tor network, as they can potentially see everything you do. Now, like I said in the previous lecture, if the target website uses HTTPS, or if you're using a plugin that will force HTTPS connections, then this will be okay because the data will be encrypted by SSL, because HTTPS encrypts the HTTP data, so you'll be fine. But this is again another step that you have to take and another plugin that you have to install on your browser in order to make sure that your data is fully encrypted along the whole way. And even if someone is able to see this data, such as the person running the exit node here, or if there is someone in here intercepting the connection, even if they capture the data, they'll not be able to read it because it will be encrypted. So, like I said, there's a lot of steps to do if you want to configure your computer to use the Tor network. And even if you do all of that, you could miss a tiny or a small detail that could potentially leak information and reveal your identity. Therefore, a better solution is to either use the Tor browser, and we'll talk about that in the next section. This is a web browser designed by the same people that run the Tor network. It routes all the data through the Tor network by default. It also has a lot of other features to prevent leaking your information and ensuring the data that you send is always encrypted. This is the simplest and a good solution. A better solution would be to use Tails, which is a Linux distro designed for anonymity and privacy. And the best solution would be using CubesOS, with Unix Gateway, which is an amazing operating system that is very, very secure and also can be configured to use Tor by default, improving your security and anonymity and privacy. Now we will go over all of this in the next lectures, starting with the simplest and easiest, and we'll end with the more complex but the best approach. From the previous section, we learned that using the Tor browser is the easiest way to connect to the Tor network. Therefore, in this section, I'm going to teach you how to properly download and install the Tor browser on Windows, Linux, and OS X. I'm also going to teach you how to bypass censorship and download it, install it, and connect to the Tor network, even if it's blocked in your country or by your internet provider. We'll also cover the basics of using the Tor browser, how to change its settings for maximum security and anonymity, and I'm also going to cover some basic concepts about anonymity and privacy. Now, as mentioned earlier, using the Tor browser this way inside Windows, Linux, or OS X is not the best method. It's better to use it inside a more private operating system, and we will cover that later on in the course. But please do not skip this section, because in the next sections, we're still going to use the Tor browser. The only difference is we're going to use it inside a more private operating system. So everything that you're going to learn in here is still relevant. Using the Tor browser, how to configure it, how to bypass censorship, and all of that is still relevant for future sections, and you still need to learn it. Not only that, but this method, even though it's not the best, it's actually very handy because it's very easy and it still provides us basic protection and basic privacy. So if you just want a quick way to become a little bit more private, or if you want a quick method to access the darknet or onion services, then you can use this method. And by the end of the course, you'll learn a number of methods and you can pick whatever suits you and suits your use. So, the Tor browser is a modified version of ESR Firefox. It is configured to route all traffic through the Tor network. Therefore, it improves our privacy and anonymity, and because it routes all traffic through the Tor network, using it, we can access Tor hidden services, or what's commonly known as darknet websites. Now, the browser itself is usually patched from all the known vulnerabilities to make sure that it is as secure as possible. It also comes with a number of plugins disabled to make it more secure and more private, and it also has a number of extra plugins to improve the privacy and anonymity of the user, such as HTTPS Everywhere, which forces HTTPS traffic through all websites, fixing the exit node problem that I spoke about earlier, and it comes with no JavaScript, which prevents JavaScript from running on websites because JavaScript can be used to de-anonymize you. So all in all, it's a pretty nice package. Like I said, we will still be using it in the future in the other operating systems, and you can just install it on any operating system that you want. And if you do that, you'll still get some basic protection. It will improve your privacy and anonymity, and you'll also be able to access the darknet or onion hidden services. So let's go ahead and see how we can first download Tor, and then we'll discuss how we'll install it on Windows, OS X, and Linux. Right here, I have the download page of Tor. I will include the link for this page in the resources. And as you can see, you can download Tor for Windows, for OS X, and for Linux. Now, if you load this page and it doesn't work for you, then your network or your internet service provider might be blocking this page. So what I'm going to do is I'm going to include another link, which is the link of the Tor's project repository, where you can download Tor as well. And as you can see, we have links for Windows, OS X, and Linux. It's highly unlikely that this will be blocked because this is part of GitHub, which is a huge platform that contains programs for all sorts of things. So it's highly unlikely that this is blocked. But if this is blocked, if you try to load this page and it still didn't work, then you can use any of the methods listed in here to get Tor. So you can send an email to gettor@torproject.org and just tell them the operating system of your computer. So you can type Windows to get Windows, OS X to get an OS X version, or Linux to get a Linux version. And they will send you a download link as a response. You can also use XMPP or Twitter in a similar fashion to get Tor. Obviously, you only need to do this if the Tor website and their Git repo right here are blocked. So first try these things. If that didn't work, then you can try this method. This is actually very, very simple. I have an example right here that I've just tested. So all I did is I sent an email and I literally just said Windows EN to get the English version to gettor@torproject.org. And a few minutes after that, I got it in my inbox right here with 2 download links for the latest version of Tor. So once you download the relevant version to your operating system, you can just double click it and go ahead with the installation process. But I want to show you how to verify the download first to make sure that the file has not been modified before you received it. So right now, just go ahead and download Tor for your operating system. Do not run it. And in the next lectures, I'm going to show you how to install it for Windows, OS X, and Linux. So the next lecture will be for Windows. The lecture after that is going to be for OS X. And the third lecture after this is going to be for Linux. Feel free to skip any of these lectures. Just go to the lecture that will cover your operating system. You won't lose any information if you skip any of these lectures. So in this video, I'm going to show you how to download Tor, verify it, and make sure that it hasn't been modified as it got downloaded, and then install it on a Windows 10 system. If you have OS X or Linux, then please skip this lecture and I will cover installing Tor on other operating systems in the next lectures. So, as you can see, the normal page is loading for me, so I'm gonna download it from here. I have a 64-bit computer and I'm running Microsoft Windows, so I'm just gonna click on the 64-bit link for Microsoft Windows. And I'm gonna save this. This will automatically save the file right here for me in the downloads. And as you can see, the download is complete now, and I can literally just double click it and install it, just like any other program. But before doing that, it's a very good idea to verify that the file we downloaded here did not get modified as it was being downloaded. Because when you download something from the internet, it passes through a number of nodes in which it can be modified. So it can be modified by your internet service provider, it can be modified by your network administrator, and it can even be modified by hackers who manage to intercept the connection. So in order to verify that this file did not get modified, we're going to use a signature provided to us by the Tor developers. So as you can see on this page, each download has a SIG. This SIG stands for signature, and this is a file that is unique to this download, to the installer. It was generated by the developers when they packaged the installer, and it can be used to verify that the installer did not get modified since it was packaged by the developers. So, to verify the installer, the first step is to download its signature. So like I said, as you can see, each file has its own signature. I downloaded this file right here, so I'm gonna download this signature in here. So I'm gonna right click the signature file and I'm gonna click on Save Link As to download it. And I'm gonna save it in my downloads, same place that we have in here. And I'm just gonna click on Save. And you can see we have this new file with a .asc extension. This is the signature for this file. So as you can see in here, each download has its own signature. So the signature is relevant to the file that we just downloaded, and it can be used to verify the integrity of the file. So what we're going to do is we're going to use another program called GPG for Win. we're going to use this program to check the signature and make sure that this file right here matches the signature right here. And if it does, then this means that the file has not been modified, because if this file gets modified, then this signature right here will not match the file. So the first step now is to download this program that will verify the signature for us, which is GPG4Win right here. I'm going to include its download link in the resources. Right now I'm going to set this to 0. I don't want to donate. And I'm just going to click on download to download the program. We're going to save it. And we have it right here. Now we're going to double click this to install it. And it's a normal Windows installer, so it's actually very, very simple. We're just going to click on OK. Next, install, and it'll install it for us. And that's it, we're done. So we're going to finish. I don't want to reboot. I'm going to reboot later. And that's it. Now the file is installed and we can actually use it with a graphical user interface that I noticed is a little bit buggy. Therefore, we're going to use it using the command prompt. So I'm going to go to Start. I'm going to type CMD to open my command prompt. And I'll just put this here. So the first thing that we need to do is import the key of the Tor developers. So we can get that from their page right here. This is their key, and we can actually add it using this command. So we do gpg.exe. This is the name of the program that we just installed. We're giving it the key server that it's going to get the key from, and we're giving it the developer key right here after the receive keys argument. So I'm going to copy all of this and I'm going to paste it here. All I have to do is just right click. It will automatically paste, and I'm going to hit enter. This could take some time, so just be patient and give it its time. You might also have to run this command a number of times until it works. This is because their servers might be under pressure, so you won't be able to get the key. But as you can see right here, I was able to get the key. So right now we can go ahead and verify the file that we downloaded. But before I do that, I'm going to make sure I have the correct key. So I'm going to do gpg.exe, the same command. I'm going to say I want to see the fingerprint of the key that I requested. So the key that I requested is this key right here. So I'm going to copy it again. And I'm going to paste it. And right here, we have the fingerprint of the key. And what you want to do is compare this fingerprint right here with the fingerprint that you have on their website, which is this one. If you have the same fingerprint, this means that you've downloaded the correct key, and it means that we can use this key to verify the integrity of this installer. So the last step now is to actually do that and verify that this installer is the correct installer. And again, we're going to use the same command, but first we will need to navigate to where we have the installer. So as you can see, the installer is in users, Zaid downloads. So I need to go to the downloads directory. So we're going to use the cd command to change our working directory. And I want to go to downloads. Keep in mind, it's capital D in here. I'm going to hit enter. And as you can see, now I'm in user Zaid downloads. And I can do dir to list all the files that we have. And you can see we have the GPG installer, we have the Tor browser installer, and the signature. So all we have to do is use gpg.exe again. We're going to say that I want to verify. And we're going to give it the name of the signature. So this is the name of the signature file. You can copy it. We also have it in here, so you can copy it from here. Or you can just type the start of it followed by a tab. It'll auto-complete for us. And make sure you complete to the .asc to specify the signature file. I'm going to hit enter. And let's just make this a little bit bigger so we can read it easier. And as you can see, it's telling us that this is a good signature. So basically, it's telling us that the signature right here is the correct signature for this file. So this means that this file has not been modified since we downloaded it from this page, because this page had the file itself, it had the installer itself, and it had the signature, which we downloaded from here. Like I said, each signature is unique to each file, and we use this signature with the developer key to sign this file, and as you can see, everything matched. So this means that this file has not been modified since we downloaded it from the web page. So we can go ahead now and double click it to install Tor. So as you can see, this step was optional. You don't have to do it, but we did it just to make sure that this file has not been modified by anybody when we downloaded it from the Tor website. So the rest of the install is very simple. We're going to say, okay, I want the language to be English. I'm going to keep the installation path for the default one. I'm going to click on install. It'll install it for me just like any other program. And we're done. So you can uncheck these if you don't want to run Tor or if you don't want to add it to the start menu. I'm going to keep everything the same. I'm going to click on finish, and this will automatically start the Tor browser for me. As you can see right here, it's telling me I can click on connect to connect to the network. So we're going to do that. And now the browser is going to first connect to the Tor network and then launch the browser for me. And as you can see, the browser is working, and I'm not going to use it right now. I'm not going to show you how to use it. We'll talk about this in the next lectures. But right now we have a clean version of the Tor browser installed on our computer and ready to be used. In this video, I'm going to show you how to verify Tor browser and install it on an Apple OS X computer. If you have a Windows computer, then please revise the previous lecture, and if you have a Linux computer, then skip this video and watch the next video. Only watch this lecture if you want to install Tor browser on an Apple OS X computer. Otherwise, just skip it. You will not lose any information if you skip this video. So, right now I have the Tor download page right here. And as you can see, I can download Tor for any operating system, Windows, Apple, and Linux. And right now we want to install Tor browser on an OS X computer. So I'm going to download the English version from the Apple OS X column. One click here will download it for you, but I already have it downloaded here, so I'm not going to click that. And right now I can literally just double click it to install it. But before doing that, it's a very good idea to verify that the file we downloaded here did not get modified as it was being downloaded. Because when you download something from the internet, it passes through a number of nodes in which it can be modified. So it can be modified by your internet service provider, it can be modified by your network administrator, and it can even be modified by hackers who manage to intercept the connection. So, in order to verify that this file did not get modified, we're going to use a signature provided to us by the Tor developers. So as you can see on this page, each download has a SIG. This SIG stands for signature, and this is a file that is unique to this download, to the installer. It was generated by the developers when they packaged the installer, and it can be used to verify that the installer did not get modified since it was packaged by the developers. So, to verify the installer, the first step is to download its signature. So like I said, as you can see, each file has its own signature. I downloaded this file right here, so I'm going to download this signature in here. I'm going to right click the signature file, and I'm going to click on Save Link As to download it. And I'm going to store it in Tor in the same directory that I have here. I'm going to click on Save. And as you can see, I have the signature file right here. Now, all we need to do is verify the signature and make sure that this signature corresponds to this installer. And if it does, then that means this installer was not modified since this signature was made, which means that the installer was not modified since the publisher of Tor has published the file. Now, we'll need to use a special program to do this verification. On OS X, we can download this for free. It's called GPG Suite. So you can click on download here to download it. And I already have it downloaded right here. And to install this, all you have to do is literally just double click it, just like any other application. We're gonna double click the installer here. We're gonna continue, keep the language at English. We're gonna agree. We're gonna click on install to install it. I'm gonna put my password. And that's it, it's installed. So I'm gonna click on close and I'm gonna move this to trash. This will just move the installer to trash. And I did this because I don't really need it anymore because I've installed the program. So I'm gonna close this. I won't need to use any of this. This is just the program. It got opened automatically. And we're gonna use the program that we just installed from the command prompt to verify the signature and see if this installer was modified or not as we downloaded it. To do this, first we need to add the key the Tor developers use to sign their installers. We can get the key from their webpage right here, and I'm going to include this in the resources of this lecture as well. And as you can see, if we just scroll to the top a little bit right here to the Mac OS X, you can see that they're giving us the key. So this is basically their key. And the command that we need to use in order to add the key is this command right here. So GPG is the name of the program that we just installed that I said we need to use in order to verify the signature. We're giving it a key server. So this is a server where we are going to pull the key from. And then we're using the receive key argument to specify the key that we want to get. So I'm going to copy all of this and I'm going to paste it here. And give this a few seconds. It might actually take some time and it might even fail. So just try it a few times because when you try it, the servers might be under a lot of pressure and they just will time out and they won't allow you to get the key. But as you can see, in my case, I got it from the first try in a relatively short time. So now the key is added, and before we actually verify the file, I want to make sure that I got the correct key. And to do that, again, I'm going to use the same command, the same program that we just installed, and I'm going to say I want to see the fingerprint of the key that we just got. So this is the key that we just got. So I'm going to copy it and paste it. And I actually didn't copy the full key. This is the full key. So again, I'm just going to copy it and run the same command. And perfect, I got the fingerprint. So the fingerprint is right here. And you want to check this against the fingerprint that you have on their website. So this is the fingerprint that they have. And as you can see, the two fingerprints match, which means that we have the correct key added. And now we can go ahead and try to verify the installer that we just downloaded, which is this installer. So before we do this, we need to navigate to the location where this is. And as you can see, it's in Downloads, TOR. So right now, if I do pwd to get my current working directory, you can see I am in users zoos. And what I want to go is users zoos downloads TOR. So I'm going to do cd to change my working directory. And I want to go to downloads /tor. So in your case, if you just downloaded the files in your downloads, you wouldn't need to go into the tor directory. In my case, because I have them in the tor, I'm going to put tor. I'm going to hit enter. And if I do pwd to get my current working directory, you can see I'm in users, zoos, downloads, tor. And if I do ls to list all the files that I have in the current working directory, you'll see that I have two files. The first one is the installer, the Tor browser installer, and the second one is the signature that we can use to verify this installer. Now, to verify the installer, all we have to do is, again, use the same command, pgp. We're going to say that I want to verify and give it the name of the signature file, this file right here, and we have it right here. So you can just copy and paste it, and we're gonna hit enter, and I typed pgp and it actually should be gpg, so another spelling mistake that I made here. So I'll fix that. I'm gonna hit enter. And perfect, as you can see, it's telling us that this is a good signature from the Tor browser developers. So what we did right now is we used the signature to validate that this file right here did not get modified since the signature was created. Like I said, this is not a necessary step, but if you want to make sure that you're using a clean version of the Tor browser, then this is the best way to do it. So now that we are happy with the installer and know that it did not get modified, we can just double click it to install it, just like you install any other application on your system. So as you can see, we have the Tor browser right here. You just have to drag and drop it to the applications in here, and once it's copied, it'll go into your applications where you can launch it from here. So if I just click on it in here, I'm gonna trust it, so I'm gonna say open. And this will first connect to the Tor network and launch a normal web browser for me, but like I said, anything you do on this web browser will go through the Tor network. And we'll talk more about how to use this browser, how to configure it, and all of that in the next lectures. But right now, we managed to install a clean and unmodified version of the Tor browser. In this lecture, I'm going to show you how to verify and install the Tor browser on a Linux computer. If you have a Windows or an Apple OS X system, then please go back to the previous lectures where I show how to do this in details for these operating systems. Only watch this lecture if you want to learn how to install the Tor browser on Linux. Otherwise, skip it and you won't lose any information. You can continue from the next lecture where I'm going to show you how to use the Tor browser. So, the instructions that I'm going to show you right now will work on most Linux distros like Fedora, Debian, and Kali, but I'm going to do it from Ubuntu because this is the most popular one. So, the first thing that you want to do is go to the Tor browser download page that I have right here, and I'm going to include its links in the resources of this lecture. You want to scroll down to where you have the downloads for all the operating systems, and this time we want to install it on Linux. So I'm going to go here to the right where it says Linux, and I'm going to download the first one because this is the English version. Now I have a 64-bit computer, so I'm going to click on the 64 bits, and this will allow me to download the Tor version for Linux for 64-bit computers. I've already downloaded this right here, as you can see in my downloads, so I'm going to cancel this. And once you have it downloaded, all you have to do is really extract it and run the binary that will run the browser for you. But before doing this, it's a really good idea to verify that the file that we just downloaded right here has not been modified as it was being downloaded. Because when you download something from the internet, it passes through a number of nodes and it can actually be modified by your internet service provider, by your network admin, or even by hackers if they manage to intercept the connection. So, what I want to do right now is verify that the file that I just downloaded did not get modified as it was being downloaded from the Tor website. To do this, we're going to use a signature file provided by the Tor developers. So as you can see on this page, each download has a SIG. This SIG stands for signature, and this is a file that is unique to this download, to the installer. It was generated by the developers when they packaged the installer, and it can be used to verify that the installer did not get modified since it was packaged by the developers. So, to verify the installer, the first step is to download its signature. So like I said, as you can see, each file has its own signature. I downloaded this file right here, so I'm gonna download this signature in here. I'm gonna right click the signature, save link as to save it, and I'm gonna choose where I want to download it, and I'm gonna keep it in my downloads. So I'm gonna click on save, and as you can see, I have it right here. It has a .asc extension. Now, before we can use this file to verify the installer, we need to import the key of the Tor developers. So we're gonna go to the Tor verify page, and this is the key of the Tor developers right here. So what we're gonna do is we're gonna import this key using the gpg command. We're saying that we want to import a key from this server, and we're giving it the server that we want to get the key from, and then we're using the receive key argument to receive this particular key. So I'm literally gonna copy this command and paste it here. And when you run this command, give it some time. It might actually take up to a minute or two, and it might fail once or twice, so keep trying it until it works. The reason why it might fail is because maybe at the time of you trying this command, these servers would be under a lot of pressure. But as you can see, it worked for me in a relatively short period of time, and I managed to import the key, as you can see in here. So now we can actually go ahead and verify the installer. But before I do this, I want to double check and make sure that I imported the correct key. So to do this, I'm going to use the gpg command again. And I'm going to say I want to get the fingerprint of the key that I just imported. So the fingerprint of this key right here. Again, I'm going to copy it and paste it here. This command will give me the fingerprint of the key, and we're going to compare this to the fingerprint that we have in here. And as you can see, they're identical. And because they are identical, this means that we have imported the correct key. So the last step now is to use the signature file that we downloaded right here to verify and make sure that this installer did not get modified. So before we can do that, we'll need to first navigate to where the installer and the key file are stored. And as you can see, they're stored in my downloads directory. So right now, if I do pwd on my terminal, you'll see I'm in home Zaid. So I'll need to go to downloads. So I'm going to do cd downloads. And now if I do pwd to get my working directory, you can see I'm in home Zaid downloads. And if I do ls to list all of the files and directories in the current working directory, you'll see I have these two files right here, which are the same files that I have in here. So right now I'm basically in the downloads using my terminal. So all I have to do right now is verify this signature. So we're gonna say GPG again, the same command that we've been running, and we're gonna say I want to verify and give it the name of my signature file, which is this file right here. I'm gonna hit enter, and perfect. As you can see, it's telling us that this is a good signature from the Tor browser developers. So basically what this means is, it means that this signature right here, the Tor browser package that we just downloaded right here, has not been modified ever since this signature was made. And we know that this signature is valid because we got the signature from the Tor download page, and we also validated the Tor developer keys using the instructions from here. So we can ignore the warning here. The warning here literally just saying that GPG is not able to validate the signature creators, so it wasn't able to validate the creators of Tor, but we know that these signatures are valid because we verified their key with the instructions that we saw in here, and we validated the signature that we got from their web page. So now that we are happy that this package has not been modified ever since it was packaged by the Tor developers, we can go ahead and uncompress it. So I'm going to right click it, extract here, and we have the package content right here. And if we navigate inside this, we have the browser, and this is the binary that you want to run in order to run the browser. So I'm going to go back to my terminal right here. I'm going to clear the screen, and keep in mind, in my terminal, if I do pwd, I'm already in my downloads directory. So if I do ls, you'll see the directory that was just created when we uncompressed the package. So we can navigate into this by doing cd tor browser linux, the whole thing. You can actually use the tab to autocomplete. I'm gonna hit enter, and I'm inside this directory right here. The next thing I need to do is to go inside this directory. So again, if I do ls, you'll see we have one directory in here. So we're gonna do cd tor browser enus. Again, if I do ls, it'll list all the files and directories, and similar to what you see in here, we have the browser and the start Tor browser.desktop. Note that this right here is in green. This means that this is an executable. So we can run any executables in Linux by doing // followed by the executable name, which is start Tor browser.desktop. I'm gonna hit enter to run this executable, and this will launch the Tor browser for me, as you can see. And in order to connect to the Tor network, all I have to do is just click on connect here. This will connect to the Tor network. It will configure the browser to send all data through the Tor network, and as you can see, I'll get a Firefox window, a browser similar to Firefox, but like I said, any website that you'll go to through this browser will be loaded over the Tor network. So that's it for this lecture. Right now, we managed to install the Tor browser on Linux using a clean and unmodified package. Don't worry about how to use the Tor browser and about its settings. We will talk about that in the next lectures. Okay, so now that we have Tor browser installed, let's go ahead and make sure that it's working as expected and is routing all of the traffic through the Tor network. Now I'm going to be using the Tor browser on Windows, but as seen before, the interface is identical on Windows, Linux, and OS X. The installation is different, and I showed you how to install it on all of these operating systems. So once it's installed, using the browser is exactly the same. So I'm going to double click the launcher. And as you can see, you get a normal browser window, and don't maximize this window ever, and I'll talk about that later. But for now, just to check to make sure that Tor is working, I'm gonna go to check.torproject.org. And as you can see, it's saying congratulations, this browser is configured to use Tor, and it's given us the IP that our browser appears to be coming from. So this is not my real IP, this is the IP that I will appear that I'm coming from. So this is all perfect, and I'll talk about more Tor settings in a future lecture. But right now, I want to show you how to bypass Tor being blocked. So in case you came to this website and it didn't load, or if you saw a warning here saying Tor is not working, then this could be because your network administrator or your internet service provider is blocking you from using Tor. See, when you try to access Tor, as I mentioned before, the first thing you'll have to do is connect to the Tor network and send your traffic to a random Tor node. So you're going to pick one of these nodes and you're going to send your traffic through it as the first node. The problem is, before you can actually connect and send data to this node, your data can easily be intercepted by your network administrator or your internet service provider before it even reaches the first node and before it's even able to connect to the Tor network. So what your internet service provider or ISP can do is they could identify all the available Tor nodes right here, the white circles, because they are publicly available, and then just block them all, prevent you from connecting to any of these white circles. So therefore, whenever you try to connect to Tor, you're passing by internet service provider, which is running a firewall, checking if you're trying to connect to any of these nodes, and if you are, it'll block your connection. The result of this is when you come in to load this page, it'll either not load or it's going to tell you that you're not using the Tor network. A simple solution to this is to use a Tor bridge as the first node. What we mean by Tor bridges, they are normal nodes similar to all the white circles that we can see in here, but they are not publicly available. So the only way that the internet service provider was able to block us is because they know all the white circles, they know all the public nodes, and they have a rule in their firewall to prevent any user from connecting to any of these white circles. So to bypass this, we can just use a node that is not publicly available. It's not being advertised. That way, when we try to connect to it, the internet service provider will not have this node in its list, and therefore we can connect to it and then continue using Tor, going out to another website or even going in and accessing an onion service. So this is pretty good. It's a pretty good solution until firewalls and service providers became smarter and implemented more advanced methods. What they started doing is they started using deep packet filtering, or what's known as DPI, to identify Tor traffic and block it. So they don't even care about which node you're trying to connect to. They started analyzing all traffic that you sent out of your computer, and they managed to identify what Tor traffic looks like. So like I said before, when you use Tor, they can't really see which websites you're trying to go to, but they'll be able to see that you're trying to use the Tor network, either by identifying the node that you're trying to connect to, or by using deep packet filtering, which will tell them that the traffic of this user matches a signature of a Tor traffic, therefore this user is using Tor, therefore we will block this traffic. So the solution to this is to use a pluggable transport. Pluggable transports will try to make your traffic look similar to any other normal traffic. So when you're trying to connect to a bridge, we're going to use a bridge that can use a pluggable transport, And this way, all the traffic that we're gonna send will not look like Tor traffic. It'll look similar to traffic that's generated when you're trying to access Google or Facebook or any other website, similar to any normal web traffic. Now, this is a pretty good solution. It will work in many cases, but it can still fail in some instances. But the worst case scenario, even if it fails, the internet service provider will be able to know that you're using Tor, but again, they won't really know which websites you're trying to access, unless they run a more sophisticated attack. Now keep in mind, this will slow down your connection. So if you were able to browse this page and it's telling you that everything is working, then maybe you shouldn't really use them. It really depends on your case. And in the next lecture, I'm going to show you how to configure Tor to use a bridge with a pluggable transport to access the Tor network even if it's being blocked. Okay, so now that we know what bridges and pluggable transports are, let's see how we can get them and configure our Tor browser to use them so we can access Tor even if it's being blocked by our internet service provider or by our network administrator. So the first thing you want to do is, right here I have my normal Firefox browser. This is not the Tor browser. And I've loaded the bridge database, which you can get by going to bridges.torproject.org. I'm going to include this link in the resources of this lecture. And once you're here, you can just click Just Give Me Bridges to get the normal bridges that will allow you to access Tor if the firewall is only blocking the known Tor nodes, so if it's not using DPI. And we can also set the advanced options here and select a pluggable transport so that we can access Tor even if the firewall is using deep packet filtering, analyzing our traffic and blocking all traffic that seems like it's Tor traffic. So I'm going to keep everything the same. I'm going to keep using the same pluggable transport. But as you can see, we have a number of options that you can try. If one of them didn't work, you can try the other one. But I'm going to keep this on OPS4. So right now, all I have to do is just click on Get Bridges. But if this page did not load for you, because chances are if your service provider is blocking you from using Tor, they might be blocking this as well. So in order to get your bridges, you can send an email to bridges@torproject.org. You have to send this email from either a Gmail, a Yahoo, or a RiseUp account. Once you do that, if you just type bridges in the email, you will actually get an email with all the available bridges and pluggable transports, similar to the email that I got right here. So if I wanted to get normal bridges, so bridges that you can get by clicking on the green button here, all I have to do is just send an email saying get bridges. Or if I want to get a bridge that uses a pluggable transport, so similar to me clicking on the purple button here, then I can send get transport followed by the transport type. And again, as you can see, the available transport types are similar to the available transport types here that we get when we click on the drop-down list. So let me show you how to get the transports if this page is blocked. So all I have to do is compose a new email. We're going to send this to bridges@torproject.org. And I'm going to say I want to get transport. So we're doing this command, and the transport that I want to get is the OPS4. So space OPS4. We're going to send this, and this will take less than a minute, and you should get your bridges in an email in your inbox. And perfect. As you can see, I have an email here. If we click on this, you'll see I have my bridges, which I can just copy and paste them in my Tor browser. But as you can see right here, it's working for me, and it could be working for a lot of you. So if this was working, all you have to do is just literally click on Get Bridges. It's going to ask me to fill up the CAPTCHA. So I'm going to set this to Q. So I'm going to try to fill it. Hopefully I get it right from the first time. And perfect. As you can see, I have my bridges that use the OPS4 pluggable transport, as you can see. So all I have to do is select all. It's already selected. I'm going to copy it, Control C. And then I'm going to go to my Tor browser, which I have already loaded before. I'm going to go on Tor network settings. I'm going to tick the first box. Tor is censored in my country. I'm going to click on provide a bridge that I know. And I'm going to paste the bridges that I just copied, Control V. And I'm done. I'm going to click on OK. And now Tor should be going through the bridges that we just configured it. So if, again, you'd only need to do this if this page did not load, or if it loaded and told you you're not using the Tor browser. So in my case, it's already working, but I'm just gonna double check to make sure that I didn't break anything by using the bridges. And perfect, as you can see, it's telling me that Tor is working and all my traffic is going through the Tor network right now. Now, like I said, with this method, you might notice that the connection will get a little bit slower than a normal Tor connection. Again, because obviously the traffic is being obfuscated to make it look like it's normal traffic and not Tor traffic. Also, like I said, in worst case scenario, even if this didn't work, your internet service provider will be able to know that you're using Tor, but they won't really be able to see which websites you're trying to go to unless they run a more active attack. So, if being flagged as a Tor user would put you in trouble in your country, or if you don't want to be identified as a person that could be using Tor, then a really good solution is to use a VPN, and I'll talk about that in the next lecture. But for now, this is a free and a very good solution to access the Tor network if it's being blocked. So far, I mentioned the word VPN in a number of lectures, but I never really explained what it is. So, in this lecture, I'm going to explain what a VPN is, how it works, and how we can use it to bypass censorship and protect our privacy, anonymity, and security. So, VPN stands for Virtual Private Network, and to understand how it works, let's first have a look on a normal scenario where we have a user trying to access google.com. As we mentioned before, usually this traffic is sent unencrypted unless Google or the website they're trying to access uses encryption. And like we said, this traffic passes through a number of routers, it passes through your internet service provider and so on. And all of these stops can see the data that you're sending and manipulate it, profile you, gather information about you, and so on. Now, if you use a VPN, you will first connect to the VPN server, which you can think of as a computer that exists on the internet, on the cloud, with really good resources. And what happens is you create an encrypted tunnel, an encrypted connection with this computer. So whenever you want to access anything on the internet, you send that first to this computer, but the request is sent encrypted. Hence, I used a green arrow in here to indicate that the data sent is encrypted. So, whenever you want to access something, both you and the VPN server will be able to read this data and understand it. But if anybody intercepts this data, whether it's your internet service provider, whether it's your network admin, whether it's a hacker, they will not be able to read this data or manipulate it or profile you because this data will be encrypted, it'll be gibberish. Then, once the VPN receives the data, once it sees, for example, you want to go to google.com, it'll simply forward that request to Google, and then the response will follow a similar path. Again, keep in mind, traffic leaving the VPN will be unencrypted. It'll only be encrypted if the service that you're connecting to uses encryption. Hence, I used a red arrow in this case. Now, you can also use a VPN and connect to the Tor network. So you'll first connect to your VPN. Again, green arrow means your traffic is encrypted, and then it leaves your VPN connecting to the Tor network, and then you can either access an Onion service or go to Google or any other website on the ClearNet. Now, this architecture of first creating a secure tunnel and connecting to a server and then go to the internet or to the Tor network or to whatever service is really, really useful because, first of all, it adds an extra layer of encryption. This means that it's going to improve our privacy and anonymity because it'll prevent anybody that intercepts this connection, that intercepts this flow of data in here from seeing what data you're sending or receiving. Again, whether it's your network admin, whether it's your internet provider, whether it's a government, it doesn't really matter. Your data in here is going to be encrypted, therefore it'll be useless to any entity that intercepts it. It will also help us bypass censorship. So we've seen previously that we can use pluggable transports and bridges in order to bypass censorship and connect to the Tor network, even if it's being blocked by your network admin or by your internet provider. A better solution, in my opinion, is to simply use a VPN. Because let's assume we have an internet service provider in here that doesn't allow the users to access Tor. When you use a VPN, again, you're creating a secure encrypted tunnel between you and the VPN provider. So the internet service provider cannot see that you're trying to connect to Tor. All it can see is encrypted data going to some server on the internet. Therefore, in the case of the pluggable transports and bridges, in worst case scenario, the internet service provider or the admin or the government will be able to see that you are trying to connect to Tor, which could cause problems in some countries. In the case of using a VPN, the worst case scenario is your internet service provider will be able to know that you're trying to connect to a VPN. That's it. They won't know that you're trying to use Tor, and they won't be able to see any data you send because, like I said, the connection is encrypted, and hence the use of the green arrows in here. On top of all of these features, using a VPN protects us from hackers because it is very easy for anyone connected to the same network as you to intercept your data, to redirect the flow of data so that it flows through their computer. I actually cover this in my network hacking and in my ethical hacking courses. So whether you're connected to a public network, such as an airport network or a hotel or a college network, or even at your own home network, anybody connected to that network can redirect the flow of data so that it flows through their computer. And once they do this, they'll be able to see all the websites you visit, all the usernames and passwords you send. They'll even be able to modify data on the fly and backdoor files you download, and in many cases, even gain full control over your computer. Now, if a VPN is used, the hacker will still be able to redirect the flow of data, and they will still be able to intercept your data. But this data again will be encrypted, hence the use of the green arrows, so they won't be able to see the usernames or the passwords or anything, and even if they try to modify this data, they wouldn't be able to do it because it will be simply gibberish and they wouldn't be able to analyze it or do anything with it. That's why using a VPN is a really good solution to prevent man-in-the-middle attacks. With that being said, there is a number of things that you need to keep in mind when using a VPN. First of all, we are introducing a man in the middle in here. So if we go back to the previous diagram, you can see that our connection was going directly to the internet. But when we're using a VPN, we're literally adding an extra node to our connection. So the data is encrypted between the user and the VPN provider, but the VPN provider is able to see this data. Therefore, you want to make sure that you pick a reputable VPN provider and avoid free providers because a lot of them keep logs and analyze you. You also want to make sure that you use a provider that keeps no logs. And with keeping all of these things in mind, with picking a reputable provider, avoid free ones, and make sure that they keep no logs, also use HTTPS everywhere. this really solves the problem of having a VPN here. Even if you trust them, even if you think this company will never do anything bad, will never keep logs and analyze your traffic, when you use HTTPS everywhere, you're adding another layer of encryption. So your connection between you and the VPN provider will be secured by two layers of encryption. First, the encryption used by the VPN, and the encryption enforced by HTTPS everywhere, which is TLS. And then when traffic leaves the VPN provider, you will have TLS encryption up to whatever destination you're going to. Therefore, even the VPN provider in this case will not be able to see your data because it will be encrypted with TLS, which is a very, very secure encryption. Last but not least, when signing up with a VPN, you want to make sure you use a VPN that does not require a lot of information. Again, at the end of the day, we're trying to improve our privacy, and it doesn't really make sense to give them my address and all this information. You can also take this one step further and pay with crypto, but this is optional. It really depends on you and your threat model. Now, there are a lot of VPN providers out there. I highly recommend you go and do your own research. Me personally, I use our own VPN that we provide at Z Security, which you can get at zsvpn.com. So I have the website already here, and I'm already at the download section. It supports all platforms, so you can use it on Windows, OS X, Linux, iOS, and Android. Doesn't really matter. And using these VPN providers is actually very, very simple. All you'll have to do is, first of all, obviously sign up with the one that you want, download their client, and once you have the client downloaded, you simply want to select a server and connect to it. So I already have the client downloaded and installed, and I'm simply going to connect to the Australia server. And right now, as you can see, my location changed to Australia. So the websites that I visit will think that I am visiting them from Australia, because going back to this diagram, I connected to a VPN server that is in Australia. So anything I send will be leaving this server, and therefore I'll appear like I'm coming from this country. So that's another benefit of using a VPN. You can change your location and access websites or content that is only available for a certain country by simply connecting to a VPN that is in that country. So now that I'm connected, we can see that it's saying here Australia. We can double check on the website itself. If I refresh it here, you'll see this bar will tell me that I am protected by ZSVPN. My IP appears to be this one, which is not my real IP. And I seem like I'm coming from Australia. So that's perfect. And now that we are connected to the VPN, we can go ahead and use the internet normally, and we'll appear like we're visiting these websites from Australia. Or you can use your Tor browser, and this way we'll connect to the Tor network from the VPN server that is in Australia, and then bounce through another 3 nodes and then access the website that we want, or access Tor hidden services. So we can just go to check.torproject.org to confirm that we're connected to the Tor network properly. And as you can see, that's perfect. We're connected to it. This is the IP. This is the end IP, the IP of the exit node. And we can even click on the eye here to see the nodes we're bouncing through. So what's happening right now is we have an encrypted connection from my computer to a VPN server in Australia. And then from there, we're connecting to Netherlands, to Germany, to the United States, and then we access the Tor project websites or whatever website we want. Now that we know how to install the Tor browser and how to access the Tor network, even if Tor is blocked, let's have a quick overview on how to use this browser and how to configure its settings for maximum security and anonymity. Now, the first thing to keep in mind is never use Tor in full screen. Always keep it unmaximized, as you can see here, and just increase the screen size manually from the edges of the window, because the size of the screen can be used to identify what kind of laptop or what kind of a screen you're using. Also, it's a very good idea to always check for updates. So to do that, all you have to do is just go to the onion right here and click on check for browser updates. So as you can see, I'm at check.torproject.org and everything is working for me. It's telling me that Tor is working and that my IP appears to be this IP. So this is all good. If we go here to the eye icon, you will see the Tor circuit. So these are the nodes that I've been showing you before in here. So this would be my first, second, third. And if we go back to here, you can see that my first or guard node is Germany, then I'm going to the United Kingdom, then to Canada, and then going to the Tor project website. So these are my 3 nodes that I used to always show you in here. So that's really cool. You can also click on new circuit for this site, and what this will do is it'll randomly select 3 different nodes, different than what we have in here. This will basically change your IP and it'll make you look like you're coming from a completely different IP. So if I click on it now, you'll see this page will refresh and you'll see my IP in here changed. And you can see that now I'm going Germany, Moldova, and then I'm going to the target website, which is torproject.org. So that's very cool. What I also want to show you is the settings. So if we click on the onion icon in here, you can see again, we can request a new identity from here. When you click on new identity, the whole browser will close, your cache, your history, and all your browsing data will be removed. Then the browser will restart with a completely new circuit. So this option will make you lose all the tabs that you have open, but you will look like a completely different person. Whereas when you request a new circuit from here, this circuit will only affect the current website, the website that we have loaded here, and it won't delete your history or browsing data. So the only thing that will change is your IP. You will seem like you're coming from a different country or from a different IP. Whereas the new identity, it'll change all of that, plus it'll close all tabs and it'll remove all browsing data. So you'll literally look like a completely new person. Next, I'm gonna click on the Tor network settings. We've actually used this before. When we wanted to use pluggable transports and bridges, we ticked this option right here and we provided bridges in this box. Now I'm not using bridges, so I'm gonna uncheck this. The second option, if you're using a proxy to access the internet, so you can check this and put the proxy information. And finally, if you think your service provider or your network manager is using a firewall that only allows specific ports, then you can check this option and only use port 80 and 443. These are ports that are commonly used by websites on the internet. It's used by pretty much all websites. Therefore, if you only use these ports, you'll manage to bypass some firewalls, but again, this will still slow your connection. So I'm gonna keep this unchecked because as you can see, I'm able to access the Tor network with my default settings, so I don't really need to change much. Finally, I want to show you some of the options that I recommend modifying just to make sure that we have configured our browser to be as secure and as anonymous as possible. So I'm gonna click on the more options in here, and I'm gonna go down. Now in here you can request a new identity or request a new circuit. I've already showed you how to do this and I explained this at the start of the video, so we're not gonna do it now. But what we want to do is to go to the options here. So you'll see an options window very similar to the one you get with a normal Firefox browser. And what I want to do is just modify some settings that I think will just make the browser a little bit more secure. So I want to go to privacy and security. And first of all, in the history, I'm going to modify this and make sure that it never remembers history. Next, I'm going to scroll down and we're going to go to the tracking protection and I'm going to set this to always. Then I'm going to scroll down. I'm going to make sure that it's going to block pop-up windows. I'm going to make sure that it warns you when the browser tries to install add-ons. And I also recommend checking this box to prevent accessibility services from accessing the browser. But checking this box will require you to restart the browser. So I'll do this at the end. So I'm going to scroll down more. Now we have the security settings here. I will cover them in the next lecture. So right now I'm going to keep scrolling down and I'm going to check block dangerous and deceptive content. And we're also going to make sure that these two boxes are checked to make sure that you get warned when a website tries to force you to download a file. So now that I'm happy with everything, I'm also going to check this box to prevent the accessibility services. Like I said, I think this will make your browser as secure as possible. Some of the settings that we're setting here will break some websites, but we're going for maximum security. And you can also come in and experiment with these, reduce it bit by bit to tailor and to suit your use. So I'm going to check this. It's going to ask me if I want to restart the browser. We're going to say yes, that's fine. And as you can see, the browser is working now again with no problems. Just to double check, we can go to check.torproject.org. And perfect, as you can see, the browser is working. If we click here, we can see our circuit. We're coming out of France. And this is the IP that we appear that we're using. Now that we covered most features of the Tor browser, I want to spend one more lecture talking about the security settings, what do they change, and how these changes affect our privacy and anonymity. We can access the security settings from the shield icon in here beside the onion that we were using in the previous lecture. If this shield is empty, it means the security settings are set to the standard settings. Clicking on it again will show you the security level that you have right now, and as you can see, I'm at standard. If you want to change this, you can click on advanced security settings in here. You can also access this from the options menu like I showed you in the previous lecture. So you just go here, you go to options, and then go to privacy and scroll down to the security levels. So as you can see, we have three main, very simple security levels. Right now, we're set to standard, which is the default. This option will make Tor browser as usable as any other browser, just a little bit slower, but it'll allow you to access everything. All content is available, scripts will not be blocked. So it'll make all websites very nice and usable, but it is not the most secure setting, especially if you're using Tor browser on Windows, which is not a very secure operating system by default. So cranking this up to safer will disable JavaScript on HTTP pages. It will also disable some fonts and other HTML content. So it might make websites function slightly different than normal. They might look slightly different than normal, but it'll be a little bit safer and more private. And then if you crank this up all the way to the safest, it'll disable JavaScript on all pages, even HTTPS pages. Obviously, all traffic will be forced over HTTPS because Tor comes with HTTPS everywhere. Videos will not play by default. A lot of other HTML content will be blocked to make sure that you get the highest levels of security and anonymity out of this browser. Note how changing the security level in here changes the icon on the top right. So in the future, when you're using Tor and you're not sure what level you're in, you can simply look at the icon. If it's full, that means you're in safest. If it's half full, that means you're in safer. And if it's empty, it means you're on standard. You can also just click it to see exactly what security level you're on. So now that I'm happy with my level, I'm going to keep it at the safest and we're going to close this. And I actually want to show you the results of some tests that I did for the three different security levels. So with the basic or standard security level, I use this website right here, and I'm going to include its link in the resources of this lecture. Basically, this website runs a number of tests to see how much information your browser is given about you. So, as you can see with the standard, the browser is blocking ads. It's not blocking invisible trackers. It blocks parties that honor the do not track promise. This is fine. This is good. And finally, it does not protect from fingerprinting. So it's telling us that the browser has a unique fingerprint. And at the bottom here, if you read the statistic, it's telling you that among the more than 200,000 browsers that were tested on this website, our browser appears to be unique. So it can be used to basically identify us. And in here, it's telling us that there are at least 17.84 bits of identifying information that can be gathered by literally analyzing our browser. Now, I've also run the same test after changing my security level to medium. And if you come here, you'll see that my browser is blocking tracking ads. It also has partial protection against blocking invisible trackers, which is again very similar to what we had with the standard. We can also see that our browser blocks acceptable ads. It still blocks parties that honor the do not track. Like I said, this is fine. And finally, our browser still has a unique fingerprint. Now, again, if we click on the show the full details, we can get the statistics. And again, it's saying that our browser is still unique, and the browser is given 17.84 bits of identifying information. Again, it's actually identical to what we got with the standard. Now, finally, I cranked my security all the way to the highest, similar to what I have right now, and I ran the same test in here. And as you can see, the results are much better. So again, browser is blocking all tracking ads. This is fine. It was happening with both standard and medium. Then it's also blocking invisible trackers. It's not accepting the do not track commitment. Like I said, this is fine. This is good. And finally, when it's saying, does your browser protect you from fingerprinting? This is yes. So this is the main thing that's different here. If you look here, and it says no. And in the standard, again, it was saying no. So our browser had a unique fingerprint, whereas right now it has a less unique fingerprint, if you want to think of it that way. So looking at the statistic here, it's saying that only 1 in 114 browsers have the same fingerprint, whereas before we had one unique fingerprint among more than 200,000 browsers. Not only that, but our browser now only gives 6.84 bits of identifying information, whereas as shown before, here and here with the two medium and low security settings, it was given 17.84. So with the high security settings, you're given much less information about your browser and about yourself in general. Now you can actually scroll down here after clicking on more information to see where exactly these bits of information are coming from. So you can see the user agent of the browser is revealing 3.74 bits of information about you. You can see the HTTP header here revealing the language used along with more information. Again, this is accounting for 1.58 bits of info. Going down, we can see the browser plugins are revealing information, the time zone, even the screen size and the color depth. And that's why I said don't maximize the screen, because if you maximize it, this will give the true size of your monitor, again giving even more information. And if you keep scrolling down here, you'll see exactly where each bit of information is coming from, and giving us the total of 17.48 in this example when we had the security at medium. Now you might think, big deal, so what if my browser is given 17.84 bits of information? What does that mean? Well, according to information theory, this information can be added together in order to identify you. In information theory, information is measured in bits, and according to this formula right here, we can calculate the amount of information a certain fact, such as your browser plugins, can reveal about your identity. Like I said, this is measured in bits, and adding all these bits together can be used to identify you. So, at the time of recording this lecture, the population of Earth is around 77 billion. Plug in this value into this equation right here. We can see that in order to identify a person on Earth, all we need is 32.8, so nearly 33 bits of information. So when searching for someone, we start adding the bits of information that we discover about them one by one, such as their language, their location, the browser they use, and so on. Once we get about 33 bits of information, identifying this person will become relatively easy. So, going back to what we had here, you can see the browser in the medium security settings is already revealing 17.8 bits of information about you. So all that's left is only 15 bits of information, and locating you will be relatively easy. Now, granted, some of the information that we see here is incorrect, such as the screen size, because we don't have the screen in full screen, but you get the idea. The more bits that your browser is given about you, the worse, because these bits can be used to locate and identify you. So if we look at the high security, we can see we're only revealing 6.84 bits of information, and as I said before, some of this information is incorrect, so it's a pretty good start. And again, as we go through the course, we're gonna talk about more advanced methods of protecting our security and anonymity. In the previous lecture, we learned what the Tor network is, how it works, and how it's supposed to protect our privacy and anonymity. We also learned how to connect to this network using the Tor browser. So we learned how to properly install it and configure it, and then use it to connect to the network so that we can access websites privately and even access Tor hidden services or onion services, or what most people refer to as the darknet. Now, this is a very easy and simple method, and it's great if you just want to access a website quickly, privately, or if you just want to have a quick look over the darknet. But it's not the best method. The reason for this is because we installed the Tor browser in a normal operating system, such as Windows, Linux, or OS X. These operating systems regularly collect data about the user, about you, to improve user experience, and who knows, maybe for other reasons. Not only that, but most of these operating systems have other programs installed on them which also collect data about you, again, to improve user experience and maybe for other reasons. Now, all of this collected data can be used to de-anonymize you and profile you. Not only that, but all of these programs, all of the programs outside the Tor browser itself, access the internet directly. They do not use the Tor network. The only program that is using the Tor network is the Tor browser. Therefore, when these programs leak information about you, they are leaking also your proper exact location. Not only that, but we also have issues such as DNS leaks, which also would leak information about you. And not to mention that all of these programs and operating systems have a history of being vulnerable to code execution and buffer overflow vulnerabilities. Now, these vulnerabilities can be used to gain full control over your computer, and obviously, when someone has control over your computer, knowing where you are or getting information about you is very, very simple. Therefore, in this section, I want to show you a much better method to protect our anonymity and privacy. This method is a little bit more complex and will require a little bit more work and a little bit more hardware, but don't worry about it. I'm gonna break it into very simple lectures and I'm gonna walk you through the steps one by one, and you're gonna learn exactly how it's gonna work and why it's so much better than just installing the Tor browser on a normal operating system. So in this section, I'm going to show you a better method to improve our anonymity and privacy and to access the darknet. We're going to use an operating system designed to protect our anonymity and privacy. You probably already heard of this. It's called Tails, and it stands for the Incognito Amnesic Live Operating System. It's a Linux-based operating system, and what they mean by live is that you install it on a USB stick or on a DVD, and then you can start it, you can boot it in any computer you want, regardless of what operating system installed on that computer. So it doesn't matter if that computer runs Windows, Linux, OS X. All you need is your USB stick with Tails on it. You stick it in, you boot from it, and you can use Tails from there. The really cool thing about Tails, which is where the incognito comes from, is the fact that all traffic sent from it will go through the Tor network. So not only browsing traffic, not only messaging traffic, anything you do on that system or any program you even install on that system will have to use the Tor network for its traffic. Therefore, it eliminates the fear or the risks of other programs leaking data. Tails also never touches the storage of your computer other than the RAM. So it completely runs using the RAM, which gets cleared once you restart or shut down your computer. Therefore, it leaves no traces on the used computer. And this is where the word amnesic comes from. This means that you can use any computer to use Tails, and once done, there will be no traces of what you did on that computer. So let's say, for argument's sake, you use Tails, which already routes all traffic through the Tor network, but somehow someone managed to identify where you are and de-anonymize you, and they come and they use your computer and they inspect that computer to see what you did on it. If you turn off that computer, there will be no traces of what you did on that computer. Not only that, but there will even be no traces of Tails on that computer. So it will seem as if you did not even run Tails on that computer. So that's why Tails is really cool, because first of all, it's live. Once we have it installed on a USB stick or on a DVD, we can use it from any computer we want. Second, it's incognito, so all traffic sent from Tails will always go through the Tor network. Second, it's incognito, it's private, so anything we do on a Tails system using any program will always go through the Tor network. And finally, it leaves no traces, so once we turn off that computer, if the computer gets inspected, there will be no traces of what we did, and there will even be no traces that Tails was even used on that computer. So, throughout this section, we're going to learn how to properly configure Tails, install it, and use it to access websites privately and anonymously, and access the darknet. Now, we have a number of options when it comes to installing Tails. The easiest is to install it as a virtual machine. With this option, you're gonna first of all install a virtualization software such as VirtualBox or VMware inside your current operating system, whether it's Linux, Windows, or OS X. And then you'll install Tails as a virtual machine using this virtualization software. So you won't have to restart, you won't have to reboot in order to start Tails. You'll be able to start it within your operating system, within Windows or Linux or OS X, and you won't need a USB stick or a DVD to start it. The problems with this is Tails will lose most of its benefits when it's installed like this, because like I said, Tails is designed to be a live operating system. One of the main advantages of it is the fact that it's amnesic, so when you use it on a computer and turn off that computer, it leaves no traces. So even if that computer is inspected, they won't even know that this computer was used to run Tails. When Tails is installed as a virtual machine, it's going to share the resources with your host operating system, with Windows, Linux, or OS X. This means that it will leave traces of it being used. You also won't be able to have a USB stick that you can use on any computer. You'll only be able to use Tails within that computer that you installed the virtual machine on. And because Tails is installed on Windows, Linux, or OS X, like we said before, these operating systems collect data about you. Not only that, they also have a number of programs that collect data about you. All of these programs access the internet directly, not through the Tor network. And all of these programs and operating systems could be vulnerable to code execution or buffer overflows, which can be used to hack into your computer and again from there de-anonymize you. Therefore, installing Tails as a virtual machine is not great because it will basically lose a lot of its advantages and a lot of its great features. The second option, which is better, is to install Tails on a DVD and then use that DVD to boot Tails. So you can use that DVD on any computer regardless of what operating system it runs. All you have to do is just put the DVD in, restart the computer, boot from the DVD, and then you'll be able to use Tails. Now with this, Tails will come with all of its great features. So it'll be live, it'll leave no traces, and it'll be running natively, so it won't be sharing resources. Therefore, you won't really need to worry about leaks or about other programs collecting data or any of the other stuff that we have to take in consideration when we're running the Tor browser or when we're running Tails as a virtual machine. The only disadvantage to this method is the size of the DVD. It's a little bit big, and the installation of Tails will not be persistent. What I mean by that is, if you store any files while you're using Tails, you will lose them once you turn off the computer or restart it. The third option, which is the best in my opinion, is using a USB stick. So this comes with all of the benefits of the DVD. We're going to install Tails on a USB stick, and then all you'll have to do is connect that USB stick to any computer, regardless of what operating system it runs. Restart that computer and you'll be able to boot into Tails. Tails will run in its live mode. Again, it won't use any resources. If you turn off that computer, there will be no traces on that computer. And we can also configure this installation to be persistent. This means that we can actually use part of the USB storage as storage for Tails. So you can actually save files within your current installation within the USB stick, and when you turn off the computer, there'll still be no traces. But even if you go and connect this USB stick to a completely new computer, you will still have your files, you'll be able to boot Tails again and use it normally, and that way you'll have an operating system installed on a really small storage device that you can boot on any computer in the world, regardless of what operating system it runs. And you'll be able to store files, and once you turn off that operating system, once you turn off that computer, there will be no traces on the computer. So even if it gets inspected, there will be no traces of it even running Tails. So you probably guessed by now, installing Tails on a USB stick is the best option, and in the next lecture, I'm going to show you how to do that.
Okay. So now that we understand what Tails is and how it works, in this lecture I want to show you how to install Tails on a USB stick so that we can start Tails on any computer that runs any operating system using this USB stick. Now the instructions that I'm going to show you will work on Windows, Linux, and OS X using the exact same programs and using the exact same steps that I'm going to show you. So I'm going to be doing these steps from a Windows computer, but these steps will work exactly the same from Linux and OS X. If you follow them and you faced any problems, please ask us in the Q&A section and we'll respond to you within 15 hours. So, in order to install Tails on a USB stick, Obviously, the first requirement is you'll need a USB stick. Now this USB stick needs to have a minimum size of 8 gigabytes. The next thing that we'll need is the Tails image. I'm going to include its download link in the resources of this lecture. And finally, you'll need software to flash the Tails USB image to the USB stick in order to have a bootable USB stick with Tails on it. And once we have that, we'll be able to connect that to any computer that runs any operating system and run Tails from that computer. Now the software that we're going to use to flash Tails to the USB stick is called Etcher. And again, I'm going to include its download link in the resources of this lecture. And this application works on Linux, OS X, and Windows. So all you'll have to do is literally just go to the download page right here, and it'll actually automatically detect what operating system you're running. So as you can see right now, it's automatically telling me I'm running Windows. And if I click here, it'll download the Windows version for me. If it's not detecting the right version for you, you can click on this little arrow right here and just download the Etcher version that is compatible with your operating system. Now I already have that downloaded in here, as you can see. So the next thing that I need is the Tails image. And again, as you can see in here, I have it, and I'm going to include its download link. I know right here it says installed from Windows, but like I said, the steps that I'm going to show you will work on all operating system. So ignore this, click on the download in here. Once you do, it'll download it for you. And as you can see, I have it right here in my downloads as well. It should be a file with a .img extension, as you can see here. Once you have these two ready, the last thing that you'll need is the USB stick that you'll flash the Tails image to. And I already have my USB stick connected to my Windows computer. As you can see, I have it in here. It has 28 gigabytes free, but like I said, you only need a minimum of 8 gigabytes. So what we want to do right now is we're going to use this application, Etcher, to flash this Tails image to this USB stick. So the first thing that we'll need to do is to install this application. So I'm going to double click it and we're going to agree. And it's a very, very simple installer. As you can see, it finished installing and it automatically started the application for me. Now the installation of this on Windows and OS X is literally as simple as this. All you'll have to do is download it, double click it, and you'll get this window right here. Now, just before I use this, just to show you, if the installer didn't run the program for you automatically, you should have the icon of it right here on the desktop. All you'll have to do is double click it and it'll start the application for you. Now, using the application is very simple. As you can see, all you'll have to do is first of all select the image that you want to flash to your USB. And like I said, the image for me is this one right here, the one in the downloads. So I'm going to click on select image. And I'm already in my downloads directory, as you can see in here. So I'm just going to click on this image and click on open. We can see it's selected in here. The next thing that you'd want to do is select the USB device that you want to flash the image to. As you can see, it automatically selected my drive E, my device E, which is the device that I have right here. Like I said, this is the correct one. In your case, if this wasn't the correct one, all you'll have to do is just click on change and select the one that you want to flash Tails to. So in my case, this is all perfect. And all I need to do right now is just click on flash to flash the image to the USB stick. But before I do that, I want to verify the integrity of the image that I downloaded. So I want to make sure that this image did not get modified as I downloaded it. And I actually explained how this could happen, how it could get modified as it gets downloaded in the previous section. So if you don't remember that, go back and revise that section. But for now, I'm just going to show you how to verify that this image did not get modified. So I'm going to go back to Firefox. Again, we're still at the download page of Tails. I'm just going to click on I already have it downloaded because I do have it downloaded. And in order to verify the integrity of the image that we downloaded, we're going to use an extension provided to us by the Tails developers. And to install that, all we have to do is just click in here, install Tails verification extension. I'm going to say yes, I want to allow that. And I want to add it to my browser. We're going to say OK. And to use this, all we'll have to do is just click on Verify Tails in here. It's going to ask us to select the image that we downloaded. Again, you want to make sure you go to your downloads and select the image that you downloaded. We're going to click on Open. And it's going to check the integrity of the image for us right now. And perfect. As you can see, it's telling us that the verification is successful. So the image is valid. It did not get modified as we downloaded it. And now we should feel safe flashing it to our USB device so we can use it to boot into Tails and use Tails safely in the future. So, as we seen before, I've already selected the image. I've already selected my USB device that I want to flash Tails to. I'm going to click on Flash to start the flashing process. I'm going to say yes, that's no problem. I give permissions. And right now, you just want to give it its time to flash the image, verify it, and once done, it's going to show us a notification saying the process is finished. Now, like I said, all the steps that I've done so far are identical on all operating systems on Windows, Linux, and OS X. Follow them exactly like I showed you right here. Ignore the fact that it says Windows in this page, and everything will work exactly as I'm showing you. And perfect, as you can see, it's telling us Flash is complete, one successful device, so everything is done with no errors. And right now, Tails is installed on my USB device that is connected to my Windows machine. So right now, I can unplug it from this machine and connect it to any computer, regardless of what operating system it runs on. And I'll be able to use Tails from that computer without leaving any traces on it. And I'll show you how to do that in the next lecture. So now that we have Tails installed on a USB stick, we can use this USB stick to boot into Tails from any computer, regardless of what operating system that computer runs. Whether it runs Windows, Linux, or OS X, it doesn't really matter. All we'll have to do is connect the USB device that we installed Tails to the computer that we want to run Tails on. Start the computer or restart it if it's already running. Then, as it starts, before it even gets into the loading page of Windows or OS X, as soon as it starts, you want to enter the boot menu. Now, this varies depending on the computer that you have. So you'll have to press a button or maybe a combination of buttons in order to enter the boot menu, and this will differ depending on your computer. So here I have a list of the most common brands and the corresponding keys that will allow you to enter the boot menu. For example, if you have an Acer, you should try to press Escape, F12 or F9. So what you do is you connect your USB device to the computer, you start the computer or restart it if it's already running, then keep pressing the Escape button multiple times until you see a boot menu like this one or similar to this one. If you don't see it, if you boot into the default operating system that your computer usually boots in, then you should restart and try the next option in the list. If you tried all of the options and it still doesn't work, then check out the links in the resources of this lecture on more info on how to boot into Tails. And if you can't find any help, then ask us in the Q&A section and we'll respond to you within 15 hours. Once you enter the boot menu, you want to select the option that will allow you to boot from a USB or an external storage. Hit enter and you will see the Tails boot menu as you can see in here. You want to keep this at the first option and hit enter. This will start booting Tails from the USB device that you connected, so give it some time to start the operating system for you. Perfect, so as you can see, we have the welcome window of Tails, and if you want to start straight away, all you'll have to do is just click on Start Tails. But before doing that, let's take a quick look on the options that we can modify in here. So first of all, you can modify the language, which is set to English United States by default, and I'm going to keep it that way. The keyboard is also set to English US. Now you might want to modify this if you have a different layout, but I think it's a good idea to keep it at the default settings because that'll give even less info. Now I know I said that Tails won't leave any traces, but I just like to keep things to the default in here. Again, we have the calendar format. I'm going to keep that to the default. And at the bottom here, we have additional settings or advanced settings. So I'm going to click on the plus to show you the settings that you can set here. And the first thing that you can set is an administration password. So by default, Tails disables the admin account. So as you can see, it's set to off. So when you go and use the operating system, there will be no admin. The reason it's configured this way so that if someone manages to hack into your system, they won't have admin permissions, so they won't be able to change core functions or core settings within the operating system, and they also won't be able to install any applications. If for some reason you needed to modify something that requires admin settings, or if you wanted to install programs on the system, then you can enable the admin account from here. You can click on this and you set a password, you repeat the password and click on add to add it. Keep in mind that this account will only be added for this current session. Once you restart the computer, the admin account will disappear along with all the modifications that you make to Tails, because like we said, Tails is a live amnesic operating system that completely wipes everything that you do every time you restart the computer. So when you create an admin account in here and log in, this admin account will disappear and will not even exist once you restart the computer. So if you want to use an admin account again, the next time you use the system, you're going to have to come to this menu and create it. But for now, I don't really want to do anything that requires admin privileges and I don't want to install any programs. So I'm going to click on back and I'm going to keep this to off. The next setting that you might want to modify is the Mac spoofing. And as you can see, this is set to on by default. Now, MAC address is a unique and permanent address that is assigned to every network device. It gets assigned to it at the time the device is manufactured and it never changes. So for example, if I have an Ethernet card or a Wi-Fi card and unplug it from my computer and connect it to a completely different computer, that card will still have the same MAC address. Now this MAC address is only visible within your network. It's not visible on the internet. As we know, Tails automatically routes all internet traffic through Tor, so we're not really concerned about stuff that happens on the internet. It should hide our identity automatically. But within the network, the MAC address is visible and the MAC address is unique and permanent, like I said, and therefore it can be used to identify you. So this option by default is set to on, and I'm going to keep it to on so that Tails will also change my MAC address every time I start it. Therefore, my MAC address will be changed, so I'll be hidden or anonymous within the network, and when I connect to the internet, all the traffic will automatically go through the Tor network, and therefore it will improve my anonymity. The only time you might want to set this to off is if the network that you're connecting to uses a whitelist. So if it only allows specific MAC addresses to connect to it, and if your MAC address is one of these whitelisted MAC addresses, that's the only time that you might want to set this to off. Otherwise, it's better to keep it at on so your identity is hidden within your network. Now the third option here, the network connection, and this is set to direct, the default. Like I said, this means that all traffic sent from any application on Tails will have to go through the Tor network, so this is perfect. But if we click on it, you'll also see we have two other options. The second option is to configure a Tor bridge or a proxy, and we already discussed what bridges, pluggable transports, and proxies are previously in the course. We discussed how to get them and why you might want to use them. So I'm not going to really talk about it right now. If you don't remember what they are, please go back and revise the previous section. I will, however, show you how to use a bridge or a pluggable transport with Tails, because we only covered how to do it with Tor browser. So I'll show you how to do this with Tails in a future lecture. For now, we're keeping this to the default. Obviously, the third option here will disable all networking. We don't want to this right now. So we're keeping everything here to the default, and I'm going to click on cancel. And we're back to the welcome menu, in which we can just shut down or start Tails. So now that we're happy with all of these settings, I'm going to click on Start Tails to start the operating system. And perfect, as you can see, we get a nice and simple desktop. I know it might look strange to you, especially if you're used to Windows, but don't worry, it's actually very simple to use. And it's very similar to a lot of operating systems, even though it looks a little bit different. In the next lecture, we'll have a basic overview on this operating system, its menus, how to use it, how to interact with it, just so that we get more comfortable with using it. Right, so now that we have Tails installed and we learned how to boot into it, in this lecture, I want to give you a basic overview on this operating system. So first of all, on the top here, we have the status bar. On the top left, we have the applications menu, which contains a number of applications categorized nicely in terms of what they can be used for. In the favorites, you have your programs that you'll probably be using most of the time. We have the Tor browser, which we already know what it is and what it can be used for. We have Thunderbird, which is an email client. We have Pigeon, which is an instant messenger that can be configured to not keep any traces of you. We have a password manager, and we have a terminal which we can use to run Linux commands. You can actually go through all of these and get familiar with all of the offered programs. On the internet here, again, we have some of the programs that I just showed you. We also have Electrum, which is a Bitcoin wallet. You have Office programs, LibreOffice, that you can use instead of Microsoft Office Word. You have media programs and all the usual stuff that you see on different operating systems. Now, don't worry about all of the strange programs that you don't know in here. We will be using a lot of them as we go through the course. So right now, I'm just giving you a basic overview of the whole operating system. That's why I'm not going to be running any of them. Beside the applications, we have the Places menu, which will allow you to access different folders in your file system. So as you can see, if we click on the home, we will actually get a file manager in the home directory. As you can see in here, you'll get to this exact location if you just double click the home icon in here. So again, as you can see here, we have a number of files similar to what you get with Windows. So we have documents, downloads, music, pictures, and so on. Again, you can access each of these directories individually by going to Places and just clicking on the directory that you want to access. Now, it goes without saying, you can also navigate to this through this menu. You can double click a directory to open it and double click a file to execute it or to open it with its default program. Right click to create new directories, to copy and paste, to get properties. So it's all intuitive and it's all very, very similar to what you get with other operating systems. Now, another really cool feature with Tails is the fact that it supports multiple desktops. So right now we have a workspace right here, and let's say this workspace gets cluttered with a lot of applications, a lot of open windows. So let's open another window, for example, on documents, and let's say you also have a browser and you want to do more stuff. Then you can actually press Ctrl, Alt, and down to go to a new workspace. And right here, I have an empty workspace which I can do more work in. So again, I can go to Places and open something else here. And I can do some work. For example, I can have my web browser in here and then Ctrl, Alt, up to go to the first workspace, this one with the windows already open in here. Not only that, but you can also press the Windows button or the left command and S on OS X. This will reveal the activity menu, which will first of all show you the open windows in the current workspace. It will also show you the available workspaces here on the right. So I can click in here to go to the second workspace where I had my music open. Again, click on this one to go to the first one, and then click on the last one to go to the last workspace. So instead of pressing Ctrl, Alt, up and down, you can navigate through the workspaces like this, and also you can see the running applications. Not only that, but you can also see your favorite applications in here in a nice dock on the left, and you can press on this icon right here to get a list of all the applications installed on Tails. So right here we have all of the other applications that we were navigating to through the applications menu. And if you can't find your application here, or if you want to access it quickly, you can literally just type its name using the keyboard. So if I just type Tor, it will bring me all of the applications that have the word Tor in them. So this is really, really handy. Again, this is the activity view, and you can access this by pressing the Windows button on Windows computers or the right CMD and S on OS X computers. I'm going to press Escape to exit this, and we're back at the main desktop. Now, I think this is enough for this lecture. In the next lecture, I'll continue covering the basics of Tails. I'll show you how to see the notifications, how to edit the preferences, how to connect to networks, and so on. Okay, so we're going to pick up from where we left in the previous lecture. And in this lecture, I'm going to continue showing you the basics of Tails, how to see the notifications, how to edit some of the settings, connect to networks, and so on. And going back to the status bar, we have the time and the date in here. Now, if you also click on this, you'll get a nice calendar on the right, and you'll also get the notification menu in here, in which you'll see a list of system notifications. Continuing to the right, we have the onion icon right here, which shows us the status of the Tor circuit. Now, if you're not connected right now, you should see an X beside it. Don't worry about that. We'll talk about this in a minute. Beside it, you have the accessibility options. Again, options to zoom in, zoom out, increase contrast, stuff that will just make it easier to use the system. We have the language selector in here. You can change the language if you wanted to. You can click on show keyboard layouts if you wanted to add more languages. Now going to the last icon in here, you can see the first thing we have is the volume controls. You can also see it saying wired connected. This is because I have an Ethernet cable connected to this computer. That's why how this computer is getting internet connection. This is the easiest way to get internet connection on Tails. If you don't have an Ethernet cable, you can also connect using Wi-Fi. Now keep in mind, you'll only see this option, the Wi-Fi option, if Tails supports your Wi-Fi card or if it supports the wireless adapter that is connected to this computer. For example, it actually was not able to detect my built-in Wi-Fi card. And the only reason why I have this option here, because I have an external USB wireless adapter connected to this computer. So if you can't see the Wi-Fi option here, it's probably because the Wi-Fi card used in your computer is not supported by Tails. I'll include a list of all Wi-Fi adapters supported by Tails in the resources of this lecture. Once you see this option, connecting to a Wi-Fi network is trivial. All you have to do is just click here, click on select network, select the network that you want to connect to, put the password, and you'll be able to connect. And finally, you can also see the power settings in here of this computer. At the bottom here, we have a number of icons. The first one here will take you into the preferences. So I'll just click on it quickly to show you. In here, you'll be able to change settings about the operating system, such as the background, display, privacy settings, language settings, and so on. Keep in mind, right now our installation is not persistent, so anything you do will be lost as soon as you turn off this machine or restart it. We will talk about persistence later on in the course, so you should keep this in mind when changing settings. Going back to the top right icon, we also have the lock icon in here, which will lock this computer. Now, keep in mind, we started this session without a password. Remember, the admin password was disabled. Therefore, when you click on this, it'll actually ask you for a password to set so that you can use that password to unlock the screen again. So let's say I put a password here and then lock the screen. Now, when I come back, hit enter, and to log in now to my session, I'll have to use the password that I just set. Keep in mind, this is not an admin password. This is literally a password that we temporarily set when we lock the screen. You can also pause the current session. You can restart or shut down using these buttons. Now, the really cool thing about Tails, when you click on shutdown or when you just disconnect the USB device that contains Tails, it will automatically shut down securely. What I mean by that is, as we mentioned before, Tails never uses the built-in storage of the computer that you run it on. It runs completely from RAM. This means that once you turn it off, it leaves no traces because RAM gets cleared every time you turn off the computer or restart it. Now, this is all good, but it actually takes a number of minutes, sometimes even up to 4 or 5 minutes, to completely clear the RAM. Therefore, if you just shut down the computer and someone grabs your computer, freezes the RAM, this RAM will still contain information about your session, and that way they'll be able to store your RAM for a long period of time, as long as it's frozen, and then they'll be able to inspect it and get information about what you did while you were using Tails. Therefore, when you actually click on shutdown or disconnect the USB device, Tails will perform a secure shutdown in which it'll wipe the RAM before it completely shuts down. Therefore, if someone gets your computer and freezes the RAM, there will still be no information about you because Tails completely and properly cleared the RAM before it went off, before it shut down. So this is a really cool feature to prevent cold boot attacks. So, as we know from the previous lectures, Tails is a live and an amnesic operating system. What we mean by this is it leaves no traces on the computer that it gets used on, and it does this by never using the internal storage. It runs completely from the RAM, which is securely wiped once you turn off or restart the computer. Then, when that computer boots, it will boot into its default operating system. This system will work exactly the same way that it was working before, and even if the whole computer gets inspected, there will be no traces of what you've done, and there will even be no traces of Tails being used on that computer. Now, this is a great feature that serves the main purpose of Tails, so it improves security because even if someone manages to hack into that computer, and install malware or change the settings to compromise your privacy and anonymity, once you restart and boot into Tails, everything will be removed because nothing can be stored on that system. Not only that, but if you are dealing with sensitive files, you can do so without worrying about someone being able to recover these files because they will never be stored on the system. So these are great features that serve the main purpose of Tails, which is an operating system that is designed to improve our anonymity and privacy. But this feature is also a little bit inconvenient because, like we said, we cannot store anything on the system. So not only that we can't store files and passwords or keys, which is something that we might want to do, we also can't save any changes we make to any of the programs. For example, if you configure the mail client, or if you change the Tor settings, or even if you connect to a Wi-Fi network, all of these settings will be removed and forgotten once you restart or boot into Tails again. So every time you boot in Tails, you'll have to go and connect to the network that you always connect to. You'll have to go and change the Tor browser settings if you change them. If you set up a mail client, you'll have to go and set it up again, which can be a bit troublesome and take a bit of time. Now, the solution to this is to enable persistence on Tails. Persistence allows us to store files, passwords, keys, or program settings that we modify. It does this by encrypting whatever that's left on the USB flash drive, so it still doesn't use the internal storage. The internal storage will still remain untouched, and it will only rely on the space remaining on that USB stick. It will encrypt that space to improve its security. And then when you log in, you will have two options. You can log in with the live default option where nothing is stored, or you can unlock the persistent storage where you'll be able to store files in a specific directory, install programs, edit settings, and everything will be stored like any other operating system. So with this, you'll be able to store files, passwords, keys, like I said. You'll be able to modify settings. So if you connect to a network or if you log into a mail client, all of these settings will be stored. So when you log in again, you won't have to do them again. You'll also be able to install programs or browser plugins and so on. Now, the last two benefits are in red for a reason, because you need to be careful when you're doing these things. Because you need to keep in mind that Tails was made with security in mind, so all of the programs that come pre-installed in it are configured in a way to protect your anonymity and privacy. Therefore, when you modify these settings, or if you install more programs, these new programs or these modified settings might compromise your anonymity and privacy. So only install programs or modify settings if you know what you're doing. Not only that, but Tor and Tails work best when it is hard to distinguish between people that are using these systems. Therefore, when you modify settings or install extra programs, you're becoming more unique. Therefore, it would be easier to detect you because you're more distinguishable than other users, than the people that are using Tor and Tails with the default settings. So, with keeping all of this in mind, in the next lecture, I'm going to show you how to enable persistence on Tails. Okay, so now that we understand why Tails is not persistent by default, why you might want to use persistence, and the warnings and the things that you want to keep in mind while using persistence, let's go ahead and see how to enable it and how to use it. So I have Tails right here, and to enable persistent storage, we're going to go to Applications, Tails, and we're going to click on Configure Persistent Volume. This will open the persistence wizard. It will give you a warning. Pretty much all the stuff that I mentioned in the previous lecture. It will also tell us how much of the memory stick will be used to create the persistent storage. So I have a 32 gigabyte USB flash drive. As you can see, only 20 of this will be used to create the persistent volume. It's also asking me for a passphrase. This is the passphrase that will be used to encrypt this storage. Make sure you pick something that is difficult to guess and difficult to brute force, but make sure it's also easy for you to remember. So I'm gonna put my passphrase. I'm gonna verify it in the second box. And once you're ready, you can click on Create to create the persistent storage. And once done, you will get a menu like this one right here, which will ask you to what exactly you want to save in this persistent volume. So by default, you can see personal data is set to on. And what this will do, it'll actually create a directory that you'll be able to see here in places called persistent. And anything you store in this directory will be persistent and will not be removed when you restart or shut down Tails. So right now you can see I don't have it because persistence is not enabled. Once I restart, keeping this on, you'll see I'll have a new directory in here which I can use to store my files. Now, you can tick any of these as you wish. For example, if you want to store your bookmarks, you want to tick this. If you want to store the settings you set for your network connections, you want to tick this. So for example, if you connect to a Wi-Fi network, it'll remember the password, because otherwise, with the installation that we have right now, the Wi-Fi settings are not stored. So you'll have to connect to the same network if you are connecting to the same network every time you boot into Tails. The additional software will not remove any software you install on Tails. Now you want to be careful about this because, like I said, if hackers install software on your installation, then that software will also be persistent. So make sure you only turn this on if you know what you're doing. You have other options, for example, for printers, for Thunderbird, which is a mail client, GNU-PG, the Electron Bitcoin wallet. And basically turning on persistence for any of these programs will store anything you do within these programs and store all the settings. So I'm actually going to turn it on for Electron because I might want to store some keys in this Bitcoin wallet and I wouldn't want them to be deleted. I'm going to do the same with GNU-PG because again, I might have some passwords in here or keys that I don't want them to be deleted when I restart or boot into Tails again. I'll do this for Thunderbird as well, and for Pigeon, just in case I actually go ahead and modify the settings of any of these programs or store something in these programs. I don't want it to be deleted. I want it to be stored every time I boot into Tails. So like I said, go through these options, see which programs you might want to use, and turn them on accordingly. Now don't worry about these programs that I didn't really speak about. We will go through a lot of these programs as we go through the course, and you'll learn exactly what they can be used for. So once you're done with selecting the files and the settings that you don't want them to be removed or reset, click on Save, and that's it, we're done. Now, the persistent volume will not actually be active or usable until we restart Tails. So I'm going to close this and I'm going to restart. And now when you get to the welcome wizard of Tails, you'll see we have an extra option in here. So right now we can put the passphrase here and unlock the persistent storage, or just click on Start Tails to start it normally without unlocking the storage, so it'll work exactly like we've seen in previous lectures with no persistence at all. So right now I actually want to unlock the persistent storage, so I'm going to put the passphrase that I created when I created the storage, and I'm going to click on Unlock. As you can see, it's telling us that the storage is unlocked. And now if I start Tails, I should have access to this persistent storage and be able to store files in my persistent directory, and all the settings that I'm gonna change within the programs that I picked will still be stored even if I restart Tails. So if I go to Places now, you will see we have an extra directory called persistent, and anything we place in this directory will not be removed when we restart Tails. So let's try this. I'm going to right click and create a new folder, and let's call this persistence test. So we have this new folder here, and I'm going to create a new folder on the desktop, and we'll call this test2. So when I restart Tails now, test2 should be removed because it's stored outside of the persistent storage, and persistent test in here should still be here. I'm just going to do this to help you understand how to use this persistent storage. So you can put any files that you don't want them to be removed in here, and then anything you store outside of this directory will be securely wiped every time you turn off Tails. I'm also going to go ahead and connect to a Wi-Fi network because remember, when I configured persistence, I chose to store the network settings. So any settings I make should be persistent and should not be reset when I restart Tails. So I'm going to go to my Wi-Fi settings and I'm going to click on select network. I'm going to select my network and connect, put the password, connect. And as you can see, the icon is restored. It's telling me Tor is ready. And if I look in here, wire disconnected and Wi-Fi is connected to my network too. So now when I restart, the test in here, the test directory should be removed because it's outside of the persistent storage. The persistent test here should still be here because it's inside the persistent storage. And I should automatically connect to this network because I configured my network settings to be persistent. So this will go to show you that all of the programs that I turned on the persistent option to will store any settings or anything that I do in them. So let's go ahead and restart. Okay, so we're back at the login screen. Again, as usual, I'm going to put my password in here to unlock the persistent volume. Unlock. That's unlocked. Perfect. Now we're going to start it. And perfect. As you can see, first of all, we don't see the test directory that we created here. This is good because we created it outside of our persistent volume. Now let's go to places and go to our persistent volume. And as you can see, we do have the persistent directory right here. This is perfect. This should still be here because we created this inside the persistent volume. So if you stored any other files in here, you'll always be able to see them when you start Tails. Let's go ahead and check if we automatically connected to our Wi-Fi network. And perfect. As you can see, it automatically connected. Like I said, without persistent, you would have had to connect to your target network every time you start Tails because the network settings won't be stored. This is just an example of all the other applications which we enabled persistent for. So right now I can use any of the other applications that I enabled persistence for, and anything I do on these applications will be stored even after I restart Tails. So this is perfect. Right now I have the best of both worlds. I can store files in a specific encrypted volume. I can also store some settings that I specifically chose, and everything else will be securely wiped every time I turn off the machine. Not only that, but I still have the option of using Tails with no persistence, exactly as we seen in previous lectures. All I have to do is, let me restart, and all I have to do is basically just start Tails without unlocking the persistent volume. So right here, all I have to do is literally ignore this and just click on Start Tails. And this will start it for me in the normal mode without mounting the persistent volume, so I won't even have access to the files stored in the persistent directory. So now even if I go to places, I don't even have a directory called persistent. And just to confirm, if I go to my network settings, you'll see that it's detecting that I have a Wi-Fi adapter but it's not automatically connecting to my network, even though that we can detect the network, because the network settings are not accessible because we started Tails without mounting the persistent volume. So right now we have an installation of Tails on a USB stick that we can use as an amnesic live operating system where nothing gets stored once you shut it down. And if we wanted to, we can unlock the persistent volume, which will allow us to store files in a specific location. And it will also allow us to restore the settings for the programs that we enabled persistence for. And keep in mind, all of these settings and all of these files are stored in an encrypted volume that is encrypted with a passphrase that we pick ourselves. Now, if for any reason you wanted to delete the persistent storage, all you have to do is go to Applications again, to Tails, and click on Delete Persistent Volume. This will ask you if you really want to do this. I'm going to say yes, delete it for me, please. And that's it. Now it's deleted. So now if you restart, you won't even get the option to unlock the persistence volume because it is deleted. In the previous section, we learned how your internet service provider or your network admin could block you from accessing Tor. We also learned that we can use Tor bridges or pluggable transports to bypass this and access the Tor network. You might also want to use Tor bridges or pluggable transports even if you're not being blocked from using Tor, if you just want to hide the fact that you are using Tor. Because as I mentioned previously, when you use Tor, your internet service provider or your network admin or anyone who's intercepting connections, they'll be able to know that you're using Tor. They won't see the websites that you're accessing, but they will be able to know that you're using the Tor network. Therefore, if this is a problem, if this is something that you want to hide, then you might want to use Tor bridges or pluggable transports. Now, in the previous section, I showed you how to do this if you're using the Tor browser. But right now, we're not using the Tor browser anymore, we're using Tails, and like I said, Tails is configured to route all traffic through the Tor network, not only browsing traffic. Therefore, if you want to use a pluggable transport or a bridge, you need to configure the whole distribution to route all traffic through this pluggable transport or through this bridge. So, in this lecture, I'm not going to talk a lot about how bridges work and how they'd allow us to bypass censorship and use Tor even if it's blocked. I covered this in details previously, so if you don't remember that, please go back and revise that lecture. What I will cover here, though, is how to configure Tails to use bridges or pluggable transports. So, right now, I have Tails booted up right here. And as you can see, I am able to connect to the Tor network. So I already went to check.torproject.org and everything, as you can see, is working as expected. We can also see here the onion icon does not have an X. So it means that I'm properly connected to the Tor network. And if I click on this to open the Tor circuits, you'll see we'll get information about the Tor circuits right here. So everything is working as expected. But if this did not work for you, so if after loading Tails and after connecting to a network, you're still not able to connect to the Tor network, if you get an error, if the onion here has an X, then it is possible that your network administrator or your internet service provider is preventing you from accessing Tor. Or if you just want to hide the fact that you're using Tor, then we can configure Tails to use a pluggable transport or a bridge. To do this, we'll first need to restart the distribution because we already booted, and we need to actually tell it that I want to use a pluggable transport as soon as it starts. So here at this welcome message, you want to click on the plus here under the additional settings. And we want to click on the network connection. And I'm going to choose the second option in here, configure a Tor bridge or a local proxy.
I'm going to click on add, and then I will start Tails. So give it its time to load up the operating system, and once it loads, it'll show you this window right here, which you can use to configure Tails to connect to the Tor network using a bridge or a proxy. Now, if you notice here on the top right, you can see there is an X beside the onion, meaning that we're still not connected to the Tor network. And if I go ahead now and run my browser, I won't even be able to access the internet. So I'm offline right now. So I'm going to click on configure to configure the network settings. And I'm going to check this option in here. Tor is censored in my country. And then I'm going to paste the bridges or the pluggable transports that I have in here. Now, I covered multiple methods on how you can get bridges and pluggable transports using emails or using different domains. So I'm not going to cover that here. If you don't remember how to get them, please go back and revise that lecture in the previous section. Right now, I actually have my pluggable transport that I want to use on a USB stick. So I'm going to connect that to Tails, and this will also be a good example for you to see how you can interact with the file system. So I'm just going to go to my home directory just to open the file browser, and we can see my removable disk right here. I'm going to click it, and I have my bridges in here in this text file, bridges.txt. As usual, double click to open a normal text file. It'll open in the default text editor. I'm going to select everything and copy it. And then I'm going to go back to my configuration window and paste it here. So now we're done, and all I have to do is click on connect to connect using this pluggable transport. Just a quick option that I want to highlight in here as well is the proxy option. You can tick this box if you want to use a proxy. But right now, all I want to do is just use this pluggable transport, which I already pasted. So I'm just going to click on connect to use it. And right now, Tails is going to reconfigure my network settings so that all traffic within this operating system gets routed through this bridge, through this pluggable transport, and then through the Tor network. And as you can see right now, it's telling me that Tor is ready, and now we are connected to the internet through this bridge and through this pluggable transport. Again, you can see the X has disappeared here from the onion, which means that I am connected. And just to verify this, I'm going to launch the Tor browser from applications. And we're going to go to check.torproject.org. And perfect, as you can see, it's telling us that we are using the Tor network and our IP appears to be this IP right here. So everything is configured properly and we have internet access through the Tor network and through this pluggable transport. As I mentioned, this can be very helpful if your internet service provider or your admin is preventing you from accessing the Tor network, or if you don't want anyone to know that you're accessing the Tor network, if you want to hide the fact that you are using the Tor network. Now that we have Tails installed, configured with persistence, and we learned the basics on how to use it and interact with it, in this lecture, I want to talk about the Tor browser that comes with Tails and highlight a major restriction that Tails enforces over the Tor web browser. So going to the applications, you can see we have in our favorites the Tor browser. As you know, we've actually covered this browser before and we spoke about how it works, and we learned how to install it on different operating systems and how to properly configure it for optimum security and anonymity. So what we have here is an identical version to the browser that I showed you before. You can go to check.torproject.org to make sure that everything is connected, but we already know that everything is working because, as I mentioned before, all connections sent from Tails, from the whole operating system, go through the Tor network, and we can confirm this from this onion. But if you really just want to double check, you can just go to check.torproject.org, And as you can see, it's telling us that everything is working, everything's configured properly, and we are using the Tor network. Now, as I showed you before, you can go to the onion icon in here to request a new identity, change security settings, or check for updates. You can check your Tor circuit from here, and you can also modify the options from here. Now, like I said, I spent multiple lectures explaining what the circuit is, what do we mean by a new identity and a new circuit, how to modify the security options for optimum security and anonymity. So I'm not gonna talk about that now. You can go ahead and do everything that I showed you previously, because the steps to do it here are identical to the steps you'd follow with any Tor browser, regardless of what operating system it's installed on. So I'm just gonna go and change my security settings and crank that to the safest, and we are good to go. I'm also gonna keep the screen at this size because, as I mentioned before, you don't want to use the screen in full screen because that'll give information about your monitor. Also, keeping it at the default size is always a good idea because that makes you less unique, and like I said, Tor and Tails work best by making it hard to distinguish the users that use these services. So when we keep the window at the default size, it's harder to distinguish between me and other users. What I want to cover though in this lecture is an extra feature that Tails implements, or an extra restriction that Tails applies to the Tor browser. To improve the security of the whole browser, so that it's more difficult to exploit and use to gain access to our system, Tails implement kernel-level restrictions over the Tor browser so that it cannot access any folder, any location within the file system except for one folder. Therefore, if we wanted to download something from the browser or upload something, we can only do that from one folder in our file system. So if we look at the places here, you'll see we have a folder called Tor browser, and we have a folder called Tor browser persistent because I enabled persistence on my installation. You will only see this if you enable persistence. And as the names suggest, the Tor browser folder is non-persistent, so anything you place in this folder will be deleted once you shut down or restart Tails. The persistent folder is persistent, so if you store anything in that folder, it will not be deleted when you restart or shut down Tails. Now, these two folders or directories are the only folders that the Tor browser has access to. So if, for example, you wanted to save this image, so you're going to go right click and save image as. I'm just giving this as an example, but this applies for anything that you want to save. You'll see we're automatically in Amnesia, which is the name of our user, Tor browser. So this is the path that we are in. And if we wanted to change this path to save this somewhere else, for example, if you click on desktop, you'll see we'll get an error message saying permission denied. You'll get this error message if you click on any other directory in your computer except the Tor browser directories, the Tor browser normal and the Tor browser persistent. So let's store this, for example, in the Tor browser in here, and it's just going to be called Tor on PNG. I'm going to save it. And now if I go to places, Tor browser, you'll see we have the image here. So it's just like any other directory. The only thing is this is the only directory that is visible to the Tor browser. So the same thing applies if you wanted to upload a file and send it anywhere. You won't be able to upload any files unless they are stored in Tor browser or in the Tor browser persistent. So if you had something on desktop or in music or in the documents, you'll have to first copy it to one of these directories, either to Tor browser or Tor browser persistent, and then upload it from there. So if I just go to tinyupload.com, this is a file sharing service. It's by no means anonymous or private. I'm just using it as an example to show you how the browser only have access to specific directories. So if I click on browse to select the file that I want to upload, Again, you can see by default I'm in the Tor browser directory, which I can upload files from with no problems. But if I try to go to my documents, again, I'll get the same error. Downloads or any other directory, I'll always be getting this error. Therefore, if you want to upload something, you'll have to copy it, paste it in your Tor browser or your Tor browser persistent if you have one, if you enabled persistence. And then from here, you can just select it, open it, and it'll upload just like any other operating system. Now, like I said, this is not a private or an anonymous way of uploading files. I will show you a better way later on in the course. So that's it for this lecture. We've already used the Tor browser and we are already a little bit familiar with it. I just wanted to highlight the restriction that Tails enforces on the Tor browser. And in the next lecture, I'm going to introduce you to the insecure browser that comes with Tails. Previously, we learned how to install and use the Tor browser, and in the previous lecture, I showed you how to use it with Tails. Now, this will be the browser that we'll use most of the time to protect our anonymity and privacy and to access the hidden services or the darknet websites. In this lecture, though, I want to show you another browser that comes with Tails, which is the insecure or unsafe browser. Now you might think, why would I want to use an insecure or unsafe browser? See, as we mentioned before, unlike installing the Tor browser on other operating systems such as Windows, OS X or Linux, where only traffic going through the Tor browser will go through the Tor network and all other traffic will literally go directly to the internet, on Tails, all traffic is forced to go through the Tor network. So regardless of what application generates this traffic, even if it's a system update, even if it's some malware that got downloaded and got executed on your system, it will always be forced to go through the Tor network. Now, like we said, this is great because it prevents leaks, it improves our security and anonymity because no other programs can access the internet directly. Therefore, all of our connections are always going through the Tor network. So this is really good and an amazing feature of Tails. The only problem is sometimes you actually need to access the internet directly, or you need a browser that will not use the Tor network. For example, if you're trying to connect to a captive portal. What I mean by a captive portal is a network similar to the networks you see in airports, universities, or coffee shops, where once you connect, you have to log in or you have to authenticate. Now, usually the authentication is done using a web browser. Any web browser will work, but the Tor browser will not work because, as we know, Tor browser will route traffic through the Tor network, and therefore you won't be able to authenticate with the local network. Now, if you were running the Tor browser from a normal operating system like Linux, Windows, or OS X, the solution to this is easy. You just go to one of your other browsers, and like I said, these will be accessing the internet directly, so that will be fine. The problem is, as we mentioned, in Tails, everything is forced to go through the Tor network. So even if you had another web browser, it'll be forced to go through the Tor network, and therefore you still won't be able to authenticate with these networks. Therefore, for this reason, and for any other rare cases where you would actually need to access the internet directly, Tails comes with another web browser. It's actually called the unsafe browser, because this is the only application on the operating system that can make direct connection to the internet outside of the Tor network. So you want to be very careful when you're using this, and you want to make sure that you know what you're doing, because it is not using the Tor network. It's going to be accessing the internet directly, revealing your location, your IP, and so on. So right here, I'm back at Tails. And if I go to my Wi-Fi networks and look for a Wi-Fi network, you can see that there is a Starbucks Wi-Fi around me. So this is a coffee shop network, and this is an example of a network that uses a captive portal. Like I said, these networks are commonly used in coffee shops, colleges,
hotels, or airports. So it's all the same scenario. Once you connect, so I'm going to click on it and connect, you'll see that I will be able to connect to the network, but I won't have internet access. So if I go up here, you can see that I am connected to the network, but as you can see, the Tor icon right here still has an X beside it, so I'm not able to connect to the Tor network. And even if I go and run my Tor browser, as you can see, it's telling me that the Tor network is not ready yet. So the browser will probably not be able to access the internet. And even if you wait for this, it's not going to connect. So I'm going to click on Start anyway. And as you can see, nothing will load. We'll be stuck at the welcome page. And even if you try to go to any website, it's not gonna load because the captive portal needs you to first authenticate with it. So this network is configured in a way that the users have to authenticate using a web interface first. See, usually on normal operating systems, when you launch your browser, you'll see the authentication web interface, the authentication page by default. But because Tails is configured so that it routes all traffic through the Tor network, the web interface or the authentication page is inaccessible to us. Therefore, the only way around this is to go ahead and use the insecure browser which accesses the internet directly. To do this, we're going to go to Applications, Internet, and we're going to click on the unsafe browser. It's going to show us a warning telling us that this will access the internet directly. You will not be anonymous, so be careful. I've explained all this to you, so we're going to click on Launch. And as you can see, we get another web browser with a big warning again about the implications of using this browser. But we know what we're doing, so that's fine. And now you can use this browser similar to the way that you use any web browser on any other operating system that does not force traffic through the Tor network. So you probably already connected to such networks in hotels or airports. Once you connect to it, you open your web browser and you can go to any website you want. For example, I'm going to go to duckduckgo.com. And as you can see, the website that I want will not load, but I will get the page for the captive portal. Now, some captive portals will ask you for a name and email. They might ask for your phone number. You can fill this with any information you want. You don't have to give valid information. And once you do this, you can click on Connect. In my case, I can just connect without filling any information. And as you can see, I'll get redirected to the Starbucks website. So I got authenticated with the network with the captive portal now. So now Tails should be able to establish a connection with the Tor network, and the Tor browser should work for us as well. And perfect, as you can see, we get a notification telling us now we can access the internet. On the top right, the X has disappeared. So if I go to check.torproject.org, as you can see, we get a nice message telling us that we are connected properly to the Tor network, our IP is changed, and everything is working as expected. So now we don't need the unsafe browser anymore. We can close it because we have authenticated with the target network properly, and the network is going to allow us to access the internet, and then Tails is going to force all traffic through the Tor network, which is exactly what we want, which will improve our privacy and anonymity. In the previous section, we learned what is a VPN, its benefits, and how to connect to it before connecting to the Tor network. This was very easy, as all we had to do is download the client that's compatible with our operating system. Most VPN providers offer a Linux client, and Tails is a Linux distro. Unfortunately though, normal Linux clients will not work with Tails because of the restrictions that Tails apply on the network connections. Therefore, connecting to a VPN from Tails can be a bit tricky, and that's why I want to spend this lecture and the next lecture showing you how to connect to a VPN from Tails. Now keep in mind, you don't have to use a VPN with Tails. This is an optional step, and there is a big debate whether you should use a VPN or not with Tails. Because as we know, Tails automatically forces all traffic to go through Tor, so by default, it is more anonymous and more private than normal operating systems. So skip this lecture and the next lecture if you don't want to use a VPN, and only watch it if you actually do want to use a VPN with Tails. Now, just a quick recap. As we learned before, usually when you access a server or anything on the internet, you send the request directly to that server. When you use a VPN, you create an encrypted tunnel to the VPN server. So if you're trying to go to google.com, only the VPN knows that you're going to google.com. The traffic between you and the VPN will be fully encrypted, so it's useless to anybody that intercepts it. And then once the VPN gets the request, it'll forward it to the actual server that you need to go to, for example, google.com. Now, this doesn't have to be google.com. It can be any website or any server or on the internet, or you can even send that request to the Tor network and access a darknet or a hidden service within the network, or go to the internet after that, again improving your privacy and anonymity. Now, because of the way the data is sent in here in an encrypted manner, this adds an extra layer of encryption. Therefore, it improves your privacy and anonymity. If your data gets intercepted by hackers or by your network admin or by your internet service provider, it'll be gibberish, it'll be useless, so they won't be able to stop you or prevent you from accessing websites, and they won't be able to gather information about you. So it'll allow you to bypass censorship, protect you from hackers, and so on. Now, if you want to go over this in more details, please revise my lecture on VPN in the previous section. This is just a quick recap. Like I said, in that lecture, we connected to a VPN easily using a client that is made for our operating system. The problem that we have now is the fact that we are using Tails because most VPN providers do not support Tails. So, going back to how Tails work, as we know, it forces all traffic from our computer to go through the Tor network. So if we have a VPN provider, even if we have a proper subscription with them and we try to connect to them, we won't be able to connect to it because the operating system is forcing all traffic to go through the Tor network. Therefore, we need to first configure the firewall in Tails to redirect all data to the VPN provider instead of redirecting it to the Tor network. So we'll configure it to redirect all data through the VPN provider, and then from the VPN provider, data is going to go to the Tor network. It'll bounce over the 3 nodes and either access a hidden service within the Tor network or go to a website on the internet. Now, if your VPN provider has a Tails client, then you will not need to manually do this. The client will do everything for you. The only problem is most VPN providers do not support Tails, so you'll have to do a bit of research to find the ones that support it. As you may already know, we actually have our own VPN service, ZSVPN, and we support Tails. So let me show you how the client would work just as an example. So all you have to do is literally download it from the downloads page in here. I'll actually include a link to this in the resources in case you want to get more information. All you will need to do is simply download the client. And as you can see, I already have it downloaded in here in my persistent downloads. It's called ZSVPN. And I'm just going to run it like so, // followed by the file name. It's going to ask me what do I want to do. I'm going to say I want to connect. It'll ask me for the username and the password. Then it'll list all the servers available to me. So all I have to do right now is select the server that I want to connect to. For example, let's say I wanted to connect to Mexico 189. So I'm just going to type 189, hit enter. As you can see, it'll automatically configure the VPN settings. It'll automatically configure the firewall. So I'm just going to put my password now, the system password, the root password, and again it'll automatically download OpenVPN if it's not downloaded, and it'll connect to the server that I selected. So as you can see right here, it's saying that I'm connected to Mexico. And that's it. Now we're ready to go and browse the internet. To confirm this, I'm going to go and run my Tor browser. And I'm just going to go to check.torproject.org. And perfect. As you can see, it's telling us that my browser right now is configured to use the Tor browser. So right now what's happening is we're connecting to the VPN first, and then our traffic is routed to the Tor network. And then, like I said, we can bounce through 3 nodes and then go to the internet, or stay within the Tor network and access Onion hidden services. Now, going back to the client, you can put number 1 if you want to connect again, number 2 to disconnect, 3 to reset the firewall settings so you're directly connected to Tor and you're not using the VPN, and 4 to simply quit the client. So as you can see, it's very easy if your VPN provider supports Tails. If your VPN provider does not support Tails, then you'll have to manually modify the firewall settings so that it allows you to connect to the VPN, and manually use the VPN settings to connect to the VPN server. This is a little bit technical and requires a little bit of Linux knowledge, but don't worry about it. I will walk you through it step by step in the next lecture. Previously, we've seen how easy it is to connect to a VPN server if the provider offers a VPN client. As I said earlier, most VPN providers do not support Tails. Therefore, if you want to connect to a VPN from Tails and your provider does not support Tails, you'll have to manually modify the firewall settings, install the needed software, and connect to the VPN server that you want to connect to. So in this lecture, I'm going to show you how to do that so that you can connect to any VPN server from Tails. Please keep in mind, like I said earlier, connecting to a VPN from Tails is optional. This is not a required step because, as we know, Tails automatically forces all traffic to go through the Tor network. Therefore, by default, it is more private and more anonymous than most operating systems. So the main thing that I'm actually going to be showing you in this lecture is how to configure Tails so that it redirects data to our VPN provider and then connect to this VPN provider. So let's go to Tails. As you can see here, I haven't even logged in yet. Before doing that, you need to add an admin account. So I showed you how to do that before. We're going to click on the plus, and we're going to click on the administrator password, and we're just going to set an admin password so that we can execute commands with admin privileges. We're going to click on add to add it, and then we're going to start Tails. Now, once you're inside Tails, I'm going to go and start my terminal. So we're going to go to applications and run the terminal from here. This is basically a program that allows us to execute commands on the system. I know it sounds a little bit scary, but don't worry, I'm going to walk you through it. And the first thing I want to do is change my privileges to admin privileges because I'm going to be modifying the system settings and I'm going to be installing additional software. Therefore, I need to be admin for this. So to change our permissions to admin, we're going to do sudo su. It's going to ask you for the admin password. So I'm going to put the password that I just set at the start of the video. Now, if you notice, at the start, it was saying Amnesia, which is the user that we were using, at Amnesia. But now it's saying root at Amnesia, meaning that we're going to be executing commands as root. Root is the admin user account on the system. So I'm going to clear the screen, and the first command that I want to run is a command to install OpenVPN. OpenVPN is a program that we're going to use in order to connect to our VPN server, regardless of what VPN provider you're using, whether you're using Nord or any other VPN provider, it doesn't really matter. You can use OpenVPN with all of them. So the first thing that we need to do is install this program on Tails. And to do that, all we have to do is do apt-get. This is the program in Tails that we can use to install other programs. And what we want to do is install. And the program that we want to install is called OpenVPN. So apt-get is a program that we use to install other programs. Install is what we want to do. We want to install another program, and the program that we want to install is called OpenVPN. I'm going to hit enter. And this is telling me, do I really want to do this? I'm going to say yes. So I'm going to type Y from my keyboard and hit enter. And perfect. Now OpenVPN is installed, as you can see in here. Now you can see the notification that we have right now. It's asking us if I want to install this program only once or install every time. If you click on install every time, Tails will install this program every time you start Tails, because as we know, Tails is amnesic. So if you pick install only once, it'll only be installed for the session. If you restart the computer, it'll be removed. So I'm going to click on install every time, and this way every time I start Tails, it'll automatically install OpenVPN for me, and I'll be able to use it without doing the apt-get command that we just did. So now that we have OpenVPN installed, we're actually ready to go and connect to our VPN. But before doing that, you need to go ahead and download the configuration files of your VPN. Now you need to get these from your VPN provider. Most VPN providers will give you that. The process of doing that is different. You might even need to communicate with them. But right now I already have them downloaded in my Tor browser persistent directory in here. These are the configuration files that I need for my VPN provider to connect using OpenVPN. The main file, which is the config file, is the file with the .ovpn extension. If I double click this file, you'll see the OpenVPN configurations. And all you need to do is basically run OpenVPN, the program that we just installed, and tell it to use the configuration in this config file. This will work on any system. You can even do it from Windows or Linux. But it won't work from Tails because, like I said earlier, Tails is configured to force all traffic through the Tor network. So before doing that, before trying to connect to our VPN, we need to modify the firewall settings so that all data is forced to go through the VPN first and then go to the Tor network. So to do that, I'm going to open the configuration file for the firewall. So I'm going to go back to my terminal and I'm going to do gedit. Gedit is a text editor, so I'm basically saying I want to use a text editor to open a text file, and the text file that I want to open is the text file that controls the firewall in Tails. So that text file is stored in etc firm, and the name of the text file is firm.conf. So we're doing gedit because that's the text editor that we want to use, and we're telling it we want to edit the following file. If I hit enter, this will open the file for me, as you can see in here. And what we want to do, like I said, we want to add an exception for the VPN server that we want to connect to. So I'm going to scroll down and I'm going to look for where it says whitelist access to local resources. And in here, we're going to add the information of the server that we want to connect to. We can get this information from here, from the config file. Like I said, this is the file with the .ovpn extension. So the first thing we're going to do is type daddr to specify the IP of the VPN server that we want to connect to. And we can get that from the config file. It's after the remote in here. So we have it right here. I'm just going to copy this and paste it here. Then we're going to need to specify the protocol. So I'm going to type proto followed by the protocol. Again, looking at the config file, we can see the proto is UDP. So again, we're just going to type UDP in here. Then we need to specify the port. So we're going to type dport. Again, we're going to get that from the config file, from the remote entry. So the remote contains the IP followed by the port. So we can see the port here. It's 1191. Again, we go back here. 1191. And we're going to say for this specific IP, with this specific protocol, with this port, I want you to allow the admin user, the root user, to do anything. So we're going to open two curly brackets and we're going to say mod owner. The UID of the owner is root. Like I said, root is the admin in Linux. And we're going to say we want to accept all connections that this user does to this specific IP with this specific protocol with this specific port. The next thing that we need to do is redirect and force all traffic to go through this VPN server so that anything that the operating system does will have to flow this way, and that way it is very difficult for other programs to access the internet directly and therefore leak information about our real IP and real identity. So to do that, we're going to scroll down to where it says Tor is allowed to do anything it wants to do. We're going to say this can only be valid if the outer face, so the interface in which data flows through, is TUN0. Now, TUN0 is a virtual interface that doesn't exist right now. It will be created once we connect to the VPN server. And what we're doing right now in here is forcing all traffic to go through this interface that will be creating the encrypted tunnel between our computer and the VPN server. So that's it right now. First of all, we added a rule to allow Tails to connect to the VPN server. And second, we configured the firewall to force all traffic to go through the connection of this VPN server. So I'm going to do Control S to save this. And we're going to do Control Q to quit the file. We're also done with the config. So I'm going to close it in here. And I'm going to clear my screen. And right now, we just have to do one more thing before connecting to the VPN server, which is restarting our firewall for these changes to take effect. To do that, we're going to do etc init.d firm, which is the name of my firewall, and we're going to say I want to restart this firewall. We're going to hit enter, and if you fail at this stage, it means that you misconfigured one of the rules. So please just revise the video and make sure you set up the rules exactly like I did. As you can see, I was able to restart it with no issues at all. Therefore, right now, I am ready to go ahead and connect to my VPN server. Now, before doing that, let me just show you right here. As you can see, the configuration files are stored in my home persistent Tor browser. So I need to navigate to this location before being able to use these files. So we're going to use the cd command to change my current working directory to this directory. So we're going to do cd followed by persistent. And you can use the tab to autocomplete. For example, I'm just going to type TOR and press tab to autocomplete Tor browser. If I hit enter, you'll see that I am inside the correct path right now, same path as you see in here. Therefore, right now I can go ahead and use this file to connect to my VPN server. So we're going to use the program OpenVPN that we installed at the start of the video. So we're going to do OpenVPN --config to specify the config file. And again, as you can see in my case, the config file right here is called config.ovpn. In your case, it might be called something else, but the config file is always the file that ends with .ovpn. So I'm going to type config.ovpn. And before I hit enter, just going to go over the command. We're using OpenVPN. This is the program that will allow us to connect to our VPN server. We're doing --config to specify the config file. And my config file is called config.ovpn. I'm going to hit enter. And as you can see, it's going to ask me for the password. This is your password to connect to your VPN server, not the password of the system. So I'm going to input mine right now, hit enter, and perfect. If you see initialization sequence completed, This means that the connection has been established. Now you will also notice that the onion icon in here will have an X as if you're not connected to anything. Don't worry about this. You're seeing that because right now the traffic is forced to go through the VPN server, like I said, and that's why the system thinks that it's not connected, but it is actually connected to the VPN server. To confirm this, I'm going to go and run my Tor browser. And I'm just going to go to check.torproject.org. And perfect, as you can see, it's telling us that my browser right now is configured to use the Tor browser. So right now what's happening is we're connecting to the VPN first, and then our traffic is routed to the Tor network. And then, like I said, we can bounce through 3 nodes and then go to the internet or stay within the Tor network and access Onion hidden services. Now, just to make sure that this is the way our computer is set up and it can't access the Tor network directly or the internet directly, what I'm going to do in here, I'm just going to go back to my terminal window and I'm going to press Ctrl and C to quit the running program right here. And now if I go back to my Tor browser and refresh the page, you will see that I do not have connection. And that is perfect because what I just did right now, I disconnected from the VPN server. And because I did that, I can't access anything. And this is exactly what we want. We want our computer to be configured in a way that it forces all traffic through the VPN server. If you want to go back to the previous configuration where traffic is forced through the Tor network directly, all you have to do is simply restart Tails. Tails is amnesic. All of these configurations will disappear and you will be connecting to the Tor network directly as usual. Now this could be a feature and can be something annoying if you always want to connect to a VPN, because every time you restart Tails, you will have to do this. You'll have to do all of the steps that I showed you previously in order to connect to your VPN provider, because your settings will be reset every time you restart. Now that we have Tails installed and configured as you want it, in this section and the next sections, I'm going to show you how to use it in order to carry out whatever task you want in a more private and more anonymous manner. Because the services that you're used to use, for example, Google, Gmail, Bing, and so on, are simply not private. They track you, they profile you, and so on. Therefore, if you really want to protect your privacy, you will literally have to change the way that you use the internet. So, in this section and the next sections, I'm going to show you how to use private search engines to search for contents and search for websites on both on the clear net and on the dark net. I'm going to show you how to communicate in a more private and secure manner. So I'm going to show you how to use private email providers, again, both on the clear and on the dark net. You're going to learn how to communicate privately using end-to-end encryption and using different programs and different protocols than what you're used to. I'm going to show you how to privately share sensitive files. We're going to have a full section on encryption to learn how to properly encrypt any form of data, whether it's text, a document, a file, how to decrypt this data, and how to sign it and verify integrity. And finally, we'll also have a full section on cryptocurrencies, because as we know, the normal money that we use in everyday life is highly traceable, and if you use it, you're definitely not going to be private. Therefore, I'm going to teach you what cryptocurrency is. We're going to cover different types of cryptocurrencies and how to handle it, again, in a private and anonymous manner. All of this is going to be divided into a number of subsections, each covering one of these main topics. And then within each one of these subsections, we're going to break this topic and discuss it in more details. Right, so now that we have everything installed and configured, we know which browsers to use, and we are connected to the Tor network, it's time to go ahead and actually start browsing the DeepNet and Onion services. Now, if you think of it, we've been using the internet for a while and we take it for granted. So usually when you turn on your computer, you open your web browser and then you start going to your favorite websites because we already know these websites and we know their domain names. When it comes to the DeepNet though, things are slightly different. First, because we are still new to this, so you don't really know many websites. You can't directly go to websites. This will change over time if you start using it for a while. Obviously, you will have favorite websites and you'll know them and you'll be going directly to them. Not only that, but we're also used to using Google and other search engines to search for websites that are interesting to us. Unfortunately, Google and most search engines do not index Onion services. So if you search for a certain topic, and if there are Onion services or Onion websites that cover this topic, Google or these other search engines will not show it to you because they ignore these websites. Therefore, in this lecture, I want to show you some entry points to Tor hidden services or Onion services. What I mean by entry points is websites that we can use to discover other websites or to get to other websites or to other Onion services. Even though we're using the deep net, which is, like I said, slightly different than the clear net or the internet that you use all the time, the idea of finding websites is very similar. The easiest method is using search engines. So I'm going to cover a number of search engines in here. And the second method is using directories or websites that will list other websites. So starting with search engines and starting with the simplest one, we're going to go to duckduckgo.com. Now this is a ClearNet website. You can access this website without using the Tor browser. And using this search engine, you can search for websites on both on the ClearNet and search for Tor hidden services or Onion services. Now, the cool thing about DuckDuckGo is the fact that it does not collect any data about the users, unlike Google and other search engines, and it does not show targeted ads. So it's more private than other search engines, and like I said, we can use it to discover Tor hidden services. Now, the way I accessed it right now is using the ClearNet domain name, duckduckgo.com, but you can also access it using an Onion service link, which I have right here. Now, we know this is a hidden service because, as you can see, the link ends with a .onion. So any website that ends with a .onion, it means this is an Onion or a Tor hidden service that can only be accessed from within the Tor network, and therefore it's considered as a darknet website. So even if you go and copy this link and paste it in a normal web browser such as Firefox or Chrome, the website will not load because that browser is not connected to the Tor network. Therefore, you can only access these websites from the Tor browser or from Tails because, as we know, Tails automatically routes all traffic through the Tor network. Don't worry, I'll include this in the resources of this lecture. So if I just paste this in here in my URL bar, this will take slightly longer because we're accessing it through the Tor network, but as you can see, we got to the same page. Using the page is going to be the same, and we're going to be getting the same functionality from the page. The only difference is when you access a website using its ClearNet domain name, we're going to first of all go through the Tor network because we're using the Tor browser, and then we're going to exit the network. And like I said, the traffic sent in here will not benefit from the privacy that Tor offers, so it won't be encrypted unless HTTPS is used, and then this traffic will go to the target website. But when you access the Onion service link, which is what I accessed right now, right here, we will never leave the Tor network. So we'll be going through the Tor network again, but we will never leave the Tor network. The last node will contain the Onion service that we requested, and therefore we will fully benefit from the privacy that Tor offers. Now, once you are in this search engine, as you can see, using it is very, very simple and intuitive. All you have to do is just type the website that you're looking for or the topic that you're looking for. Like I said, we can use DuckDuckGo to search for both ClearNet and Onion hidden services. So for example, if I wanted to go to a ClearNet website, I can look for Z security. And as you can see, we got accurate results for that security. The first link will actually take you to my website. And if we wanted to search for an onion service, for example, I want to search for another search engine, and this one is called Not Evil. So I'm going to type Not Evil search engine, and maybe I'll add onion to the search query. And as you can see, the first result is actually the correct onion link to this onion hidden service. I already have it in here as well. So we can just copy it and paste it here, or you can copy it from here. Just make sure you remove the .to from the end. I like copy pasting links instead of clicking them, because sometimes when you click on a link, you don't really know where this is gonna go, because the text that you see here is not always what the browser loads. Therefore, even if you see a link like this, it's best to copy it, open a new tab or open it in the same tab as you wish, but make sure you copy and then paste the link. That way you're sure that you're going to the link that you're seeing on screen. Now, as you can see, Not Evil has loaded for us. Now, this is another search engine, but this time, unlike DuckDuckGo, this search engine does not offer a clear net address. It only offers an onion service address. Also, it can only search the Tor hidden network, so it can only search for onion services. Now, as you can see, there are no ads on the page. There is no tracking with this search engine, and in my experience, I get pretty accurate results with it. So let's say we want to search for a vulnerability. As you can see, again, very simple. You get all the websites that might contain interesting stuff for you. You can click on them or copy paste the link if you wanted to, and then you'll get to the website that you're looking for. Now, I should also mention that this search engine used to be called Tor Search, and like I said, to be honest, this has to be my favorite search engine. Now, the next one that I want to show you is called Torch, which is short for Tor Search Engine. Now, you can just look for it here, so we can type Torch Search Engine. So these are websites that will actually contain links linking to the search engine, or I actually have the link right here, so I'm just gonna copy and paste it. And again, very similar to the other search engines that I showed you. All you have to do is type the thing that you're looking for in here. Again, let's look for vulnerability. And you'll get your results right here. Now, what I don't like about this search engine, as you saw in the homepage, there are a number of ads for other Tor hidden services, and a lot of them are scam. They also slow down the browser and slow down the whole computer if you don't have a lot of resources. That's why it's not my favorite, but it's a very, very popular search engine. That's why I'm covering it here. The next search engine that I want to show you, and the last one, is called Amya. So again, we're going to copy its link and paste it here. Now again, similar to the others, this will only search for onion services. Very simple and easy to use. As an example, I'm going to look for vulnerability. And I misspelled it. As you can see, it's nice. It's correcting it for me. And again, we're getting the results that's relevant to what I searched for. Now, as you can see, this one does not have ads similar to Torch, but the quality of the results that you get here are not as good as Not Evil. So like I said, Not Evil has to be my favorite in the three that I showed you so far. Now keep in mind, the links that we're using, the Tor or the onion links that we're using right here, could change from time to time. So these links that I'm using right now might fail at the time that you're watching this video. That's why it's always a good idea if the link doesn't work, to search for the website name. For example, if you're trying to go to Not Evil, go on DuckDuckGo or one of the other search engines and look for Not Evil search engine. Similar to the others, if you're looking for Torch and it's down, then look for it on DuckDuckGo or Not Evil, and then you can go from there. Not only that, but even searching on DuckDuckGo, you'll actually see a lot of ClearNet websites, so normal websites that we use every day, listing links for other DeepNet or Onion services. So if you search for Torch search engine, for example, on DuckDuckGo, you'll get a lot of results of normal websites giving you valid links to Onion services. Now that's the easiest way of discovering Onion hidden services, using search engines. And in the next lecture, I'm going to show you more methods or more ways of discovering hidden services. Okay, so now that we had a look on the most popular search engines on the darknet, or that we can use to discover hidden services, in this lecture, I want to show you more ways to discover hidden services or Onion services. And we'll do this using websites that link us to other websites or to other services. Now, like I said, there are a number of ClearNet websites that will link you to hidden services. All you have to do is just look for them in DuckDuckGo or even in Google. A very popular website that will list a number of links is the DevsWiki. You can look for it on any search engine. I have the link for it right here, so I'm just going to copy and paste it here. Now, the DevsWiki will contain a lot of broken links and a lot of scam. So you want to be very careful when you're clicking on links here. I'm showing it here to you for the sake of completion because you might find some useful links in here. And if you're a security researcher, you really need to know what the DevsWiki is, even know about the scammy websites in here because you might want to do research on them or you might want to investigate them. Using this is very simple. You can see categories. Each category contains websites that fall under this category. You can copy and paste the links to access them. It's as simple as that. A better website with more valid links would be dark.fail. So the dark.fail is a ClearNet domain that you can access on any browser. Or if you're on the Tor browser, you can access the hidden service for this website. So again, copy pasting it in here in my Tor browser. This will load a website similar to the DevsWiki. So it contains a number of links to popular hidden services. And these links are PGP verified, so it's less likely to be scam. And it's all valid links, so you can see the grayed out ones. These are links that are offline. So for example, if you try to access this link right here, it won't work. Everything else, it should work. So this is different to what's in the DevsWiki. You'll notice this if you test it yourself. You'll see a lot of the links that you click in the DevsWiki will not actually work. Another place where you can get hidden services is the DeepNet or the Deep Web subreddit. So this is actually a subreddit on the ClearNet Reddit. So again, you can access it using a normal browser or using the Tor browser. Obviously, it's better to access it using the Tor browser because you'll be more anonymous. And in here, you'll see all sorts of topics about the deep web. So you'll see people discussing anonymity, people discussing new services, new vulnerabilities, and so on. So if you're a Reddit user, or even if you're not a Reddit user, but you want to use the DeepNet frequently, then this is a really good subreddit to stay updated with. And like I said, it'll also contain a number of good entry points. So you'll see if there is any new websites, if there is any new deep web search engines, and so on. Another useful subreddit similar to deep web is Onions. So again, reddit.com/r/onions. Again, in here you'll find links to hidden services, to Onion websites, and updates and news about vulnerabilities and about what's new in the darknet. On top of this, a really good place to get links would be forums or people that you start knowing, you start contacting, or you start talking to through messaging apps or through emails. And we'll talk about how to use messaging apps and emails later on in the course. Now, I also want to mention two other websites that I think could be useful, and I don't want to spend a full lecture on them in the future. The first one is Dread, which is a Reddit for the DeepNet. So I'm just going to copy paste its link. Now, like I said, keep in mind, if any of these links don't work, just use one of the search engines that I showed you in the previous lecture to search for the website name. So if you paste this link in here and it doesn't work, all you have to do is just look for Dread, Onion link or Onion service in one of the search engines that I showed you in the previous lecture, and you should be able to find its link. So as you can see, this is a website that has a very similar style to Reddit. You have a number of subreddits in here or subthreads, and in it you can post or you can upvote, downvote. So the usage of this website is very, very similar to Reddit. The only thing is you can discuss DeepNet or Onion services related topics in here. Last but not least, I also want to show you hidden answers. Now this is similar to Quora or other websites where you can ask a question and get an answer to. Again, the only difference in here, first of all, it's more private, it's more anonymous, and you can ask questions related to Onion services or to the deep web. So that's it for this lecture. Just wanted to cover more entry points that you can use to discover other Onion services or DeepNet websites. Like I said, the main thing to keep in mind is the links for these websites could change, and you might try something that I used here and it wouldn't work for you. If it doesn't, just look for the website name. Forget about the URL. Look for the website name. For example, if you're looking for hidden answers, look for hidden answers in DuckDuckGo or in any other search engine that I covered in the previous lecture. And from there, you should be able to find a valid link for this particular hidden service. Sometimes you could find a direct link, so a direct Onion link, or in other cases, you might find a ClearNet website or another DeepNet website that'll link you to this. So the steps are simple. Look for the website name in a search engine. From there, you'll either find a direct link or another website that'll link you to this hidden service. Now that we're getting more comfortable with navigating the darknet, we know how to access websites, how to search for data and search for websites. The next thing that you might need is an email account. Now, similar to search engines, you can actually use email accounts with ClearNet providers such as Google and Yahoo, because as we know, we can actually load these websites through the Tor browser. So let me show you a quick look. Right here, I have the sign up page for Gmail in my Tor browser. And as you can see, you're asked for a number of things, such as your first name, your last name, the email that you want. When you click on next, it'll probably ask you for more personal information, such as your phone number and your address, and then it'll sign you up with an email. Same, we have Yahoo here just as another example. Again, as you can see, it asks you for a number of personal information. And then when you fill this up, you will get an email, which you can use from Tor browser on darknet websites or in the darknet really in general. Now, first of all, we have a big problem where these mail providers are asking us for personal information, for our name, for our address, for our phone number, and so on, date of birth. So these might be things that you don't really want to share with these mail providers. Now, to get around this, I want to show you a good website which you can use in many cases. I'm going to include its link in the resources of this lecture, but as usual, with any other darknet website, if the link I gave you doesn't work, look for the website name because the links can change. Now, basically what this website will do, it'll create a fake identity for you. So it'll give you a gender, a name, a second name, age, address, phone number, email. You can change this with your email once you actually change it, and it'll basically give you detailed information about a specific person. And what you should do, you should always use this information whenever you're signing for any service on the darknet. So this will be your identity. You forget about who you are as soon as you start Tails, and from there on, you'll become the person that you're getting from here. Now, an even better solution to this is to take this information and even modify it yourself manually so that you don't forget the information in here. So maybe you can modify the first name, the second name, you can modify the email, but the main idea here is you want to create an identity that you will always use when you're on the darknet and you will never use when you're on the ClearNet. This way, your fake identity can never be linked to your real identity. This is also better than you using different identities every time you sign up to a different service, because this way you'll be more consistent, and this way you'll always be filling the same data, but this data will be fake, so it's fine, it's not going to link to you. Now, you can use this information here, like I said, to sign up to one of these email services, and then you can use this email for whatever reason you want when you're communicating with friends, or if you are signing up for other darknet websites that require you to have an email address. So this could be an easy solution, but there are still a number of drawbacks to it. First, when you're accessing this service, you're exiting the Tor network, because like we said, when you want to go to a ClearNet website, you're going to first go through the Tor network, and then you're going to exit out of it to the service that you're trying to access. Now, this exit will be unencrypted, like I said, so anyone who intercepts this data might be able to read it and analyze it. Not only that, but these email providers are known for logging you and tracking everything you do on their servers. So whatever you type, whatever you send, whatever you receive, Gmail probably gonna keep logs on every single thing you do. Now, even though you're using fake information, and even though I'm gonna show you how to encrypt your messages in the future, this could still be a risk, because like I said, they're gonna be analyzing and tracking every single movement you do. So you can do this, like I said, use it with a fake identity. Keep this fake identity completely separate from your real identity. So make sure you never use any of this information on a ClearNet website. Make sure you never use any account that's created within this fake identity to communicate with any of your real accounts or any of your real friends on the ClearNet. And this might be a good enough solution for you, depending on your situation. But in the next lectures, I'm going to show you more options if you want a more private and more anonymous solution. See, when it comes to picking up an email service, it really depends on why do you want this email and what's your threat model. So the solution that I showed you here could be perfect for you, but it might not be perfect for another person. Or it could be perfect for you in a certain situation, but it won't be good for other scenarios or other situations. Therefore, in the next lectures, I'm going to show you a number of other solutions that you can use in order to set up an email and communicate with other emails, and then you can compare them and pick the best one for you based on the reason why you need this email and based on your threat model. As mentioned in the previous lecture, in this lecture and in the next lectures, I'm going to show you a number of methods to send and receive emails, and then you can sit down yourself, compare them, and see which one suits you best based on the reason why you need an email address and based on your threat model. Now, the first thing that I want to cover is temporary email accounts. As the name suggests, these are email accounts that will work for a short period of time, and then they'd expire, deleting all of your emails and all of the information on them. Now, the cool thing about these accounts is, first of all, they're temporary. They require no setup, so they won't request any personal information, and they won't waste any time. As soon as you load the website that offers this service, you will be presented with your inbox, which you can use straight away. So as you can see, this can be very useful in many cases if you wanted to communicate with someone for a short period of time, or if you get asked for an email by a website and the website will send you a confirmation link, so you actually need to have a valid email, then you can use this. And in many cases, you're asked to have a company email, and these emails are great because they actually do look like company emails, unlike other emails that you get from Gmail and so on. Now, the main disadvantage with these email accounts is that they are relatively easy to break into, so you want to be careful about that. But if you're using encryption, which I'm going to show you later on in the course, then even if someone reads your messages, your data should be secure and encrypted as long as your keys are encrypted. But that's something to talk about for another lecture. For now, let's have a look on how to use these temporary accounts. An example right here, we have tempmailadress.com. There's also tempmail.com, and I'm going to include a full list of all of these websites in the resources of this lecture. There are also hidden onion services that offer the same service. So this website right here, gorillamail.com, right here I'm actually on their ClearNet website, as you can see, but they also offer a hidden service. So right here I have the .onion hidden service website, which is called Tor Gorilla Mail, and pretty much it's the same functionality. It gives you a temporary inbox which you can use for 1 hour. After the hour, everything gets deleted. So using the inbox is very simple. You can see, first of all, you can actually set the name that you want to use for this email in here. You can also set the domain, so you can pick the @domain from any domains that you want in here. And like I said, this can be very useful if the website you're signing up for requires you to have a company email. Once you have these picked up, you can actually copy this email and share it on that website or send it to anyone that you want to receive emails from. But using the email like this makes it easier to guess your ID and gain access to this inbox. So a better way of sharing it is to use the scrambled link in here. So this is basically the same email that you see in here. It's just scrambled so that it's more difficult to know the ID. So you can copy this and give it to anyone that wants to send you an email. And just as an example, I'm going to go to the ClearNet version of this website, this one right here, gorillamail.com, and I'm going to click on Compose. I'm going to set the to email to the email that I have here on the darknet. And let's set the subject to test and set the body to this is a test message. Now, as you can see, you can even add attachments if you want, but I will talk about file sharing in more details in the future. And once you're done, we can just click on send. And perfect. As you can see, it's telling you that the message is dispatched. And let's go to the darknet inbox in here and see if we're going to receive it. And perfect. As you can see, we got a new message in here. So if we click on this, and we have the content that we expect, which says this is a test message. Now, one thing I should note is, as you can see here in the ClearNet version of this website, you have the compose button where you can compose and send emails. But in the darknet version, this functionality is not working as expected. And even if you click on reply, it's not going to work. Now, hopefully they fix this in the future by the time that you watch this lecture. But for now, the darknet version can only be used to receive emails. But that's not a big problem because, as you can see, through Tor and through Tails, we can actually still access ClearNet websites and we can make full use of this functionality. So, like I said, this is one option of receiving and sending emails. The pros is that it requires no information. No time is wasted on signing up, and everything gets deleted within an hour. Or if you're using other services such as this one, you can pick how long you want to keep the account for. The cons, this might be easier to break into and it is temporary, so it will eventually expire. Therefore, it might not be good for all scenarios or for everybody. And like I said, these are just 2 examples of websites that offer these services. Check out the resources of this lecture for a list of more websites that offer the same service with slightly different features. The next type of email services that I want to talk about are email services that are focused on privacy and anonymity. So unlike temporary emails, these are proper email services that will give you a proper email. Your inbox will never expire. You will sign up and log in with a password similar to the way you sign up and log in to the email services that you're familiar with, similar to Google and Hotmail. They offer a lot of very useful features. They're user-friendly. So again, all of this is similar to the services you're used to. But unlike Gmail and Hotmail and all of these services that collect a lot of data about you, these privacy-focused email services collect no data. They don't store any logs. They don't track you. Most of them use some sort of encryption. the good ones would be using end-to-end encryption, so your email will be encrypted at your end and only decrypted at the destination. Therefore, nobody that intercepts this email will be able to read it. Even the mail provider itself shouldn't be able to read it. Now, I actually look at these services as a hybrid between the email services that we all know and use, such as Gmail, and the email services available on the darknet that I will talk about in the next lectures. Because like I said, first of all, they offer all of the features that we are used to. They are also user-friendly, but at the same time, they won't track you, they won't keep any logs, and they're privacy-focused. And another reason that makes me feel that they are like a hybrid is the fact that most of them are available on the ClearNet and on the darknet. So they'd have a ClearNet address and a darknet address, and they can communicate with both darknet and ClearNet email providers. Similar to the temporary emails, there are a number of providers that offer these services. I highly encourage you to do your own research and read the privacy policy before you sign up with any of them, and never use your real identity if you're using these services in the darknet. Make sure you use your fake identity. With that being said, a very popular example is ProtonMail. So this is just an example of a privacy-focused email provider. It is not the only one, and like I said, I highly encourage you to do your own research and read and see which is best for you. So ProtonMail comes with all of the features that I just mentioned that all of the providers in this category offer. On top of that, it is open source, so all of the code used is available for anyone to read and analyze. And even if you don't know coding, you can be rest assured that people are constantly revising their code and will call them out if they discover anything fishy. ProtonMail also enforces HTTPS on both on their ClearNet and on their darknet website, which is something that is rare on darknet websites, and it is great because that adds an extra layer of encryption. It uses end-to-end encryption, so like I said, the messages that you send get encrypted at your end and only decrypted at the destination, and vice versa. So even ProtonMail, if they wanted to read the content of your email, they won't be able to do that because it's going to be encrypted. They also use their own servers, so they don't rent servers from third parties, and all of their servers are in Switzerland, which is a country known for having good privacy laws. With that being said, if you read their privacy policy and their transparency page, you will see that they did reveal information about specific users in order to comply with court orders. But like I said, they keep no logs, they don't track you, and everything is encrypted, so they don't have a lot of information anyway, even if they do reveal this information. And at the end of the day, like I said at the start of this section, I'm showing you all of the options, and you should go with what suits you best in terms of why you need this account and what's your threat model. Now let's go ahead and have a look on this website. So right here I have their ClearNet website, and in here I have their Onion hidden service. For this to work, you should actually put your security settings to medium, to safer, so that it allows JavaScript to be executed on HTTPS pages. Now, depending on your threat model, you might not want to do this, but in general, because this is only done on HTTPS pages, which already has encryption, and because ProtonMail is open source, so all of its code is known, and because of their reputation, it's not a very bad idea to do this. Now, signing up is very simple. All you have to do is just click on sign up. I'm going to choose the free account, and I'm going to select it. And let's set up a username. So like I said, you want to keep in mind that you're going to use your fake identity in here. So I'm just going to set this to JOWCK, and let's put a password. You can also set a recovery email that you can use to recover the password with. I'm going to keep this to blank because I don't want to give a lot of information about myself. And I'm going to click on create account. It's giving me a warning that I'm creating an account without a recovery email, but that's fine. And right now, ProtonMail is going to create the keys that will be used to encrypt your data, your emails. Like I said, it uses end-to-end encryption. So when you send something, it gets encrypted at your end, and it will only be decrypted at the destination. Therefore, anyone in the middle, including ProtonMail themselves, they won't be able to see the contents of your emails. Now you want to give this some time because it could take a few minutes depending on the specs of your computer. Okay, now it's asking me to solve this CAPTCHA. So I'm going to click I'm not a robot. It's not accepting this, probably because I'm using the Tor network. So the other solution would be to verify myself that I'm not a robot using an email. And again, you can use any email in here. I'm going to use a temporary email similar to the ones I showed you in the previous lectures. So I'm just going to go to gorillamail.com. And let's just use a different domain just in case they get a lot of domains like this one. And let's copy this and paste it here. And we're going to send. So it's telling us that the verification code should be sent to the email that we picked. Let's go back and check if we actually did get this verification code. Perfect. As you can see, we have the code in here. It's 974644. So go back here. And we're going to click on complete setup. Again, you want to be patient with this and let it load and create your account. And perfect, as you can see, the account should be set up now. It's asking us if we want to change the name. I'm going to keep it the way it is. I'm going to close these tips. And perfect, as you can see, it's a very nice user interface. Like I said, this really is like a hybrid between what you get on the ClearNet and on the darknet. Using this is very intuitive. I'm not going to waste more time on it. This is your inbox, drafts, sent, and so on. You click on compose to send a message. The messages that you get will show up in here in the inbox, and you can, from any message, you can click on it. And now that you're inside a message, you can reply, forward, and so on. So that's it for this lecture. Just wanted to cover an example of a private kind of hybrid email service. Like I said, this is not the only one, so please don't take this as the only example. This is just an example, and I want you to understand the whole concept. So there is a whole number of services that operate on the same concept. Like I said, there are a lot of pros to this, as you can see in here. The only cons are the fact that it uses JavaScript and the fact that it is a ClearNet website, it is a proper company, and they have complied and revealed information about their users when the court ordered them to do so. With that being said, like I said, they don't keep any logs, they don't track you, and everything is encrypted, so they can't really reveal too much because they don't know too much. But again, read the privacy policy, continue with the options that I'm going to show you, and pick the option that works best for you based on the reason why you need this service and based on your threat model. In this video, I want to cover the last type of email providers. So as we're going through these videos, the providers will become a little bit harder to use and will have less features, but they will become more private, more secure, and therefore more anonymous. So in the previous lecture, we had a look on privacy-focused email providers such as ProtonMail. They were great. As they don't track you, they keep no logs, they use encryption and all that good stuff. The only problem with them is that they operate both on the clear and on the darknet. They are proper known companies, and therefore sometimes they comply with court orders and might be influenced by agencies and so on. Now, the email providers that I want to show you in this lecture, they come with all of these great features of the privacy-focused mail providers. So they come with no tracking, no logs, require no personal information and all that. And they operate fully from the darknet. So they don't have servers on the ClearNet, and even if they have ClearNet websites, they redirect you to the darknet website. They're less likely to be influenced by agencies and so on. Because all of their servers are in the darknet, so all of them are running as Onion services, therefore by default they benefit from Tor's anonymizing and privacy features. They all use encryption, and therefore they are more secure, more private, and therefore they are more anonymous. Now, there are a lot of darknet email providers. I'll include links to lists in the resources of this lecture. You can go through them and see which one you like the most. As usual, do your own research, read the privacy policy, and pick the one you like the most. In this lecture though, I'm going to show you two examples of these mail providers. The first one is Elude. It's pretty cool. Like I said, keeps no track, no logging, all that cool stuff. It also uses end-to-end encryption, and your emails are stored in personally encrypted storage. So that's really, really nice. Now, before I go and use this, both of the services that I'm going to show you today do not require JavaScript. Therefore, we can go ahead and set our security settings to the highest. We had to keep it at safer when we were using Proton Mail because it requires JavaScript. But for both of the services that we're going to use today, they do not require JavaScript. Therefore, we can set our security to the highest and they should still work and function as expected. Signing up to this is very simple. All you have to do is go to sign up. Now, like I said, I will include a link to this in the resources of the lecture, so don't worry about that. It's going to ask you for your name. Again, use your fake identity. So I'm going to set it to John Wick. Put a username. So I'm going to set it to JNWK7. Set a password. Solve the CAPTCHA. And click on register. So it doesn't get any simpler than this. When you're done, it's telling us we succeeded. We have the email now, and we can just go ahead and log in. So I'm going to log in with my username, put my password, fill the CAPTCHA. Now it's going to ask you to verify your email. You can do this using any of the other services that I covered before, or you can just skip the verification and go straight to your account. Now that I'm in my account, I'm going to go to the email login to go to my inbox. And I'm going to use the text only interface. And perfect. As you can see, you get a normal inbox that is very easy to use. So I'm not going to spend too much time on it. But I want to highlight a major feature of this email provider. See, when it comes to darknet email providers, not all of them allow you to send emails to darknet and clearnet addresses. So Elude is one of these email providers which allow you to communicate with both clearnet and darknet addresses. So as a test, let me first of all send an email to a clearnet address to a Gmail address. So this is my other Gmail account. Now you should never do this in real life scenarios. You should never communicate with your own clearnet addresses because this can be used to link you and to know who you are. But for now, I'm just trying to show you that this email provider works with both clearnet and darknet addresses. So I'm just going to say this is a test to a clearnet email address. You can also send attachments if you want, but we're going to keep this the way it is. I'm going to send it. And if I go to my Gmail address that I sent this to, as you can see, we got the message. It's telling us that this is a test to a clearnet address. And I can reply, let's just say it works. And if we go back here, go to the inbox, refresh it. Perfect. As you can see, we got the response. If we click on that, it's saying it works. So everything is working as expected, and we can use this account to send emails to both clearnet and darknet addresses. Now, this is one example of darknet email providers. The other example that I want to show you is called Torbox. Like I said, I will include links to this in the resources. And the main difference between Torbox and Elude is that Torbox is completely isolated from the ClearNet. This makes it a little bit more private because it literally prevents you from communicating with anyone on the ClearNet, therefore increasing your privacy and therefore increasing your anonymity. Also, like I said, the more examples that I show you, the less features they will have and the more anonymous they are. So this email provider has less features and you'll see that, but like I said, it'll be more private and more anonymous. So let's click on sign up to sign up and you'll see this is again very, very simple. We'll set a name. So again, John Wick. Pick an email. So our email is going to be jnwk7 and it'll be at this address .onion. And we're going to set a password and solve the CAPTCHA. And perfect, the email is done. This is it. You can store it in a text file so you can remember it. And now we can go ahead, click on webmail login to log in. Put the name and the password. And perfect, we're logged in right now. As you can see, the interface is even simpler in here. If you wanted to write a message, you can click on compose. Let me show you. If I send this to my Gmail email address and say test and click on send, you'll see that this will actually be refused. So as you can see, it's telling us that this did not get sent because we are trying to communicate with a ClearNet email address. However, if I try to send something here to the elude email, so this was jnck7@elude.in, keep everything the same. If I click on send, you'll see I'll get no error messages. And if I go to elude and check my inbox, you can see I have a message coming from my Torbox address. And if we go in, we can see the message content. Now, elude and Torbox are just two examples of darknet email providers. Like I said, I just wanted to show you two different examples, as like I said, elude allows you to communicate with both ClearNet and darknet addresses, where Torbox can only communicate with darknet addresses. So again, do your own research, read about both of them, see which one suits you best and fits your threat model and fits your needs, and use the one that is best for you. And like I said, I'll include links to all of these and more in the resources of this lecture. Now, in the previous lectures, we covered different types of email providers. Within each type, there are a number of providers, and each one of these providers could have their own pros and cons. Therefore, at this stage, I wouldn't blame you if you feel a little bit confused or find it a little bit difficult to pick which is best for you. Now, the reason why I covered so many different types, because I think each one of these types is different from the other, and knowing all of these types can be very, very useful because you'll be able to pick which is best based on your scenario. So, as I mentioned at the start of this section, when you want to pick an email service, you want to keep two main things in your mind. Why do you want to use this service, and what's your threat model? Who might be trying to de-anonymize you or discover your location? Keeping that in mind, and in order to revise and make it easier for you to pick a good email provider based on your scenario, I made this simple table that summarizes everything we talked about so far. Now, the main thing you keep in mind is, as we go down in this table, the provider type will be more private, more secure, and therefore more anonymous, but it will have less features. So like I said, it all comes down to why you want to use it for and what's your threat model. So the first type of providers we had a look on were the common services such as Gmail, Hotmail, Yahoo Mail, and all of that. These email providers can send emails to the ClearNet and to the darknet, as we saw. They all use JavaScript, so they are less secure. We know that they heavily track you and log everything you do, so they are not private.
Like I said, if you really want to use these, you want to make sure that you use fake identity and never communicate with your own email addresses or any other email addresses that can link to your real identity. They do not offer a hidden onion service link, and they do use HTTPS encryption. So these were the base. Then the other example we had was the temporary emails, which in my opinion can be very, very useful in so many scenarios. Like we said, they don't require any personal information to sign up. There is no sign up. You literally get an inbox straight away and you can use it. So you can have unlimited number of emails because you're never asked to sign up. They are more private and more anonymous than the normal email providers. They do use JavaScript, so again, they're not as secure as possible. They might be logging you, but the cool thing is some of them offer a hidden service, so you never need to exit the Tor network when you're using them, and they also use HTTPS to add an extra layer of encryption. So this is a really, really good option if you know what you're doing. If you just want a temporary email to send something quickly, to receive something quickly, and this will actually be destroyed once you're done with it. So it can be anonymous enough. It can be great in so many scenarios. Again, if you're trying to just bypass a registration form and so on. The next email providers that we had a look on were the privacy focused, or what I called hybrid services. So they can communicate with ClearNet and Darknet services. They have a lot of nice features. What really differentiates them from the common services such as Gmail, Yahoo, and all of that is the fact that they will not track you. They won't be logging your movement. They don't require personal information. Like I said, these are privacy focused. Some of them will even have a darknet address, so again, you can access them without exiting the Tor network, which will improve your privacy and anonymity. Some of them use end-to-end encryption. Again, in our example, ProtonMail uses end-to-end encryption, so like I said, even if they wanted to see what you're doing, they won't be able to see it. The only problem with these providers is the fact that they are real proper companies. They have servers on the ClearNet, and they have complied to court orders and disclosed information about their users previously. Now, like I said, they keep no logs and they require no personal information, and they use end-to-end encryption, so the amount of information they can share is limited because they don't know a lot. But again, the fact that they do comply sometimes puts them in second place in terms of anonymity. The other thing that you want to keep in mind is the fact that they require JavaScript. So when you use them, you need to have your security settings in the Tor browser to medium, which is not very secure. But if you're using ProtonMail or any other reputable email provider, and if that email provider is using HTTPS, then it is secure enough to enable JavaScript in the medium level. But again, this is still not as secure and as anonymous as possible. This led us to the last email providers, which are completely available on the darknet. They have no ClearNet addresses. So again, when you use them, you never exit the Tor network. This increases your privacy and anonymity. They also do not require JavaScript. So you can put your security settings to the highest, where JavaScript and all of the other features of the browser are disabled. That can be used to reduce your security or de-anonymize you. Some of these providers allow you to communicate with both ClearNet and Darknet addresses, such as Elude. And we also had an example of Torbox, which is a provider that only allows you to communicate with Darknet addresses. Now, this is great because, like I said, it keeps you limited and it keeps you as anonymous as possible. Now, it goes without saying that none of these services track you. None of them keep logs. Because they run as onion services, they make full use of the privacy provided by Tor, and on top of that, some providers such as Elude provides end-to-end encryption and even personally encrypt the storage that stores your emails. And again, because these are darknet services, the location of their servers is unknown and they're less likely to comply with court orders or to get influenced by government agencies and so on. Now, like I said,
the examples that I'm giving you in here, these are just single examples of the categories that we see here on the left. So do your own research if you want to learn more about each one of these categories, and don't just take my word for granted. Go read the privacy policy, read the history of each of these companies, make sure that this company or this provider is the best for you, for your scenario, and only then start using it. Okay, so now that we know how to use emails to communicate on the darknet privately and anonymously, the other method of communication that you might want to use is instant messaging. Now, when it comes to instant messaging, just like everything we spoke about so far, there are a number of applications that we can use to do this, such as WhatsApp and Viber for phones and Skype for desktops and phones. And again, similar to everything we spoke about so far, a lot of these apps are not private and not secure. So a lot of them log what you do, they track what you do, they track your messages, they track the users that you talk to, communicate with. Some of them have permissions to listen on your mic, and the list goes on. Not only that, even the apps that claim that they use encryption and they are private, such as WhatsApp, we don't really know how this is implemented. We can't see the code. So there is even rumors that the end-to-end encryption in WhatsApp is not 100% secure. It's not 100% end-to-end, and Facebook might be able to read the messages that get sent. Now, you'll face this issue with everything that is owned by one specific company, because a lot of these companies don't share the code used on their programs. So at the end of the day, you will just have to trust them. All this aside, all of these applications might be vulnerable to exploits, and we all heard about the WhatsApp vulnerability that affected all smartphones, in which hackers could hack into any phone by simply calling the phone, and you won't even need to answer the call and you'll get hacked. Check out the link in the resources for more information about this vulnerability, but this is just an example on how these apps can be dangerous. And again, putting all of this to the side, even if the apps are 100% secure and even if they are 100% private, these apps are installed on operating systems that are not secure and private, such as iOS, Android, Windows, and so on. And we spoke about how all of these operating systems log data and track their users. Therefore, if you want to protect your privacy and anonymity, it's a better idea to first of all use an operating system that is more private than other operating systems, such as Tails. This will solve the problem of the operating system, and then use a messaging service that is more private and a messaging app that is more private. So we're already using Tails and we know how to do that. So we have the first part of the problem solved. The next thing that we want to do is to use an instant messaging service that is more private. And to do this, we're going to use XMPP. This is a free and open protocol that is not owned by anybody, so it's not controlled by a single company. It is decentralized, so anyone, even you, can go and create your own server and use that to communicate with other XMPP servers. We can also enhance its security by using OTR, and we'll talk about that later on. And this is a widely used method of communication on the darknet. Therefore, it is very important to learn how it works. So in this lecture, I'm going to show you how to create an XMPP account, and then we'll see how we can improve its security using OTR in the next lectures. Now, like I said, XMPP is decentralized, so anyone can run their own server, and you can even use your own server to set up an account. So right here, I have a list of public XMPP servers. I'm going to include a link of this in the resources. Now, as you can see, there is a lot of servers that you can use. You can think of these as email providers. So each one of them will allow you to create an account. And once you create an account, you can communicate with any XMPP server, with any XMPP account, regardless of what server it's made on. So it's similar to emails. When you create a Gmail account, you can use it to communicate with Hotmail, Yahoo, or any other email. this is exactly the same. You can set up an account with any of these servers right here, and once you do, you can communicate with all of the others, even if you're communicating with a server that is set up by a person, not a public server. Now you can see for each server, right here we have a hidden service that you can use to access the server from within the Tor network. The inbound registration column here specifies whether you can sign up to this account without accessing their website. So if you can sign up using the XMPP protocol on its own, using your instant messenger such as Pigeon. In many cases, even if it says it's enabled here, it doesn't really work. So it's better to click on the link of the server that you want to sign up with and manually sign up. And I'll show you that in a minute. The XEP compliance gives an indication of the features and the specifications of XMPP that this server has implemented. So if you click on this right here, you'll actually get this link right here, and it'll have a list of the servers that we have, and we can see the features in here on the top, and each of these features or specifications will be green if the server is implementing it. So you can see this server right here is implementing all of the specifications. If we go down, you'll see some servers have red in here, which means that they haven't implemented this specific specification. Now, you don't really need to go through all of this because, again, in this list, it's telling you excellent for the ones that are implementing everything. So you can just pick one of the ones that say excellent. And finally, the IAM Observatory grade is a grade of the security of the server, of how well they implemented their TLS, which is their encryption, and their DNSSEC. Again, if you see A for this, that means it's pretty good, so you can go for one of these servers. Now, like I said, you can pick any of the servers in here. Before you do that, as usual, I highly encourage you to read the privacy policy and see reviews about the server before you actually go ahead and use it. But for this lecture, I'm going to use this mail, which actually is a good server, and I've seen good reviews about it. And as you can see, you get a normal website. And what we want to do with this right now is just simply register. So I'm going to click on register to register with them. And it's asking us some very simple information, such as a username. Again, make sure you set this to your fake identity. So I'm going to set it to John Wick. I'm going to set a password and answer the question. And that's it, we're done. So as you can see, a very, very simple registration process, very similar to what you would do when you're signing up for an email. It didn't ask us for any personal information, and it took us a few seconds. So you can actually even create temporary accounts. So every time you want to communicate with someone, or every week or every 2 weeks, you can just create a new account and use that to improve your security and anonymity. So the username that I picked was John Wick, JHNWCK, and the server that we have is this. So my account is going to be jhnwck@thismail.de. So like I said, it's very similar to the way emails work, and even the format is very similar to the format of emails. So that's it, the account is created. And in the next lecture, I'm going to show you how we're going to use this account to log in to the server using an instant messenger that comes with Tails, and we'll see how we can use it to communicate with other accounts. Okay, so now that we have the account set up, let's go and see how we can log in to this account and communicate with friends using Pigeon as the instant messenger. So I'm going to go to a new desktop. Now Pigeon comes pre-installed in Tails, so this is great, and this is one of the reasons that I chose to cover it, and one of the reasons why it's so popular, because you don't need to install it, and as we know, Tails is live, so it's always great when you can just use the built-in applications. So we're going to go to applications, and you can find Pigeon in here in the favorites, as you can see in here, or you can find it under internet, and we have it right here. Now we're going to launch this. And as you can see, as soon as you start it, it'll have 2 default accounts. Now we're not going to be using these accounts. We want to use our own account, which we just created. So I'm going to click on add. And I'm going to choose that this account is going to be an XMPP account. I'm going to put the username. And as you remember, the username that we picked was JHNWCK. And the domain that we set this on was this domain right here, thismail.de. So I'm going to copy it and paste it here. I'm going to put the password, which is the same password that I chose when I signed up. And I'm going to click on add. Now, perfect. Now I'm actually logged in. As you can see here at the bottom, the circle is green and it says available. This is my status. So if anybody has added me to their friends list or buddy list, they will see me as available. And using this, we can set it to away, do not disturb, or offline if we want to go offline. Now, this is fine. Let's go ahead and add a friend. So I'm going to go to buddies. I'm going to click on add buddy to add another friend. So the first thing it's asking us which account I want to add this friend to. This is our account that we're using right now. So I'm going to keep this the same. If you had multiple accounts, you can click this and select the other account that you want to add your friend to. Next, it's asking us for the buddy's username, the username of the friend that I want to add. And I've already set up another account on a different XMPP server just to show you that you can communicate with any XMPP server with any account. And the other account that I set up is jhnwck2@jabber.systemli.org. So as you can see, this is a completely different server, but we should be able to communicate with it. I'm going to add it. And if we go to the other account, which is this one right here. So this is another Tails machine that I'm already logged in to the account that I just added to johnwick2@jabber.systemli.org. And as you can see, he got a friend request from my other email, which is johnwick@thismail.de. So I can authorize or deny this, and I'm going to authorize it. I'm going to allow him to add me, and I'm going to add him as a friend as well. So if we go back here, we can see we have John Wick as a friend, and we can see there's a green circle beside it, so he's online. And if I double click this, let's close this, we will get an instant messaging screen. Again, very similar to what you get in other applications and other instant messengers, and you can start sending messages. So let's say, hey, let's see if we receive it here. As you can see, we got a message here in a new tab from johnwick@thismail.de. He said, hey, let's say hello back just to test. And going back here, as you can see, we got the message back. Now, before we wrap this up, I want to highlight one more thing. So right now, when we send something through XMPP, we are connecting to the Tor network because, as we know, Tails route everything through the Tor network. Then whatever we're sending is exiting the Tor network to the XMPP server because the XMPP server is on the ClearNet, and then it's relayed to the destination. Now, all of the servers that I showed you offer a hidden service XMPP server. So what happens in that case is we connect to the Tor network, and whatever message we sent directly goes to an XMPP server that is running as a hidden service. Therefore, it never leaves the Tor network, making full use of the privacy and anonymity that the Tor network offers. Now, to do this, we need to slightly modify the way we configured Pigeon. So let's go back to Tails, and I'm going to go up to the list of the servers, and I'm going to look for the server that I used, which is this one right here, thismail.de. And as you can see, we have the link for its hidden service right here. I'm going to copy this. I'm going to go down to Pigeon. I'm going to sign out of my current account. I'm going to go to offline, and we're going to go to accounts. We're going to manage my accounts. And this is the account that we want to modify its server so that we connect to the hidden service instead of directly connecting to the ClearNet server. We're going to click on modify to modify its settings. And keep in mind, we're keeping the basic exactly the way it is. We're still using the same username and the same ClearNet domain because this is our address. But what we want to modify is in the advanced tab, which is the connect server. So you want to set this server to the hidden service that you want to use as the XMPP server to connect. And that's it. We're going to click on save and we're good to go. I'm going to close this and I'm going to change my status to available again. It's going to ask you for the password. We're going to put it. And perfect, we're back online. I can see my buddy right here. And let's send him another test message. And go to his account. And perfect, as you can see, we got the message from him right here. So as you can see, very simple, very intuitive, very similar to any other messaging app that you can use. The great thing about this is, like I said, it's decentralized, so anyone can start their own server. There is no one company that controls how this works. Pigeon comes pre-installed in Tails, therefore you don't need to install any third-party programs, and as we know, Tails is amnesic and live and secure enough, therefore you're benefiting from all of these features. The only problem right now is, as you can see here, it's saying the connection is not private. So the communication right now between us two is not private. Now TLS is used, so there is a layer of encryption, but it's not end-to-end encryption. And ideally, we want to use end-to-end encryption, so the message gets encrypted at my end and it never gets decrypted until it reaches the destination. So even the server owner or anybody that intercepts this message would not be able to read it because it'll be encrypted throughout the whole way. So in the next lecture, I'm going to show you how to configure Pigeon to use end-to-end encryption. Okay, so now that we know how to create an XMPP account, configure Pigeon to sign into this account, add a user, and communicate with friends, in this lecture, I want to show you how to improve the privacy and anonymity of this method of communication of XMPP using a plugin called OTR. So as you can see right now, when we're sending messages, you can see in here at the bottom right, it's saying that our communication is not private. To understand why our communication is not private, let's have a closer look on what happens when you send a message. So we have David and John here that want to communicate. They're using an XMPP server to communicate. It doesn't matter what server they use. Like I said, they could be using two different servers. So David has a message that is a secret message. He sends it to the XMPP server that he uses, and then this server might relay it to other servers or directly send it to John. Then John can open the message and read it. Now pretty much all of the servers in the list I gave you in the previous lecture support TLS, and if you choose a grade A server, then that means they're using the latest and greatest specifications for TLS. So that means the communication between the clients and the server are encrypted. And hence the red lines in here, that means all of this communication is encrypted. And if anybody manages to intercept this connection here or here, they will not be able to read the message because the message will be encrypted. It'll be gibberish. The only problem is, listen to what I said. I said the communication between you and the server is encrypted. So what that means is, it means you will be able to read the message, the server will be able to read the message, and the receiver will read the message. Now it's fine that you and the receiver can read the message. The only problem is the fact that the server can read the message because the communication between you and the server is encrypted, but once the message is delivered to the server will be able to read it. Now, like I said, you want to make sure you use a server that you trust and read about the reviews and read about their privacy policy. And even if the server is great and will not share anything that you do and will not log anything that you do, it's still not great that servers can read what we type. It's not very private. Therefore, the solution to this is to use a plugin called OTR, which is short for off the record. And the idea behind this plugin is to make this communication as close as possible to an off the record private communication that you can have with a friend. So whenever you're talking to someone about something privately and you don't write anything about it. So it provides end-to-end encryption. It provides authentication, so we'll be able to verify the person we're talking to. It provides perfect forward secrecy and deniability. Now, the way this works is, so let's go back to our diagram. We have David who wants to send a message over an XMPP server that is using TLS. So as you can see, we have red lines here indicating that the communication is private. But what happens is, before sending this secret message, David is going to encrypt this secret message. So the message will become gibberish, and then and only then he will forward it to the XMPP server. This means that the message that the server will receive will be gibberish. It will not be readable. Then the server will relay this message to John. When John opens this message, it's still gibberish, and he will have to use a key to decrypt it and read the content of the message. This way, the only two entities that are able to read the content of the message are David and John, the sender and the receiver. And even though the XMPP server will read the message, the content of the message will be gibberish because it got encrypted by David before sending it. Not only that, anyone that intercepts the communication in here, they will have to bypass 2 layers of protection now. They'll have to bypass TLS and the encryption implemented by the OTR plugin. So let's go ahead and see how we can configure this with Pigeon so that we can encrypt our messages and send them privately. So right here, I'm already logged in to the account that we created previously. And before I send any further unprivate messages, I'm going to go to Tools, Plugins, and I'm going to look for OTR or off the record. We have it right here. And as you can see, it's enabled by default. And I'm going to click on Configure to configure this plugin. And what I want to do right now is make sure that it is enabled. I want to make sure that automatically initiate private messaging and require private messaging are ticked so that even if I try to send any messages unencrypted in the future, Pigeon will refuse that. So I'll have to always use encryption. That's done now. I'm going to close this. And now when we come here, when we come to a conversation, so let's close this and just show you the steps from the start. So you'll double click because you want to talk to your friend. And again, before you do anything, as you can see, it's saying the communication is not private. So you can either click on this, you can click on the OTR in here or on this icon. So I'm going to click on this and we're going to select Start Private Conversation to enable OTR off the record and start communicating with my friend privately. So as you can see, it's telling us that it's generating a private key for me and it's done. So I'm going to click on OK. And right now, if I send a message, so let's say this is a test and send it. If we go here, as you can see, this is the friend that I sent the message to. He automatically got a private key as well because I requested to initiate a private conversation. And as you can see, automatically for him, it's saying it's unverified. So it changed from private to unverified. We'll talk about what the unverified means later, but basically this means that the communication between us now is encrypted. And as you can see, we get the message. So now if I say hello back and go to the other person, as you can see, we received it right here. And basically this means that any message I send from here or from the other account is always encrypted at my end and only decrypted at the end at the destination. So even the server will not be able to read the contents. So that's it for this lecture. Now our communication is private. As you can see, we still have one more notification in here saying that our communication is unverified. So we bypassed the private problem. Now our communication is unverified. I will talk about what that means and how to fix this in the next lecture. Okay, so far we signed up with XMPP, which, like I said, can be more private and more anonymous than normal messaging services. We're also using this from Tails. which is live and amnesic and comes with the latest patches and more secure than normal operating systems. So right now, our method of instant messaging is more private and much more anonymous than normal instant messengers. We're also using end-to-end encryption, so whenever we send a message, it gets encrypted on our end and never gets decrypted until it reaches the destination, so no one can read the content of the message. Even the server that we're using to facilitate the connection cannot see the messages that we sent. So this is really, really good. The servers also use TLS. So everything is set up properly so far. The only problem that we have is you can see here at the bottom, it's still telling us that the communication is unverified. So it is private, but it's just unverified. And what's meant by this is right now, we're still not sure that the person on the other end, this person right here, is who they're claiming to be. What if someone managed to hack into this person's account? Or what if someone has managed to impersonate this account? So how can we be so sure that the person using this account right here is the person that we want to communicate with? So this is what the warning is telling us. We haven't verified the person on the other end. And in this lecture, I want to show you a number of methods on how we can do this. So we're going to click on the notification and we're going to click on Authenticate Body. And as you can see in here, we have a drop-down menu in which we can select the method that we want to use in order to verify the person at the other end. So the first method is very simple, question and answer. And the way this will work is you'd want to use a question in here that only the right person can answer. So you want to make sure that if anybody hacks into their account or impersonates them, they won't be able to answer the question that you enter in here. So for example, let's say I want to ask him, where did we meet? Now this is obviously a really bad question to ask in terms of privacy because this will reveal the location where you met this person, but just for testing, it's fine. And you want to put the answer to this question. So let's say Ireland, and we're going to click on Authenticate. So right now, as you can see, we're waiting for the person to respond to this question. And if we go to the person's account, as you can see, he got this message telling him that the other person is trying to authenticate you. The question is, where did you meet? And he has to put the answer here. So if I put the correct answer in here, click on Authenticate. As you can see, it's telling this person that your body has successfully authenticated you. And you may want to authenticate them, so you may want to use a different method of authentication to make sure that that person is who you think they are. But if we go back here, you can see that it's telling us that the authentication is successful and the communication right now is private. The warning is gone. So right now we're using end-to-end encryption. Everything is encrypted on our end and only decrypted at the other end. We also verified that the person at the other end is the person that we actually want to communicate with. We're using XMPP to send the messages. Like I said, this is a decentralized messaging protocol that is not really owned by a single company. And you can even set up your own XMPP servers. So therefore, there isn't a single entity that could spy or could see what's happening. Now, there are actually other methods to verify the other person. So if we go here and click on Authenticate Body, you can also choose a secret, a shared secret. So this way you don't ask a question. You need to agree with the other person on a secret that you use to authenticate them. So you would only put the secret in here. They'll be prompted for the secret as well. And if you both put the right correct secret, they will be authenticated. And the last method of authentication, you can use manual fingerprint verification, where you will have to send your fingerprint, which is this one right here, this code, to the other person, but you want to do this using another method of communication. So you want to either call them or send it to them by email or another secure method of communication. And then once they get it, go to the authenticate, go on the fingerprints as well and compare the fingerprint that you send them to the fingerprint that they see in here. Now, as you can see, this method is a little bit more complex and would require more steps, but the other two methods that I showed you earlier are only available in the recent Pigeon versions. So if your buddy or your friend is using an older version, you might have to use this method. So that's it for now. You can go ahead and start communicating with your friends using Pigeon with XMPP and OTR, and this way your communication will be private. You'll be able to authenticate your friend, make sure that the right person, and therefore your communication will be more anonymous. So far, we learned how to communicate privately and anonymously using emails and using instant messages. In both of these methods, we're sending the data as text. We never really tackled the problem of sending files. So, in this section, we're going to talk about sharing files anonymously and privately. So first, we're going to talk about how to strip files from any identifying data. Then, we're going to talk about different methods in order to share this data with other people or with specific people, privately and anonymously. And finally, we're going to talk about how to remove these files securely, because once you have something on your computer, simply deleting that file does not completely remove it. So we're going to talk about how to properly delete files from your hard drive, from your storage devices, and we're going to talk about how to securely wipe and encrypt these storage devices. Now, before we discuss the methods that we can use to send files, let's talk about metadata. So each file, whether it's an image, a PDF, or a document, any digital file has metadata. What we mean by that is it's information that is attached to the file that can reveal more information about the file itself, such as the creator, the program used to create this application, the time it was created, and more. Let me show you an example. So right here, I have an old picture of my car taken with an old phone. And if I right-click this picture and view its properties and go to the Image tab, as you can see, we get a lot of information about this picture. Now, the first few things might not look very interesting, such as the type of the image, the width and the height. But then if you go down, you can see the camera type, which was Apple. You can see the camera model, it was an iPhone 6s. You can see the date this picture was taken, the exact date with the day with the time. You can even see if the flash was used or not. Now, this is an example of a picture. If you do the same for a document, you will see the creator, the operating system, the program used to create it, and so on. Therefore, all of this information can be pieced together to understand what platforms you use and work from there to de-anonymize you. Therefore, if you want to share files anonymously, it's a really good idea to remove all of this information to minimize the amount of information that can be used to identify you. Now, luckily, doing this is very, very simple in Tails. All you have to do is right-click the file that you want to remove its metadata and click on Clean Metadata. One click on this, it'll first create a backup of the image, as you can see in here, just in case the process could break something. And then right here, we have the image itself after clearing the metadata from it. So right click it and go to Properties now. And if you go to the Image tab, as you can see, we won't see any information related to me, to the person that created the image. So we don't see the font type, the camera type, and the time it was created, and so on. Now, once you have the image cleared, you're ready to share it. So you can go ahead and use one of the file sharing services that we already know on the ClearNet, such as Google Drive, Dropbox, and so on. The only problem is with these services, similar to many ClearNet services, they are not private. They're going to log data, they're going to track you, and they're not secure. Not only that, but the way these services work is not very private because they upload your files to an online server or to the cloud. So you might think, okay, I'm not going to use this. I'm going to use the email services that I showed you before because all of them allow you to send attachments, but they suffer from the same problem. Your file will be uploaded to a server, to the cloud. So let me show you what I mean. Let's say David wants to send a file to John here on the right. And what they want to do is they want to use Google, Dropbox, or even one of the email services that I showed you earlier. So to do that, the file is going to be uploaded to the cloud to a server owned by one of these companies. And then John is going to download this file from the cloud. So the end result is both David and John will have copies of the file, which is fine, but at the same time, the server used to host the file is going to have a copy of this file, which raises a number of problems. Anybody who has access to this server will have access to the file. So the employees that work at that server, hackers that manage to gain access to the server, and government agencies that have some sort of an agreement with the owners of these servers. Therefore, this method is not very private and is not good if you're sharing sensitive files. Now, the creators of Firefox have attempted to solve this problem by offering a file sharing service that uses end-to-end encryption. So the way this will work is the file will get encrypted using code that runs on the client side. So this is code that runs on the computer, on your own local computer. It will encrypt the file that you want to share first, and only then your file is uploaded to their server, and then you share a special link that contains a decryption key with John. John will use this link to download the file, and because the link contains the decryption key, John will be able to decrypt the file and read its content. Now, let me show you how this works so you have a better understanding of it, and then we'll discuss the cons of this method. So, let's go back to my Tails computer, and I'm going to try to share the same image that I cleaned that has no metadata at the moment. And keep in mind, this image is stored in my Tor browser directory because remember when we spoke about how Tor browser is configured on Tails, it can only upload and download files stored in the Tor browser directory. So the image is in the right place and it contains no information that can be used to identify me. The only thing that's left to do is upload this image. I'm going to go to my Tor browser, and I'm already at the file sharing service offered by Firefox. You can access it by going to send.firefox.com. I will include that link in the resources of this lecture. And as you can see, it's very simple, very easy to use. All you have to do is click on the file that you want to upload. You'll be at the Tor browser directory by default. You want to pick the file that you want to share. This is my image. And we're going to click on open to start uploading it. Now you can actually select multiple files by clicking on the plus here. You can actually configure this file to expire after a certain amount of downloads, for example, after one download, or you can set up an expiry date so it expires after 5 minutes, an hour, a day, or 7 days. You can also protect the file with a password by ticking this box. So I'm going to keep everything to the default and I'm just going to click on upload. And perfect, as you can see, we have the download link right here. So you can copy this and share it with the person that you want them to download. So I'm going to click on copy to copy it. And then I'm going to go on a new tab and paste the link. Now, as you can see in the link right here, this is the decryption key, and this is the key needed in order to decrypt the file so that the person that downloads it will be able to see its content unencrypted. Without this part right here, the file contains no useful information. Therefore, even the owners of Firefox or anybody who has access to their servers will not be able to see the contents of your file without this key. And keep in mind, this key gets generated by code that runs on the client side, by code that runs on your browser. So it's not code that is running on their servers. Therefore, they should not be able to see this key. Now, if we hit enter, As you can see, we'll get a download page, and if we click on download, it'll first decrypt the file, again using code that runs on the client side on your own local computer, and then you'll be able to download the image. Let's just call it 22, save, and that should be downloaded. So if we go here, you can see we have the image, which is identical to the image that we uploaded. So that's perfect. Now, this method might seem secure, and it is more private than uploading your files using Google Drive or Dropbox and all of them. But there are still a number of things to keep in mind. First of all, the link contains the decryption key. Therefore, anybody that has access to the link will be able to download your file and see its content. Then we have the other problem. Do we trust that server? Now, I know I said that the file will be encrypted before uploading it to the server, and the encryption will be done using code that runs locally, so the server does not know the decryption key. But do you really trust that this code will never change? What if a hacker gains access to Firefox servers and modifies the way this code works so it actually sends the key to their server or to his own server? What if an employee that is pissed off and don't like Firefox does something like that? What about government agencies? So again, even though encryption is used in this case, it still suffers from the same problems as normal file sharing services because we still have to trust that server. So the main problem that we're facing here is the way these file sharing services are implemented, not a problem with encryption. We will actually talk about how you can manually encrypt your files without relying on code pulled from another server. The main problem that we have here is our file is being stored somewhere that we do not control. Regardless of how this file is stored, whether it's using encryption or not, does not really matter. Ideally, we want to keep our files locally and only share it in places where we have full control on. And this is what I'm going to show you in the next lecture. Now, one more thing to add. For this service to work, like I said, it uses client-side code to encrypt and decrypt the files. Therefore, you need to have your security settings on low or medium to work, because the client-side code that will do all of this work is JavaScript code, and the high security level, as we know, disables JavaScript. Therefore, you might not want to use a medium or standard security setting because it doesn't fit your threat model. So again, this will be another problem with using this service. But in general, if you have something that is not very sensitive, then this could be a nice and quick way to share files. Okay, so now that we know that the normal file sharing services are not great when sharing sensitive files, even if they use end-to-end encryption, such as Firefox's send service, in this lecture, I want to show you a more private method to share files. Now, this method is peer-to-peer. Now, remember, we said the main problem was not about encryption, but it was the fact that our files were stored somewhere that we have no control on. So, in the method that I'm going to show you in this lecture, our files will not be stored in a server that we don't control. It's going to be stored locally. It's going to be peer-to-peer, so the file will be shared from our computer to the computer of the person that we want to share the file with. It's going to use end-to-end encryption. It's going to benefit from the anonymity offered by the Tor network. Therefore, it's going to be more private and more anonymous. In this method, we're going to be using a tool called Onion Share. And to put this simply, the way this will work is it'll create an Onion service on your computer so others can access this Onion service and download your file. So you can think of it as if it's creating a dark web website on your local computer, and this website can only be used to download the files that you specify. To make this simpler, you can think of this as the user that wants to download your file. And we all have seen this diagram of the Tor network and how when you try to access a hidden service, you go over 3 nodes. The user that you want to share the file with will end at an Onion service that is sharing your file. and this Onion service is running from your own local computer, so the file is shared directly from your computer, and you can shut down this sharing service whenever you want, whenever you feel that you don't want to share the file anymore, or whenever you feel like your connection is being compromised. So as you can see in this example, we are not uploading our file to a server that we do not own or do not control. Therefore, it fixes the main issue with the method that I showed you with the Firefox service, and it benefits from all of the encryption implemented by the Tor network. Therefore, it's more private, more secure, and more anonymous. Now, doing this is actually very simple in Tails. So let me show you. I'm back at my file manager. I have the picture or the file that I want to share right here. And all you have to do is right click this file and click on Share via Onion Share. As you can see, this will open the Onion Share window for you. You can see the file that I selected is already in here, and you can click on Add Files to add more files to share with a specific person. You can add a full folder by clicking here, and you can use the delete to delete files. You can also see the checkbox in here ticked, stop sharing automatically. This basically means once someone downloads this file, the sharing will stop automatically. You can untick this to keep sharing the file until you manually stop it. Once you're happy with the files that you want to share, we're going to click on Start Sharing. And right now, when you see the yellow dot in here, this means that Onion Share is creating and starting the Onion service that will share the files for you. So you want to be patient with this. It might take some time. And once this is done, as you can see, the circle will turn green and you will see a link to a hidden service. So you can see this looks very similar to the links that we use when accessing darknet websites. You can click on copy URL to copy it, and then you can share this link with anybody that you want to share the file with. So you can send it via email, or you can send it using an instant message like what I'm going to do right now. So I'm going to paste the link in here. I'm going to hit enter to send it, and then I'm going to go to a second computer. We're going to pretend that this is the recipient computer. As you can see, they got a message with a link in here, and all they have to do is click on this link. Now keep in mind, this is a hidden service or an Onion service link, so it can only be accessed using the Tor browser or using a computer that is configured to use the Tor network. So this service is only accessible within the Tor network. As you can see, once this loads, you will get a very simple page. It has the file name, it has the size, and if you click on download, it will download the file for you. I'm going to click on save, and this will automatically go to the Tor browser directory. I'm going to click on save, and perfect, the download is complete, and we can verify this by going here. Now, as you can see, the file has a zip format. It's not an image, and you will always get the file in a zip format when using Onion Share. So you have to uncompress this file, and to do that, we're going to right click the file, click on extract here, and go inside the directory that just got created. And as you can see, we have the image that we wanted to share. Now, if you actually go back to the computer that started sharing, you will see that in the status bar, it's telling us that someone has loaded the download page and that someone has downloaded the file. So if you actually ticked this box, this would have stopped sharing the file automatically because someone has downloaded the file. Or if you want to stop it manually, you can click on stop sharing to stop sharing. So now if anyone tries to access this link again, so if I refresh here, you'll see that this page will not load. Therefore, you have full control over the files that you want to share. You can start and stop sharing them anytime you want. The files will not be placed in any computer that you do not have control on, so it will only be placed on your computer, and you'll benefit from Tor's anonymity and privacy. Therefore, this is a much more private method of sharing sensitive files. So far, as we are going through the course, we interacted with the file system quite often. We also learned how to download and upload files, how to share files securely with friends and contacts, how to remove metadata that can be used to de-anonymize us or get information about us. So before moving to the next section, I think there is still one missing piece, which is how to properly delete files and wipe storage media. Now, in general, in operating systems, when you right-click a file and delete it, or even if you shift delete it and empty your recycle bin or your trash, the file doesn't actually get deleted. What happens is the operating system marks the file or marks the space that the file was occupying on the storage device as available. So the data of that file will still exist on your storage device until that space is overwritten with other data. That's why we see so many tools that are very easy to use that you can use to recover deleted files. Now, these are very simple tools that you can download from the internet for free, so you can only imagine what a resourceful adversary can do. So, because deleting a file doesn't actually delete the content of it or its data unless it's overwritten with other data, there are tools that will randomly fill up that space of that file with random data so that it's more difficult to recover that file. Now, Tails comes with such tools pre-installed as you'd expect. So if we go to our file manager and go to the file that we want to delete, so in my case, it's in files and it's this image right here. Now I can right click the image and just click on move to trash, which will literally just move it to trash similar to any other operating system. And then I'd have to go to the trash, right click and empty. And like I said, this will still not delete the content of this image or the data of this image from my storage. The better option to go to if you want to securely remove this file is to click on wipe right here. Now, if you click on that and expand the options in here, you'll see that it'll ask you for the number of passes of random data that will be executed to overwrite the location that contains the data of this image. So by default, this is set to 2, which should be good enough for most hard disks. You can set it to 38 for older ones, or 1, which is not very secure, which will only protect you from the very simple software that you can download on the internet. Now, this method will work on hard drives, but it won't work on USB sticks or solid-state drives. Now, if you don't know the difference between hard drives and solid-state drives, then I highly recommend you go and do some reading on that. I will include links in the resources of this lecture. But basically, the way that solid-state drives work, they don't have sectors. They use cells in order to store your data. And even if we use a tool similar to this tool right here in order to overwrite a specific location of this solid storage device, the logic inside the storage device will probably overwrite the request that we make in order to increase the life of the device. Therefore, you might use this click on wipe and think that it worked, but it might actually not work as you'd expect it. So you can only properly rely on this method if you're using a hard drive and not a solid state drive or a USB device. Now, that's for removing one specific file. But what if we wanted to clean all the free space or all of the available space on the system? Now, this is only relevant if you're using persistence, obviously. And you might want to do this because you've deleted a number of files insecurely, so by literally moving them to trash and emptying the trash, and then the contents of these files, like I said, will still be recoverable from your storage device. Therefore, what you want to do is you want to right click any empty space in your file manager, click on wipe available disk space, and you'll get a very similar window to the one that we just got with the same options. And once you set the options, you click on wipe, and that'll clean and that will securely clean the available disk space. So it won't delete the files that you have, it will only clean the available disk space, filling it with random data to make sure that it can't be used to recover the files that you deleted. So it will only clean the files that you deleted. It won't affect anything that you already have on your storage device that you did not delete yourself. Now this is great, but again, it won't work as expected when it comes to solid state devices and to USB devices for the same reason that I mentioned earlier. Therefore, if you're using a solid state device or a USB device and you want to securely delete all of the data that you have on it, then you have two options. First option is physically destroy that device, so you can burn it, put it in a microwave, do whatever you want really. Or the other option is to securely format the device and wipe it. And I'm going to show you how to do that in the next lecture. Now, in this lecture, I'm going to show you how to securely format and wipe a USB device and encrypt it, so everything stored on that USB device will be unreadable unless you know the passphrase used for the encryption. And to do this, again, Tails comes with pre-installed tools that allow us to do this. All we need to do is go to Applications, Utilities, and we're going to go to the disk utility right here. Now this utility can be used to format and encrypt any storage device connected to your computer right now. So as you can see right here, it's listing all of the storage media that I have connected to this computer. And as you can see, even if we look here on my file manager, you can see that I have an 8 GB volume. This is another USB device, not the one that I'm using to boot Tails. And let's assume that I want to securely wipe everything that is in here. To do that, we're going to go and select it from here, from the left. And in here, you can obviously unmount it. You can delete the selected partition, or you can click on the cogs here to get more options. And what I want to do right now is format the partition. And when you click on format, you'll see the first option is the erase option. So this is set to don't overwrite the existing data, which will be quick, but it's not secure because, like I said, it'll only mark the locations for available for writing, but the data will still be available and it'll be easily recoverable. Therefore, if you want to securely wipe your device, the selected device in here, you want to click on this and set it to overwrite existing data with zeros. This will be slow, as you can see, but it'll overwrite everything with random data, which will make your previous data that you stored on it harder to recover. The next option in this window is the file system type that will be used on the storage device. Now, you usually see this in any operating system when you try to format a storage device. You can set it to whatever type you want, as long as this type is compatible with the operating system that you're going to use it on. You can use FAT or NTFS for Windows, ext4 for Linux. Then set the name of the storage media and click on Format to format it. Now, this whole application can also be used to encrypt your storage media after formatting it, so that whenever you store data in it, everything that you store will be encrypted and nobody will be able to read it unless they know the passphrase used to encrypt it. So it's similar to the way the persistence storage is configured on Tails, because as you remember, when we set it up to use persistence, I said that this will be an encrypted storage, and we set a passphrase that we need to use in order to unlock the persistence part. So this is very similar in here. You can use this program to encrypt a whole USB device. And to do this, you just need to click here on the type and set it to encrypted compatible with Linux systems, which will use Luke's encryption. Now, when you click this, as you can see, again, you'll have to fill up the name. So let's say encrypted drive. And then we'll have two new input boxes asking us for the passphrase that will be used to encrypt the storage device. So you can pick any strong passphrase you want. click on format. It's going to ask us to confirm that we're formatting the right drive, because keep in mind, this will remove everything that is stored on this device. It will securely remove that actually to make it very difficult to recover, and it's going to encrypt it so that whatever we store on that device will be unreadable unless the right passphrase is used. Now I'm going to say yes, I want to do this. I'm going to click on format. Give it its time, because like we said, this will not just remove the files, it'll overwrite everything that's there on the device with random data and then remove this random data to make sure that our previously stored data is very hard to recover. Once it does all of this, it'll also encrypt the storage so that everything we have on it is unreadable without the passphrase. Now once done, you'll see the loading circular icon is gone from here. So that means that the device has been securely wiped and encrypted. So what I'm going to do right now is I'll close this, and I'm actually going to disconnect it from this computer just to show you what happens when you go ahead and connect it to a computer. So I'm going to physically remove it now from my Tails computer, and I'm going to connect it again. And as you can see, it appears in here again on the left saying it's an encrypted device. And if I click on it, you'll see that I can't open it. I can't see its content because we encrypted this device. And like I said, it's not going to be accessible unless we know the passphrase in order to decrypt it and see its content. So I'm going to put the passphrase that I set when I encrypted the device. I'm going to click on unlock to unlock it. And only now, as you can see, the lock is gone and it opened the device for me. Now, obviously, it's empty because we just wiped it and we securely wiped it. So the data that previously was stored on it should be very difficult to recover. And now, if I put any data on this and disconnect the device, even if someone manages to get their hands on the device and read the content of it, the contents will be gibberish because everything is encrypted and it's not readable unless they know the passphrase. In the previous sections, we learned a number of methods to send and receive data privately and anonymously. This data can be simple text, or it can be files such as an image, a PDF, a document, and so on. All of these methods used end-to-end encryption, so if the data gets intercepted by any entity, the data will be useless to this entity because it'll be simply gibberish and it'll only be decrypted once it's received by the person that we want them to receive it. This is all great, but first of all, we have to trust that these methods of communication are implementing the encryption properly, that there are no problems or no flaws in the way that they're encrypting and decrypting the data. And what if we wanted to send data through a website or through a form of communication that does not support encryption? In this case, you'll have to manually encrypt your data and the person that receives the data have to manually decrypt it. Because this is very important, I decided to make a full section on encryption in this course. So in this section, first of all, we're going to learn about asymmetric and symmetric encryption. You're going to learn how it works and why we prefer to use end-to-end encryption. Then I'm going to teach you how to manually encrypt your data, again, whether it's text or files such as a PDF or a document or a song. You'll also learn how to decrypt this data once you receive it. You'll learn how to sign this data, so when a person receives this data, they can confirm that it was actually sent by you and not by someone else. And you'll also learn how to verify the signatures and integrity of the files and of data that you receive, so that you know that this wasn't played with as it was sent to you, it wasn't tampered with, and to make sure that it was actually sent from the sender and not someone else. So you can use this as another layer of encryption on top of the other methods. So even if you're using a method that supports encryption, you can manually encrypt and decrypt the data just to make sure that your files or your data is as private as possible. And you can use this, like I said, to send files and to send data using unsecure methods of communication.
even using normal post, and you'll know if this data gets intercepted. It's still secure and it's still private because whoever intercepts it will not be able to read it because it'll be encrypted and it'll be gibberish. In this section and in the next lectures, I'm going to show you how to use PGP to encrypt and decrypt texts, files, emails, and we're also going to use it to sign and verify the integrity of files, emails, and so on. This way, we'll be able to communicate safely because everything we'll send and receive will be encrypted, and we'll be able to verify the integrity of the data being sent. So we'll be able to sign whatever we send, and the receiver will be able to verify that this data has actually been sent from us and has not been tampered with. Now, the reason why we're going to use PGP for encryption and to verify integrity, because this is a very strong encryption that stood the test of time and has not been broken yet. Even based on leaked reports, it seems like even government agencies are not able to break it yet. So it's a very, very strong encryption. Even though PGP stands for pretty good encryption, this statement is actually sarcastic because this is a very strong and powerful encryption. Now, in this lecture, I want to explain to you how PGP works in general, and then in the next lectures, we'll see how we can use it to encrypt all sorts of data and how to use it to sign and verify integrity. Now, PGP is a public key or an asymmetric encryption. And to understand how that works, let's first have a look on the other traditional type of encryption, symmetric encryption. So let's have an example where we have two people, David and John. We're going to forget about how they're going to communicate. We're just going to assume that David wants to send a message to John, and the content of this message is secret message. Now, if David wants to protect his message from anyone who might intercept this message or read it, he can use an encryption key in order to encrypt this message, and this will transform the message into gibberish. Then he can go ahead and send this message to John using any method, by sending it as an email or by post or as a text message. It doesn't really matter. And if this message gets intercepted, the contents of the message is going to be gibberish, so it won't be useful to the person intercepting this. John will receive the message, he will open the message will still be gibberish, and then John is going to use the same encryption key to decrypt this message and reveal its content, which was secret message. So, very, very simple. Basically, David uses a key to encrypt the message, John uses the same key to decrypt it, and this way, they're both able to read the message, but anybody who does not have the key will not be able to read the message. So, the same key is used by David and by John. Therefore, this is known as symmetric encryption. Now, you probably guessed it by now. This key needs to be private. That's why it's known as a secret key, because anybody who manages to get his hands on this key, they will be able to decrypt any message that David sends to John and vice versa. So, based on everything that we said so far, we can see that the secret key can be used to decrypt the messages. Because of that, it should be kept a secret. But David somehow has to share it with John and anyone else David wants to communicate with. Therefore, this is a major flaw with symmetric encryption, because the key has to be secret, but at the same time has to be shared, and sharing it with more people increases the attack surface, not to mention the problem of sharing the actual key. How are we going to share it? Are we going to send it in a separate message? What if that message gets intercepted? What if we're sending stuff over the internet and we know how many hops our data could pass by? This could be intercepted, read, and then the rest of our communication will be decrypted. This was the main incentive to come up with a more secure encryption. And this is where asymmetric or public key encryption comes. So let's go back to David wanting to send a message to John, and the content of the message is secret message.
In asymmetric encryption, one key is used to encrypt the message is sent in the air, and then another key is used to decrypt the message. So as you can see in this encryption, two different keys are used, and hence the name asymmetric encryption. Now these two keys are referred to as a key pair. They are mathematically related. One is used for encrypting the message and the other is used for decryption. Therefore, the decryption key is never shared, and that's why it's more secure. Now you're thinking, if the decryption key is never shared, how is this going to work? Well, let's go back and have a closer look on how this is going to work. So again, David wants to send a message to John. The content of the message is secret message. But before sending this message and before encrypting it, John is going to create a key pair, a public key and a private key. Like I said, these keys are mathematically linked, and John is going to send the public key to David, to the person that will send the message. So the public key can be shared with anybody. You can actually make it public on the internet, on key directories. It doesn't really matter because it cannot be used to determine the private key. Therefore, it's completely safe to share the public key. So David receives the public key. He uses the public key to encrypt the message. The message is sent using any method. It doesn't really matter. And even if it's intercepted, it's going to be gibberish. John will receive the message. He will open the message. The message will still be gibberish, but he will use the private key to decrypt this message. This way, he will get the content of the secret message. And as you can see, the private key was never shared. John created the private key and John kept the private key. The only thing that is shared is the public key, which cannot be used to determine the private key and cannot be used to decrypt the message. It can only be used to encrypt the message. So by the end of the communication, David is going to have John's public key and John is going to keep their private key. Therefore, now David can always send messages to John and John will always be able to decrypt them using his own private key. Not only that, but when David encrypts something with John's public key, he can be rest assured that nobody can decrypt this message except for John, because John is the only one that has the private key, and his private key should never be shared if John knows what he's doing, because there is no point of sharing it. Even if he wants 100 people to send him messages, all he has to do is share his public key and not his private key. Now, if John wanted to send something to David, the same can be done in an opposite direction. So David would create a key pair. He would send John his public key, and then John would use David's public key to encrypt messages. When David receives them, he will use his own private key to decrypt them. So the idea is very, very simple. You share your public key, hence the name public. That is completely safe because it can't be used to determine the private key and it can't be used to decrypt the messages. So you share the public key, and anyone who wants to send you a message, they will encrypt that message with your own public key, and this way you will be the only one that can decrypt this message. Same goes when you want to send another message. For example, if you wanted to send a message to me, all you have to do is encrypt that message with my public key, and this way, because I don't share my private key with anyone, I will be the only one that can read the message. So you can put this message anywhere, you can share it publicly, and it'll still be safe because no one will be able to read that message but me. Now that we understand how PGP works, in this lecture and the next few lectures, I'm going to show you how to use it to encrypt all kinds of data, verify integrity, and so on. Now, as I explained in the previous lecture, for this to work, the receiver, which is John in this case, has to first generate a key pair, a public key and a private key. He will share the public key with the person who he wants to receive data from. That person, who is David in this example, will use the public key to encrypt the message, send the message to John. The message will be unreadable unless the private key is used to decrypt it. And as you can see throughout this whole scenario, the private key never left John. So John never shares the private key, and it is the only key that can be used to decrypt the data. Therefore, this implementation is very, very secure. So, like I said, the first step for this is the receiver needs to generate a key pair, a public key and a private key. So, in this lecture, I'm going to show you how we can create our own key pair so that we can share our public key with the people that we want to receive data from, and then they can use this public key to encrypt data and send it to us so that we are the only ones that can decrypt this data because we have the private key. So, in Tails, this is actually very, very easy. You can do it using the clipboard applet that we have in here on the top right. So you can click on it and go to Manage Keys. Now, in the recent versions of Tails, they've been moving this all over the place. So if you can't find it here, we can go to Applications, Utilities, and click on Passwords and Keys. This will open a program that can be used to manage all your passwords in Tails, but what we're interested in is managing our GNU PG keys. Now, clicking on this, as you can see, we have a number of entries by default. Do not delete these entries. These are actually keys used to verify the integrity of updates that Tails downloads and the integrity of packages that you can download through Tails and install on your system. So if you delete them, you won't be able to verify the integrity of these packages. So we're keeping everything here the same. And what we want to do, like I said, is create our own key pair so we can share our public key with others, so we can receive encrypted data that can only be decrypted by us. To do that, to create a key pair, you can click on the plus sign in here, or you can go on File, New. Like I said, this application allows you to manage all sorts of keys. What we're interested in is creating a PGP key. So I'm going to click on the second entry here, and I'm going to click on Continue. Now it's going to ask you for your name. So in my case, I'm using John Wick. Next, it's going to ask you for your email address. Now, it is very important to understand that the people that you'll share the public key with will be able to see your name and your email address. Therefore, if you want to stay anonymous and protect your privacy, make sure you use the fake name that you created when you created your fake identity, and make sure you use your private or anonymous email in here. In my case, it's jnck7@elude.in. We're also going to click on the advanced options to select the encryption type. I'm going to keep this at RSA because this is a very strong encryption. We're going to set the key strength to the highest possible, which is 4096. And you can also set an expiry date so that your key expires at the date that you specify in here. Now, this would be good if you want to take your security to the next level, but for this course, it's fine. I'm going to set it to never expire. I'll keep this ticked, and I'm going to click on Create to create my key pair. Now, it's going to ask me to set a passphrase for the key. Make sure you set a strong and long one. Click OK. And this program is going to generate your key pair. And as you can see right here, we have a new entry with my key pair. Now notice the icon here for this key pair contains two keys, a silver and a gold one. This means that this is a key pair. It contains a private key and a public key. Notice all of the other entries in here contain only one gold key, which means that these entries only contain a public key. So these can be used to encrypt data for someone else or verify the integrity of data, but there is no private key stored in here. Now, to get more information about any of these entries, you can right-click and click on Properties. And in here, you can see information about the owner. For example, the name, John Wick, like we said it. The email, again, the same email that we set it to. You can see the key ID, which can be used to verify the key, and we'll talk about that later. And if we go on the details, you'll also see the fingerprint, which can also be used to verify the key. We actually used this when we downloaded the Tor browser, if you remember. And as we go through this section, actually, you'll see how the verification steps we followed to verify the Tor browser make sense. And all of this will click with that. Now, from here, you can also export your secret key, which is something that you should never do because, like I said, we should never share the secret key. The secret key should always be kept privately. The only time that you might want to do this is if you're going to completely wipe the system and still want to use the same key. You might want to export this, store it in an encrypted USB device, and then put it on your next installation. Other than that, there is no need to export your key from here. From here, you can also set the expiry. So as shown before, we set the expiry to never, but if you change your mind, you can click on this icon and set the key to expire at any date you want. And going back to the names and signatures, you can see again your name and the email associated with this key, and you can click on add name to add more contacts to be associated with this key. But like I said, be very careful when you're doing this because these contacts will be visible to anybody that can see your public key. And like I said, in general, we will be sharing our public key with a lot of people because this is the way this works so that they can encrypt data and send it to us. So now that we have the key pair created, in the next lecture, we're going to talk about how to share our public key with our contacts, and then we'll see how that can be used to encrypt data and verify integrity. Now that we have our key pair generated, the next step is to share our public key with the people that we want to receive encrypted messages from, so that they can encrypt messages using our public key so that we will be the only people that can decrypt these messages because we have the private key. So in order to do this, you need to come to your passwords and keys. Like I said, you can access this from applications, utilities, and click on passwords and keys. As you can see, I have it already opened and I already selected my key pair, which I created in the previous lecture. Now, in order to export the public key, now keep in mind, we're exporting the public key, not the private key. We never share the private key, hence the name private key. So we're going to go to File, we're going to click on Export, and you need to select the location where you want to store your public key in. Now, I'm going to select my Tor browser directory because I want to share this through email, so I want to add it as an attachment. And as we know, the Tor browser can only access the Tor browser directory in Tails. That's why I selected this directory, but you can store it anywhere you want. Now, I'm also going to change the format from PGP to armored PGP. This won't really make a big difference. The reason why I'm doing this so that I can show you the content of the key as plain text. So we're done here. I'm going to click on export and that's it. It's done. So if I go to my home directory and go to Tor browser, you can see we have a file called johnwick.asc. And this is my public key that I can share with anybody so that they can encrypt data and send it to me. Now, you can literally attach this file the way it is. You can upload it to a file sharing service like I showed you, or use Onion Share. You can use any method of sharing this file. If you don't want to share it as a file, you can also right-click it, select Open with Other Application, select View All Applications, and select your text editor to open it with the text editor. If I click on Select here, you'll see we'll be able to read the file as normal text, and this way you can literally copy all of this and paste it anywhere you want. So like this, you can share the key without having to upload the file or attach it anywhere. You can copy this text, send it as an instant message, print it on a piece of paper and give it to someone. You can do anything you want with it. So you have two ways of sharing it. You can literally copy this text and send it to the person that you want to receive encrypted data from, or you can attach this file right here. And like I said, you can use any method of communication. It doesn't really matter how you send it. Now, just as an example, I'm going to be sending this as an email. So I've already logged into my webmail, as you can see in here. And what I want to do is send a message. So I'm going to click on compose. I'm going to put the email of the person I want to send this to. So I'm sending this to another email account that I own for David Smith at elude.in. I'm going to set the subject and I'm going to call this my PGP key. And then you can write anything here if you want in the message. So we're going to say, please find my PGP key below. And you can literally just paste all of the text that you copied in here, like I said, and then they'll be able to use this key as text to encrypt data to you. And we'll see how you can do that. This is the first method of sharing your key. Like I said, you can also share the key file that we exported. To do that, we're going to use an attachment. So again, I'm going to click on browse and select the key file that we have in here. We're already in the Tor browser directory. So you just double click this and that's added to the attachment. Now, like I said, you don't need to send both. I'm just showing you both here as an example, but only sending the key as a file or as text in here is enough for the other person to start encrypting data for you. Not only that, but you can even add this key to your signature. So every time you communicate with someone, they will see your public key, and if they wanted to, they can encrypt the data that they're sending to you using your public key, and this way nobody can read this data except you. A lot of people even put this in their profile page in forums and even in markets. So if you click on a certain account, you'll probably see their PGP key pasted like this, so that when you communicate with them, you would use this key to encrypt the data, and that way they will be the only people able to read the message because you encrypted it using their public key. So the whole idea is you want to share this with anybody that might want to communicate with you, so that when they send you something, you will be the only person able to read what they sent you. So we have the key here, we have it attached, we've already set the email and the subject. So I'm just going to click on send to send this email. And I'm going to go to the other computer. This is David's computer, the person that is supposed to send messages to John. As you can see, I'm already logged into the email account as well. I'm going to refresh to see if I got anything in my inbox. And as you can see, I have a new message. We're going to go to the inbox. And this message is coming from John Wick. Perfect. So we're going to click on it. And again, as you can see, we have the key in both forms as an attachment and as text. So now this is David. And if we go back to our diagram, David is the person that wants to send an encrypted message to John. So what John did is he created a key pair. He sent John the key pair. So we have the key right here. What we need to do right now is download the key. And in the next lecture, I'll show you how we use it to encrypt the message. So let's go ahead and download the key. So we have it in here as an attachment. All we have to do is click on download. And as usual, if you click on save, this will only allow you to save it in the Tor browser directory, and it's called johnwick.asc. So I'm going to click on save to save it there. And if we go to our home directory, go to Tor browser, you will see we have the key saved right here. Now I'm actually going to remove this because I also want to show you how to download the key if it was sent as plain text, if it was not sent as an attachment. So we're going to assume that you just got the key like this as text. So if you want to save a key that you got it like this, for example, if you got it as an instant message, or if you saw it on a forum or on an account where the user was sharing their public key so that you can encrypt messages for them. In that case, if you want to start sending encrypted messages to this person using this key, you want to make sure, first of all, you copy the whole key from the start here all the way down to the end. I'm going to right click and copy. And then you want to open a text editor. So we're going to go to accessories. We're going to open our text editor. We're going to paste everything that we copied in here. We're going to save, Control S or click here. And you want to store this in any location that you want. Now, you don't really have to put it into our browser. I'm just going to put it there anyway. And we're just going to call this John Wick again .asc. We're going to click on save. And again, we have the file now. If we go back to this directory, we have the file, the johnwick.asc, and inside it, it has the content of the public key of John. Now, all we have to do is import this public key to our keyring. To do that, again, we have to open the passwords and keys here. And we're going to go to File, Import, and select the key that we want to import. If you couldn't see it here, then make sure you go to the location where you downloaded it. So in my case, it was into our browser. And again, we have the key that we want to import in here. Click on Open. It's going to show you the information of this key. Again, like I said, remember, I said anybody who has access to this public key will be able to see your email address. And as you can see, we can actually see John's email address right here, and we can see his name right here, John Wick. That's why it's very important to use your anonymous or fake identity in here. We're going to click on Import to add this key. And now if we click on our GNU PG keys, as you can see, we have John Wick as an entry in here. And as you can see, John Wick in here has an icon of one gold key. We don't see two icons. Going back to John's computer, if we go to the passwords and keys in here, you can see John has two keys in here because this is a key pair. John has his own private key and the public key. But at David's computer, David only has the public key, and that's why we see only one gold icon in here. Again, if you right click this and go to properties, you'll be able to see the name and the email of the key owner. You can see the key ID, and clicking on details, you can see the fingerprint, which, like I said, can be used to verify the owner of the key. And we'll talk all about that later on in the course. For now, we have imported the public key of the person that we want to communicate with. So right now we can start encrypting data and send it to John. And the only person that will be able to see the content of this data is John, because he is the only person that has the private key. Now, so far we have David who wants to send a secret message to John. To do this, John generated a key pair. John also sent the public key to David. David has downloaded the public key and imported it into his key ring. So if we go to David's computer right here, we can see he has John's public key. So right now, David can encrypt data with John's public key, send it to John, and that way John will be the only person who can decrypt this data because he is the only person that has his own private key. Now you'll also notice an extra entry in here. I've actually created a key pair for David in this section right here for the sake of completion. You don't have to do this because, like I said, all we need is John's public key to send data to John. And according to the example we're doing, David will be sending data to John. So all we need is John's public key. I just created a key pair here for David just for the sake of completion so that you can see how this will work in a real life scenario. So we actually don't need to use this anymore because David already has the public key of John. So all you have to do is literally start typing the message that you want to send. To do this, I'm just going to open a text editor. So again, we're going to go to accessories, we're going to open my text editor, and I'm just going to start composing the message. So for this, we're just going to say, hello, this is a secret message sent from David to John. Now, before sending this, we're going to select all of this text, we're going to copy it, and then we're going to go to the clipboard applet, and we're going to click on Sign Encrypt Clipboard with Public Key. We're going to click on this, and as you can see, you get a list of all of the public key that you have on your computer. Now, like I said, all of the ones that start with tails are default public keys added in order to verify the integrity of packages downloaded from tails. You don't want to select any of these. You want to make sure you select the contact that you want to send the message to. And in our example, we want to send the message to John Wick. Now, this is perfectly fine. You can just select it like this and click on OK to encrypt the message. But in this case, even David, so even the sender won't be able to see the contents of the message. If you want to be able to decrypt the contents of the message yourself as well, then you should tick the entry for your own key. So this is David's computer, and if David wants to still be able to see the contents of the message that he's gonna send, he should tick this box. Otherwise, we can just tick John, and the only person in the world that will be able to read the content of this message will be John or anyone who has the private key. But if John is using PGP properly, he should never share the private key with anybody, and therefore, when we encrypt a message with his private key, we can be sure that John will be the only person that can read the content of this message. So, we're gonna click on OK. It's going to ask us if we trust this key. We're going to say yes, we do trust it. And as you can see in here, you can see the icon of the clipboard has changed to indicate that the clipboard right now contains an encrypted text that represents the text that we copied already. So if in the same text editor in here, if I just paste whatever that is in my clipboard, you will see I'll get an encrypted message. And this is basically the content in here encrypted using John's public key. So right now, you can just copy all of this and send it to John using any method of communication. So you can send it as an instant message, you can send it in a chat room, you can send it as an email, you can even put it in a paste bin publicly where anybody can see your message, where anybody can see your secret message. This is the beauty of PGP. You can put this anywhere and nobody will be able to see or read the content of this unless they have the private key of John. And like I said, if John is using PGP properly and he knows what he's doing, he should never share his private key. Therefore, he will be the only person in the world that is able to read the content of this message. Now for this example, to make things easy, I'm going to go back to my email client and I'm just going to reply to this email and we'll put our encrypted message in here. Keep in mind, I'm copying it from the start to the end. I'm going to click on send and that's it, sent to John. So let's go to John's computer. We're going to go to his email account. We're going to refresh the inbox and we're going to click on the message that we just got. And as you can see, this message is encrypted. It's gibberish. We can't really see what David is trying to tell us. So we're going to right click and copy this message. And as soon as we copy it, you'll notice the clipboard icon in here again changes to indicate a lock, to indicate that the clipboard contains encrypted text. We're going to click on this and we're going to say, I want to decrypt or verify my clipboard. it's going to ask me for the passphrase for my key, for John Wick's key. Remember when we created this key, we had to select a passphrase, and that passphrase will always be required before you can use this private key. So I'm going to put the passphrase that I set when I created this key. I'm going to click on OK. And perfect. As you can see, we can see the contents of the message saying, hello, this is a secret message sent from David to John. So that's pretty much it. As you can see, the receiver shares their public key with the sender uses this public key to encrypt the message, and then they can put the message anywhere or even share it publicly. It doesn't really matter because the only person that can read this message is the person who has the private key. The private key never gets shared. Therefore, this is a very, very good and secure implementation. So now, in this example, John created the key pair, he shared his public key with David, and David was the one encrypting the message and sending it back to John. Now, if John wants to send something back to David, we just have to do the reverse of the process. So David will just have to create his own key pair, share the public key with John, and then John will be able to encrypt messages and share them with David and know that David would be the only one able to read the contents of the messages sent to him. So far, we learned how to use PGP to encrypt messages so that only the receiver can read the content of the message. To do that, the sender, David in our example, uses the public key of the receiver. So the receiver makes their public key public, as the name suggests. That's fine because the public key cannot be used to decrypt messages. It can only be used to encrypt messages. So David encrypts the message with the receiver's, John's, public key. The message is sent. And when John receives it, he uses his own private key that he never shares with anybody to decrypt the message. Therefore, David can send the message to John in any way he wants. He can send it as a text message, as an instant message, or even using an insecure service. That's fine because if anybody reads the message, they will see gibberish. They won't be able to see the content unless they have the private key. And as long as John doesn't share the private key, there's no need for him to share it, then nobody will be able to read this message except for John. So that's really, really good. The only problem here is that there is no way for John to verify that the message that they received has actually been sent from David. So like I said, for this to work, John needs to make their public key public. So getting the public key of John is easy. Therefore, John could have it in his signature in his email. He can have it in his signature in a forum. He might have it publicly shared because he wants people to send him encrypted messages. So there is nothing wrong with making your public key public. The only problem is someone can come in, pretend to be David, use John's public key to encrypt a message and send it to John. And that way, John has no way of knowing whether this message did actually come from David or not. To solve this problem, David will have to sign the message. This can actually be done with PGP. So let me show you how this will work with this example. So again, we have David. He wants to send a secret message to John, and as we learned before, the first thing that David will do, he will use John's public key in order to encrypt the message. The message will change into gibberish. Now, at this stage in the previous lecture, we sent the message, but this time, David is going to sign the message with his own private key. So he still hasn't sent the private key. The message is still at David's end. And what he's going to do is he's going to create a signature for this message. This signature corresponds to this message, and if anything gets modified within the message, if one letter gets modified, the signature will change. Therefore, this signature can be used to verify that the message has not been modified since it got signed by David's private key. Now keep in mind, David is still keeping his own private key. He did not send it through any method of communication. So now we have a message with an encrypted content and with a signature that corresponds to David's private key. Then the message is sent using any method of communication. Like we said, you can even use an insecure method of communication. John is going to receive the message along with its signature. And before decrypting this message with his own private key, what he's going to do is he's going to use David's public key in order to verify the signature. So like I said, the signature was created with David's private key, and then John doesn't have David's private key, but he's going to use David's public key to verify the signature. If the message was not modified, the verification will be successful, and this way John will know that this message was actually sent by David and was not modified by anybody, because like I said, if one letter gets modified, the public key, David's public key, will not verify the signature. So when the signature is verified, we know that David was the actual sender of the message and the message was not modified as it was sent, whether it was sent over the internet, as a text message, or using any other method of communication. The next step is very similar to what happened in the previous lecture. John will use his own private key in order to decrypt the message and read its content, which is just secret message. So as you can see, as a result of this, each party still kept their own private key. Nobody sent their private key to the other party. So the sender encrypts the message with the receiver's public key and signs the message with his own private key. The message is sent, the receiver verifies the signature with the sender's public key and decrypts it with his own private key. This way, he can verify that this message came from the sender, he can verify that the message did not get modified as it was sent, and the message is encrypted, and the only person that can read it is the receiver because he kept his own private key private and it was not shared with anybody. Now, all of this should become clearer in the next lecture, as I'm going to show you how to encrypt messages and sign them as a sender. And I'm also going to show you how to verify the signature and decrypt the messages as a receiver. Now that we understand how signing works in PGP, in this lecture, I want to show you how to encrypt messages and sign them as the sender, and how to verify the signature as a receiver and then decrypt the message. So right here, I have John's computer, and let's go ahead and send a message to David. So as we've seen before, the first thing you want to do is open up a text editor, and we're going to type the content of our message. So I'm just going to say this is a secret signed message from John to David. Now, like we've seen before, I'm going to select all of this. I'm going to copy it. I'm going to go to my PGP clipboard, and I'm going to click on Sign Encrypt Clipboard with Public Keys. Next, we want to select the public keys that we want to encrypt the message with. And like I said, I'm sending this message to David, so I'm going to tick him. You can also tick John if you want to be able to decrypt your own message. And unlike what we did in the previous lecture, before clicking on OK, I'm going to go to Sign Message As. If you click on this list, you will see a list of all of the private keys that you have on this computer. So this is John's computer. And as you can see, the only private key that we have is John Wicks. So I'm going to select that and I'm going to click OK. It's showing a warning about the key. It's my own key, so I trust it. So I'm going to click yes. And then it's going to ask you to enter the passphrase that you selected when you created this key. I'm going to hit OK. And as you can see right here, the icon of the clipboard changed to a lock, which means that now in my clipboard, I have the encrypted message along with the signature. So I know in my diagrams in here, when we were sending the message, I said we're going to send a message with its signature, but in reality, both the message content and the signature is all going to be one block of text. So if I'm back here at my text editor and just paste whatever that is in my clipboard, you'll see we'll just get one block of text that contains the content of the message and the signature. So as we did before, I'm going to go to my email I'm going to compose a new message, and I'm sending this to David Smith. And I'm going to paste the message along with its signature, like I said, and I'm going to click on send to send the message. Now, let's go to David's computer, refresh our inbox, and click on the new email. We have the message contents. So again, we're going to select all of it, right click, copy. And as you can see right here, we can see the lock on the PGP applet. One click on this, and we're going to click on decrypt verify clipboard. So the steps are very, very similar to what we did in the previous lecture. Now it's going to ask me to enter the passphrase for my own key, for David Smith's key. And as you can see, we see the content of the message. Again, very similar to what we've seen in the previous lecture. But at the same time, you can see at the bottom in here, it's telling us that this message has been signed with a good signature of John Wick. We can also see the key ID and the key fingerprint. So right now, we're sure that the person that encrypted this message, the sender, is actually John Wick, and it's not someone else that is pretending to be John Wick. Not only that, but we're also sure that the contents of this message was not modified as it was transmitted to us. Because like I said, when data is sent over the internet or over a lot of methods of communications, it passes through a number of hubs, and each one of these hubs could be modified. Not only that, it can also be intercepted by a number of methods, and when hackers or agencies intercept them, they can modify them, implant data, or remove some data. Therefore, when the signature checks out, as we can see in here, if it's verified, that means that the message was not modified since it was signed by John's private key. Now you can also see that there is a warning saying the key is not certified with a trusted signature. This is fine. You can actually ignore the message. It's just because the key is not set to be trusted. But what's really important in here is to see if this is a good signature, because like I said, if it says it's a good signature, that means that the message was signed by John's private key and it did not get modified since it got signed by his key. So right now we have a method to send data in a way so that even if it gets intercepted by any party, they won't be able to read it. The only person that will be able to read it is the receiver. Not only that, but the receiver will be able to verify that this was sent from the person that they want the message from, so they can verify the sender and verify that the message did not get modified as it was being sent. Okay, so far we learned how to use PGP to encrypt text and send it in a way so that the receiver is the only person that's able to read the content of the text. Not only that, but we also learned how to sign the message, to sign the text, so that the receiver can verify that this message was actually sent from us, from the sender. So it's really, really good, because now when a message is sent, we're sure that it can only be read by the receiver, and the receiver can be sure that it was actually sent from the sender, and he can also verify that the message did not get modified as it was sent. So this is really, really good. The only problem is we can only do this for text. So what if you wanted to send a document or an image? Therefore, in this lecture, I'm going to show you how to encrypt, sign, verify, and decrypt files. So right here, I'm in John's computer. I have the image that we already worked on and removed its metadata before. If you don't remember how to do that, please go back to that lecture. And if I double click the image right now, as you can see, the image works. It shows us a picture of a car. Now, let's assume we want to send this message to David, and we want to send it securely so that if anybody intercepts this message or if anybody manages to read it, they won't be able to see the content of it. They won't be able to see the image. To do that, we're going to right click it and we're going to click on encrypt. Now you'll get a message that is very similar to what we used to get when we encrypt text. You need to select the public keys of the people that will be able to see the contents of this file. In my case, I'm sending this to David, so I'm gonna take David from here. And as we learned before, you can also sign the message from here and select your own private key. And that way, when the receiver receives the image, they can verify that the message or the image was sent from you by verifying it with your own public key. So I'm gonna click on OK. This will ask me for my passphrase for my private key because I selected the sign option. If you did not select the sign option, you will not see this. And once I put the password, as you can see, I will have a new image created. And this image doesn't really display, it doesn't really work. So if I double click it, you actually won't see anything in here. And the reason for that is because this image right now is encrypted and the only person that can see it is David. So we need David's private key in order to see the contents of this message. Therefore, like I said, right now we're in John's computer. So even John can't see the content of the image anymore. And what we're going to do is we're going to go ahead and send this as an attachment in an email to davidsmith@ilu.in. I'm going to scroll down. I'm going to select the image. And keep in mind, you want to make sure you select the encrypted image, not the normal image. So right here, we have the normal decrypted image. As you can see, we can see it in here in the preview. And right here, we have the encrypted version of it that will not work unless we have the private key of David. So I'm going to click on open and just say test in here in the content and click on send. Perfect. Now the message should be sent. So let's go to David's computer. We'll refresh the inbox. We have a new message. Perfect. Let's go ahead and open it. And we're going to download the attachment. Save it. It's going to go in my Tor browser directory. That's fine. Click on save. And let's go ahead and open the containing folder. And as you can see, we can't really see the contents of the image. Now, this is the same whether this was a PDF or a Word document or any file, really. I'm just using the image as an example. Now, in order to decrypt this message, because this is David's computer and because this message was specifically encrypted for David using David's public key, we can actually decrypt it right here because we have David's private key and we'll be able to see the contents of it. To do that, we're going to right click the image. We're going to click on open with decrypt file. This will ask you for the passphrase for David's private key. I'm going to input it. And perfect. As you can see, this will create a new file. This is the image after decryption. And as you can see in the middle, it said that the signature has been verified. So we're sure that this image was actually sent from John. Now I can double click the image to see its content. And as you can see, I'm able to see the contents of the message. So the idea behind this is very similar to the idea of sending text. We encrypt the message with the receiver's public key. If anybody manages to get their hands on this file, whether it's an image, a PDF, a document, doesn't really matter, they won't be able to read the content of the file unless they have the private key. Now, there is also one more feature that I want to cover in this lecture, which we can use to sign the file without encrypting it. So if you remember, when we downloaded the Tor browser, we also downloaded a signature and we used that signature to verify that the Tor browser did not get modified as we downloaded it. So you can also do this to any file you send by generating a separate signature. So again, you can do this to any file you want, whether it's software, whether it's an image, a PDF, a Microsoft document, it really doesn't matter. I'm using the image here as an example. I'm at John Wick's computer right now, and all you have to do is click the file that you want to sign, click on sign, It'll ask you which private key you want to use to sign this file. Like I said, I'm in John Wick's computer. The only private key that I have right now on this computer is John Wick. So the only entry I have in here is John Wick. So I'm going to click on OK. And as you can see, this will generate a new file with a .sig extension. This is a signature that corresponds to this file that has been generated using John Wick's private key. So people can use this file to make sure that the image did not get modified since this signature file was created by John Wick. And to do this verification, they'll use John Wick's public key. So the private key is used to generate the signature. The public key gets used to verify that the signature did not get modified. Now, if you're doing this, you will obviously have to send the signature file with the image file to the receiver. So let me do this really quick here. Again, we're sending this to David Smith. And like I said, you want to make sure you first select the file that you want to send, which in my case is the image, and you also need to select the signature. So I'm going to select the image first, and then click on attach. And then I'm going to select the signature file as well, like I said, and we're going to open and click on attach again. And right now we have the two files added to the message. I'm going to click on send to send the message. Now keep in mind, right now we did not encrypt the image. If someone manages to intercept this file, they'll be able to see the contents of the image. We only signed the image with a separate signature so the receiver can verify that the image did not get modified as we sent it. So go into the receiver's computer. Let's go refresh the inbox and we'll go open it. Open the new message. And let me actually delete what I have in here for now. And we're gonna download the image. And then we'll download the signature. And go into the downloads directory. As you can see straight away, we're able to see the contents of the image. So the image was not encrypted because all we did is we generated a signature for the image. So the whole purpose of this is to allow the receiver to verify that this message was sent by John and that the message did not get modified since John created this signature. To do this, you right-click the signature, and we're going to click on Open with Verify Signature. And as you can see, it's telling us that this is a valid signature. And like I said, the untrusted warning can be ignored. It literally just means that the key has not been set to trusted. But the fact that it is saying a valid signature means that this image did not get modified since John created this signature right here using his own private key. So that's it for this lecture. I just wanted to show you how we can use PGP to encrypt files, sign them, so that they can then be verified and decrypted at the destination. And this way we're able to send files securely, because even if they get intercepted while they're being transmitted, whoever intercepts them, they won't be able to read their content. Not only that, the receiver will also be able to verify that the file did not get modified as it was sent, and verify that it was sent from the right person, not from a third party. Now, before we wrap up this section, I want to spend one more lecture talking about another method to exchange keys between the sender and the receiver. So as we learned, we can use PGP in order to encrypt a message and make sure that this message will only be readable by the receiver by encrypting the message with the receiver's public key. Therefore, for this to work, for example, if David wanted to send a message to John, he would have had to get John's public key. Then, same goes for John. If John wanted to send something to David, he would have had to get David's public key. And to exchange the keys, in the previous lectures, we used email to send the keys from one person to another. Now you can use any method of communication, and like I said, sometimes if you're using a market or if you're on a forum, you might even see the user including their public key in their signature or in their profile page. That way you can use that key to encrypt messages and send them to that user, and you'll be sure that the only person that will be able to read this message is the user. Now, there is another way of sharing the keys, which I want to cover in this lecture, and that way relies on using key servers. So you can think of this as a computer that's accessible on the internet or on the darknet. It contains a number of keys, and then, for example, if David wanted to share his public key with John or with anyone else, they can upload their key to the server. Same goes for John. If he wanted to share his public key with others, he can upload his key to the server as well. And then, if David wanted to communicate with John, he won't need to ask John for the public key directly, and John won't need to communicate with David directly and send him the key. All David has to do is query this server, the key server that is accessible, like I said, on the darknet or on the internet, and download John's public key. Same goes for John. If he wanted to get David's public key, he can query the server, download David's key, and that way both David and John have each other's public keys, and therefore they can start communicating and encrypting messages to each other using each other's public keys. The only thing that you want to keep in mind when doing this is when you upload your key to this public server, anybody can get your public key. Now, like I said, the public key cannot be used to decrypt your messages, but as we've seen before, there is an identity tied up to the key. Now, we used fake information, but if you're using real information, the name will be visible on that key, and the email associated with that key, again, like we've seen before, when we create a key, we set an email address with that key, so that email will also be publicly available. So if you don't want to make this information available, then do not upload your keys to these key servers. Also, if the key is associated with other keys or part of a chain of trust, these keys will also become available along with the information tied up to them. So any contacts associated with the key will also become available and public once you upload that key to the key server. So again, if you don't want this information to be public, then do not upload your key to the key server and just send it directly to the people that you want to share your public key with. But like I said, the main idea remains sound. Sharing the public key does not compromise the encryption. The public key cannot be used to decrypt the messages. It can only be used to encrypt them. Hence the name public, and that's why we can actually share it with anyone we want, and we can just make it publicly available. Now, let's see how we can do this. So first of all, I'm going to go to John's computer right here, and let's say that I want to make my private key, so this key right here, available, and I want to upload it to a key server. Now, before uploading it to a key server, I need to enable this feature, and to do that, we're going to go to Edit, Preferences, and in here, when it says Publish Keys To, I'm going to click on the drop-down menu and select the server right here. Now, as you can see, this is an Onion service. Therefore, whoever is going to download this key needs to be connected to the Tor network. Now, I'm going to close this. And the next thing that I'm going to do is upload this key to the key server. So to do that, we're going to go to Remote and Sync and Publish Keys. This is telling us that one key is selected and it's going to be synchronized and uploaded to the key server that we selected. We're going to click on Sync, and this will upload my key to the key server that we selected. Now, anyone who wants to communicate with me, with John Wick, they can query this key server and find my public key and use that to encrypt messages for me. So in our example, it's David that wants to communicate with John. We have his computer right here. And all he needs to do is open his passwords and keys from the utilities as we've seen before. And he's going to first select the GNU PG keys, go to remote, and click on find remote keys. So these are the steps that you need to use if you want to pull a key from a key server. When you click on this, you'll get a search box, as you can see in here, which you can use to search for your contact. You can search using the name associated with the key, as we know that's John Wick. You can also use the email or the ID. I'm just going to use the email, which is jnck7@elude.in. And I'm going to click on search. Now, as you can see, I have the result right here. Now you can right click and look up the properties of this contact. And you can see this is for a person named John Wick. You can see the email, you can see the key ID, and if we click on details, you'll also be able to see the key fingerprint. Now, ideally, you'd want to confirm the key ID and the fingerprint with your contact before adding this key, because as we've seen, anyone can publish a key to the key server and claim to be anybody. So we're not sure that this John Wick is actually the John Wick that we need to communicate with. Therefore, you should communicate with your contact using another method of communication, for example, by email, by phone, or by text message, and confirm the fingerprint and the ID that you're about to add to make sure that this is the correct fingerprint and the correct ID for the key that you want to add. Now, obviously, John can get this information again by going to his passwords and keys, right-click his own key, click on properties, and he can get his own fingerprint and use that to help you confirm that this is the right contact. Once you're sure this is the right contact, you can click it in here and click on import to add it to your keys. And as you can see, it got added in here into my keyring. And then, as we've seen before, you can start typing messages and encrypt them from the applet in here, or encrypt files by right-clicking the files and encrypting them. So basically, I just wanted to show you another method of key exchange, how you can upload a key to a key server and how your contact can download it, or how you can download a key from the key server. Now keep in mind, when you upload a key to the key server, it might not become immediately available. I actually paused the video and resumed recording after several hours after uploading the John Wick key, because usually there are more than just one key server. So when you upload your key to one of these servers, it actually takes some time for the key to be shared with all of the servers and to become available for everybody to download. So if you uploaded a key and your contact tried to download it within the same hour and couldn't find it, then that's fine. Just tell them to wait for a few hours and then they should be able to download it. In the previous sections, we covered how to carry out most of the tasks that you'd usually do in a more private and more anonymous manner. So we covered how to privately and anonymously search for data using private search engines in the clearnet and in the darknet. We covered how to anonymously and privately communicate using emails and using instant messages. We covered how to properly handle files and share files anonymously and privately. We covered encryption so you can improve whatever method of communication you're using. And we covered all of these topics as separate modules and separate topics so you can use them in different scenarios and different situations. So for example, you might be just signing up to a forum and all you need is just a private email address. So you only use the information from that module. Therefore, all of these modules combined together right now should allow you to do pretty much anything you want to do on the internet or on the dark net in a more private and in a more anonymous manner.
One thing that we haven't covered yet is transferring or receiving money, or transferring or receiving funds. So again, on the internet, in many situations, you might want to send money to a friend or receive money, or you might want to buy something. And we're used to use our Visa cards or PayPal or different payment methods in order to transfer money and handle this. Now, just like anything else that we covered previously, using these traditional methods to transfer money is not anonymous and not private. Therefore, we'll need different methods if we want to protect our privacy and anonymity. You're probably already thinking now of using cryptocurrency, and that's correct. Some of the cryptocurrencies are actually very secure and very anonymous. So in this section, we're gonna first of all talk about cryptocurrency, what it is and how it works. We're gonna talk about Bitcoins, obviously, because it's the most common cryptocurrency. And then we're also gonna talk about a more private cryptocurrency, which is Monero. So we're going to talk about how to properly obtain these cryptocurrencies anonymously and privately, how to handle them in a secure and private manner, and how to send and receive, so how to transfer these currencies again in a secure, private, and anonymous manner. So this information goes as another module, again, that you can plug into different situations and different scenarios in case you needed to transfer money to a friend or to another person in an anonymous manner, or if you wanted to pay for something, if you wanted to buy something anonymously and privately, or if you're simply just buying from a website that only accepts cryptocurrency. Now, in general, unless you're using cash, when you make a payment, this payment is processed and is transferred from one account to another using one or more financial institutions or banks. The same goes when you go online and buy something, even if you buy with PayPal or some other method. Again, there is usually one or more financial institution to process that payment. So as you can see, this is a centralized structure where one entity is managing payments, and we're also entrusted in that entity to manage our security, the security of our account, and our privacy. Now, no matter how well you trust this company or this bank, as we've seen before, centralized structures are just inherently not private. The reason for this is because all of the information is stored in one single place. So even if you trust this company and trust everything about it, what about the employees that work at this place? What about hackers that manage to gain access to it? What about other agencies that force this entity to have backdoors or to give them access? And the list goes on and on and on. Simply, the idea of keeping everything in one place is not private. The alternative to this is to use cryptocurrency, which is not controlled or managed by a single entity. So previously, we had the money, which is the cash, which is stored in a bank or some financial institution that manages that currency. When it comes to cryptocurrency, it eliminates the need to a middleman or to an entity that manages this currency. Instead, it relies on decentralized peer-to-peer structure, known as blockchain. Now, to understand how this works, let's have an example where David wants to send money to John. To do this, the first thing David will do is he'll create a crypto wallet. You can think of this similar to creating a PGP account. So the wallet will be associated with two keys, a private key and a public key. And let's say David wants to transfer one coin to his friend John, so he generates a message or a request similar to this right here, and he'll sign this request with his private key, which will generate a signature or a fingerprint. So again, this is very similar to when we used to sign messages with our private key with PGP. And the reason why this is done to make sure that whoever inspects this message or this request will know that this request to transfer one coin from David's account is actually generated by David, because David will never share his private key. Now, once this is signed,
David will also include his public key so that it can be used to verify the signature. Again, similar to what we spoke about in the encryption section of this course, the public key is mathematically related to the private key, and therefore it can be used to verify the signature without revealing information about the private key. So, when this message is inspected by anybody, they can use the public key to verify the signature, and if it checks out, we'll know that this message was actually generated by David, therefore we can process the transfer of one coin from David to John. So, once this message is generated on David's end, David will send this message to the cryptocurrency network. Now, this network is basically a number of computers, usually of high specs, that keep a copy of all transactions done using this cryptocurrency. These computers are usually referred to as miners because they get paid coins for maintaining the ledger or this record of transactions. Now, this record of transactions is known as a blockchain. So it's a public record that contains all transactions made with this cryptocurrency, and each miner, each computer on the cryptocurrency network contains a copy of all of these transactions. So it contains a copy of the blockchain. So David's message is sent to the currency network. It'll get verified, and if it checks out, it will be added to the blockchain. So this message will be added as a new block to the existing blockchain stored by each one of these computers or miners. So right here I have a zoomed in diagram of the blockchain. So each one of the miners of the computers contains a copy of this. And you can think of each one of these blocks as a transaction that happened in the past. The latest one being the one that David just generated, in which he transferred a coin to John, but the others are just other transactions that have been done in the past. So as you can see, this is a decentralized structure. It is not owned by anybody and not controlled by anybody. Anyone can join this network and use their computer for mining, so anyone can download a copy of this blockchain and start mining and start helping maintain this cryptocurrency network. Now you can also see that this implementation is private because I'm using names in here. So I'm saying we're transferring one coin from David to John, or here from Bob to Alice. But in reality, real names are not used. Instead, wallet addresses are used. So the contents of the blocks, even though they're public, you'll see the content of it saying it's transferring from a long address to another long address. And as long as the users are using proper OPSEC, keeping their real identity separate from their fake identity, connecting using the Tor network, and using all of the tips and methods that we discussed to stay private and as anonymous as possible, these addresses will not link to their real identities. With that being said, the fact that the whole ledger or the whole blockchain is public means that we can read all of the transactions done using this cryptocurrency. Therefore, even though these addresses don't link to real identities, we can analyze a specific address and see all of the transactions it got involved in. So we can see all of the money that left this address and all of the money that entered this address. Therefore, we'll even be able to calculate the current balance in this specific account. Now, you can obviously just create multiple addresses to get around this. There are also other methods to increase anonymity and privacy and make it hard to see where money is going and where it's leaving from. And you can simply just use a more private cryptocurrency like Monero, which we'll talk about later on in the course. For now, I just wanted to give you a basic understanding on how cryptocurrencies work, and this is pretty much how Bitcoin works, which is the most popular cryptocurrency. Okay, so now that we have a basic understanding on how Bitcoins work and how cryptocurrencies work in general, In the next lectures, I want to walk you through how to use cryptocurrencies and specifically Bitcoins anonymously on the internet and on the darknet. Now, first, before we can do anything, we have to create a wallet. What we mean by wallet is it's software that's going to hold our money or our cryptocurrency. Then we can use this wallet to send payments, receive payments, and so on. So you can think of it similar to the bank account that you get when you sign up with a bank or the dashboard that you get when you sign up with PayPal. Now, there are a lot of web-based wallets where you can access your currency online using a web browser. There are apps that you can get on your phones, and there are programs that you can install on your desktop computers. Now, since we're using Tails, we're going to be using a wallet called Electrum that comes pre-installed in Tails. This is very important because, as we know, Tails is a live operating system. It's amnesic, so if you install external programs, you'll have to install them every time you start Tails unless persistence is enabled. Another cool thing about Electrum is it's really fast. It doesn't need to download the whole blockchain, which is pretty big. It uses an indexed version of it, so you can use it as soon as you download or launch the program. And the wallets that you create with Electrum can be used from separate computers. So, for example, if you destroy your Tails build, you can just go to another Tails and be able to restore your account, and I'll show you how to do that later on in the course. Now, let's go to Tails, and all of this will become much easier to understand as we do this practically. So like I said, Electrum comes pre-installed with Tails, so you don't need to install it, and you can access it by going to Applications, Internet, and click on Electrum. Now, recently, a very dangerous vulnerability was discovered in a previous version of Electrum, but this version was shipped with Tails. And even though Tails has been updated multiple times since that version, Electrum did not get updated because the latest version of Electrum still doesn't have a Debian build, which is what Tails is built on. So, in this lecture, I'm going to show you how to manually install the latest version of Electrum, and in the next lecture, we're actually going to use it. Now, for you, in your case, you can launch it from here and follow what I'm going to show you in the next lecture. If the program gets stuck, then that means Tails still doesn't include the latest version of Electrum, and you'll have to come back to this lecture and install the latest version, as I'm going to show you right now. Now, to download the latest version of Electrum, you need to go to their website, electrum.org. I'll include that in the resources. We're going to go to Downloads, and we're going to select the Linux image, the app image right here. One click. And we're going to click on Save File. And this will automatically be stored in our Tor browser directory. That's fine. And I'm going to click on Save. And this will start downloading it for me. I'm also going to download the signature right here. So I'm going to right click this and save link as. And again, this is going to my Tor browser directory. I'm going to click on Save. And I'm going to scroll down. And I'm going to download the developer's public key by right-clicking, save link as, and again, it's going to go into my downloads, and I'm going to click on save. The reason why I downloaded the signature for the installer and the public key of the developer, Thomas, is because, like I explained earlier, when you download something from the internet, it can be modified by a number of entities. Therefore, we downloaded the signature and we downloaded the public key of the developer, and we're going to use the public key of the developer and the signature to verify that the file has not been tampered with since we downloaded it, since that developer signed it. I've actually explained how this works in details in my encryption section, so go back and revise that if this sounds a little bit vague. But basically right now, I'm pretty sure the downloads are over. And if we go to my Tor browser directory, you'll see I have the program itself. This is Electrum. This is the executable. And we also have the signature for this program that has the exact same name as the program with the .asc extension. And I have thomasv.asc file, which is the public key of the developer that made this program. So before I can do anything, I have to import this key right here to my keychain. And I showed you how to do that before, so I'm going to do it quickly. I'm going to go to my applications. I'm going to go to passwords and keys. I'm going to go to file, import, and I'm going to select the file which is in my Tor browser. And it's this file right here, thomasv.asc. Click on open, verify the details, click on import, and this will import his key for me. And to verify that, I can go here and just look for Thomas. And as we can see, we have the developer key in here. So now that we have the key added, we can click on the signature, right click it, and open with verify signature. And this will give us a positive result if this executable right here did not get modified, since Thomas, the guy with the key, has created this executable. So we're going to click on verify. And as you can see, it's telling us that this is valid. And like I explained before, don't worry about the untrusted part. As long as it says it's valid, this means that the file did not get modified since it got signed by Thomas. So now we can go ahead and run this file and not worry about it because we know the file did not get modified since Thomas signed it. But before we do that, I'm actually going to copy this and I'm going to put it in my persistent directory. So I'm going to right click here and paste. And the reason why I'm doing this, because like we know, Tails is live, it's amnesic, so every time we restart, all the files will be lost unless they are stored in the persistent directory. Now, if you don't have the persistent directory, that means persistence is not enabled for you. I covered this previously in the course, so please go back to that lecture and see how to enable this. Now, also, before using Electrum, I'm going to go to Applications and Tails. We're going to click on Configure Persistence. I did cover this before, but I want you to make sure that personal data is enabled. And if we scroll down, Bitcoin client is enabled as well. And the reason why we need these settings, so when we create a wallet, the wallet information will be stored on this computer. So when we restart, we won't have to restore the wallet every time. We'll just have to put the password. So I'm going to close this because everything is configured properly for me. And one last step, because I can run executables on Tails. This is a security measure that comes with Tails. You'll need to right click the file, go to its properties, go to permissions, and you need to check this box that says allow executing file as program. We're going to close this. And now every time you want to run Electrum, don't go to Applications Internet, come to Persistence and double click this executable. Now, as you can see, the program has started. Now, it doesn't have any wallets. That's why it's not asking us for a password or anything. But right now, it's ready to be used. And in the next lecture, I'm going to walk you through the basics of this program. And we're going to create our first Bitcoin wallet. Okay, so now that we have our wallet software installed, which is Electrum, in this lecture, I'm going to show you how to create our first wallet. So I'm here at Tails, and I'm going to double click the Electrum icon. As you know, we put this in persistent. Now, because this is the first time we run it, and because we haven't created a wallet, as you can see, by default, it's showing us a wizard to create a new wallet. So the first thing you want to do is select the name of the wallet that you want to create. In my case, I'm going to call it John Wick Wallet. And I'm going to click on Next. And now it's asking us what type of wallet do we want to create. By default, this is set to a standard wallet, and this is what we're going to create. The wallet with two-factor authentication allows you to create a wallet that uses 3 keys
2 of which are stored on this computer, and the third is stored on a remote device. And in order to log into this wallet and use it, you'll need to use a device with Google Authenticator. Now, this obviously increases security, but it jeopardizes our privacy because, as we know, Google isn't great when it comes to privacy. Therefore, this would be a good option if you want to be secure and you don't care about privacy. But if you want to be anonymous, then standard wallet is a better option than this. You can also create a multi-signature wallet. This is basically a wallet that uses 2 other separate wallets installed on 2 separate machines. Again, it increases security, and because it doesn't require Google Authenticator, it won't jeopardize our privacy. But like I said, in order to do this, you will need to set up 2 machines and use these 2 machines to authenticate and use this wallet. The last option will allow us to import Bitcoin addresses or private keys, as the option suggests. So we're keeping this at standard wallet. We're going to click on next. Now it's asking us whether we want to create a new seed or a new wallet or restore an existing wallet. A seed is a string of text that can be used to restore a wallet. So if you already have a wallet on a different computer that you removed, or if you already have a wallet that you want to use on this computer, then you would select the second option, I already have a seed. If you're creating a new wallet from scratch, you're not restoring anything, you're going to keep this at create a new seed, and you'll see in the next window we will get a seed which we can use to log into our wallet or restore it on multiple computers. You can also use a key or a hardware device to again restore a wallet and use it in this computer. But like I said, we don't have a wallet. We want to create a new wallet. So we're keeping this at the first option, and we're going to click on next. Next is going to ask us about the seed type. We're going to keep this at the SegWit. This is much more secure than the legacy, but as the note suggests in here, this might not work with all websites. And right here, as you can see, we have our seed. So like I said, the seed is a string of text that we can use to log in to this wallet. So this is very dangerous. You're not supposed to share this with anybody. If anyone sees this text, they'll be able to log in to your wallet. So that's why you have all the notes in here telling you never store this electronically. You should keep it on a piece of paper or try to just memorize it. Because if anybody sees this string of text, they'll be able to log into your wallet and use your money, transfer money, or receive money. Now, this is very useful for us if we keep it private, because we can use this text to log in to our wallet from different computers, or even if we remove Tails from here and reinstall it on a completely different USB stick, all we have to do is start Electrum. Instead of choosing create a new seed, we're going to say we're going to restore from an existing seed, put this text, and you'll be good to go. You'll be able to log into your wallet and you won't lose any money. So right now I'm going to copy this and I'm going to put it in a text editor. Now I know it said don't do this, but I'm going to do it anyway for the sake of this video. And we're going to click on next. And in the next window, it's literally asking you to paste the seed in here just to make sure that you actually stored it somewhere and you remember it. So I'm going to go here. I'm going to select all, copy it, and paste it here. And we're going to click on next. Now it's going to ask you to choose a password to encrypt your wallet. Again, use a long and strong password. And we're going to keep this option checked to encrypt the wallet file that will be stored on this computer. I'm going to click on next. And that's it. Our wallet is set now, as you can see in here. The main thing you want to check is the balance. As you can see, we have 0 micro bitcoins because we haven't really transferred anything in here. This is our balance. You can also see in here the blue circle. Now this circle will be red if you're not connected. It will be green if you're connected directly, and it will be blue if you're connected over the Tor network. So Electrum is just software that you can install on any operating system,
And you can see that if you install this on any other operating system other than Tails and create a new wallet, you'll see this circle right here will be green, not blue, because you'll be connected directly through the ClearNet. But because this is blue in here, we know that we are more anonymous and more private because we're connecting using Tor. So we can be rest assured that all the traffic that is sent to and from Electrum is going through the Tor network first. Now you can also see in here, we're already by default in the history tab where you can see all your transactions. Again, I have nothing because I haven't done any transactions. You can use the receive tab to get your receiving address and your receiving QR code. You can use these, you can share them with anybody that you want to receive money from, and they will be going to their send tab, and they will either use your receive address or use your QR code to send money to you. And that's pretty much it. So now we have our wallet, and as you can see, Electrum is a very simple program that is easy to use. Don't worry too much about using it. We are going to use it more in the next lectures, and you'll get very comfortable with it because, as you can see, it's simple enough anyway. Now that we have our wallet set up, in this lecture and the next lectures, we're going to discuss how to buy Bitcoins anonymously. Now, there are a number of ways to buy Bitcoins, but not all of them are anonymous. So if we go back to our wallet right here, you can see that if we click on the receive, you'll see our receiving address. This is the only piece of information that you'll be sharing when you want to receive money into your wallet. And when you receive money into this, like I said, this will be stored in a public ledger in the blockchain. Therefore, anybody can come in and analyze the blockchain and see who sent you money. So if you send money to this address using your bank account or using a service that verifies your identity, then your identity will be linked to this address, and then any transfer you make from this address will be known and again will be traced back to your real identity. So far we're anonymous because this address is not linked to anything, but if you use an unanonymous way of transferring money into this wallet, then this wallet will be linked to your identity, and then whenever you use this wallet, all the transactions could be easily traced back to your real identity. Therefore, it's very, very important that you buy your Bitcoins anonymously. So the first way of doing this is to create Bitcoins yourself. And to do that, you're going to have to mine Bitcoins. So if you remember when we spoke about how Bitcoins work, we said that there are computers right here, the yellow ones, and we call them miners. And these computers keep a copy of the blockchain, and they use their computation power to keep the blockchain working. They do this by solving mathematical problems and calculating hashes so that the blockchain functions as it should. Now, these mathematical problems and the calculations, they take a lot of computation power and a lot of electricity. Therefore, not anyone can afford to do this. But if you can afford to do it, then it is a really good way of generating Bitcoins anonymously. Now, we're not going to go into this because we can literally make a big course just on how to mine Bitcoins properly. So we're not going to cover it here. The next option is to use an exchange. Now, using exchanges is not anonymous because when you use an exchange, they will ask for your bank information and they will ask you to verify your identity. So using an exchange is not anonymous, but we can combine using an exchange with what's known as Bitcoin tumblers or mixers. These are services that attempt to mask where the money is coming from. There is a lot of debate of how good or how anonymous this is. It adds an extra step when you're transferring the money, therefore it's a little bit complicated. And because of all of this debate, I wouldn't feel very secure or very anonymous by using this method. But this is a really good method because exchanges work all over the world. So if you couldn't get Bitcoins any other way, then you might have to use this way where you use an exchange with a tumbler or mixer. Now, if you just go on Google and look for a Bitcoin exchange, you'll see a lot of websites that will allow you to do this. Now, on Bitcoin website itself, you can see that they're recommending the following exchanges. You can just click any of them to open their website. Now, the most popular one is Coinbase, which I already have open right here. Like I said, this is really easy to use. All you have to do is click on Get Started. It'll take you through a number of steps where you create a new account. It'll automatically create a web wallet for you, so a wallet that you use on this website. It will ask you to verify your ID. So like I said, this is not anonymous, but once you create your account and buy some Bitcoins, you can use a tumbler service, and we'll talk about tumbler services and mixers later on in the course. And when you do that, it will add a layer of anonymity, and it'll make it harder to link this account that you're gonna create in here with your Bitcoin wallet that you're gonna transfer the money to. Transferring the money is always the same. You literally just have to put the receiving address that you have in here in the wallet that you're going to create on this website, and the money will go to your Bitcoin wallet. Now, don't worry about this too much because, like I said, if you're going to use this, you'll need to use a tumbler or a mixer, and I will cover tumblers and mixers later on. So even if you want to use this option, keep it in mind, don't use it right now, only use it after I cover the tumblers and mixers. The next option that we have is to use a Bitcoin ATM. Now, this is a really good option because some of these ATMs even accept cash. The only problem is not all countries have Bitcoin ATMs. So to check if your country have a Bitcoin ATM, you can go on this website. I'm going to include its link in the resources. It's coinatmradar.com. And all you have to do is just put your address in here, or if you want, you can go down on this map right here. I'm going to maximize it and look for your country, zoom in on your country and see if there are any ATMs. Now, I will talk about this in more details in the next lecture, where I'm going to teach you how to use Bitcoin ATMs in details, and you'll learn how to convert real currencies such as dollars and euros to Bitcoins anonymously using Bitcoin ATMs. Last but not least, we can use peer-to-peer services to buy Bitcoins. Now, peer-to-peer services allow us to buy Bitcoins directly from the seller. So unlike coin exchanges, there is no middleman, there is no middle institution, and if the seller is willing to give us Bitcoins using an anonymous method, such as by giving him cash, then this will be perfect. Now again, going back to the Bitcoin website, you can see that they list a number of peer-to-peer services. Now, pretty much all of these services will either require to verify your identity, or they will only use services that require your identity. For example, BitQuick right here will not ask you to verify your identity, but in most countries, the only method of transferring money would be a method that would require your identity. So you're pretty much back to the start. Local Bitcoin used to be a really good service that would allow you to buy Bitcoins in cash. So you'd literally meet the person and give them cash and they transfer the money to you. Unfortunately, recently they stopped this and you can't buy Bitcoins with cash with local Bitcoin, and they also started verifying IDs. So again, this service is not very anonymous anymore. Paxful, on the other hand, is a really good peer-to-peer service that still allows you to get Bitcoins by literally giving cash in person to the person that will give you the Bitcoins. So it's really good if you can find peers in your country, and I will actually cover this in future lectures. So that's it for this lecture. I just wanted to give you a breakdown of the most common ways that you can buy Bitcoins anonymously. And in the next lectures, I'm going to show you how to specifically buy Bitcoins from an ATM and how to specifically buy Bitcoins using a peer-to-peer service. In both cases, we'll be using cash, so it'll be as anonymous as possible. Now that we discussed the different methods of buying Bitcoins and getting it into your wallet, in this lecture, I want to show you how to buy Bitcoins with cash using a Bitcoin ATM. Now, like I said, because we're using cash, this method can be anonymous as long as there are no cameras at the ATM and as long as you practice proper OPSEC. The only limitation here is if there are no Bitcoin ATMs in your country. If you're not sure if there are any ATMs in your country or not, you can check out this website, coinatmradar.com. I will include this link in the resources of this lecture. And as you can see, very easy to use. All you have to do is type your address here. Or if you go down, you'll see a nice map that we have in here with all of the countries in the world, with the amount of ATMs that they have. This map will actually show you ATMs for a number of cryptocurrencies, not only Bitcoins. So you can filter them from this list in here. You can filter whether you want to buy or sell crypto, or you can filter based on the location type. I'm in Ireland, so I'm going to zoom in here. And even though it seems like there are no ATMs in Ireland, when we zoom in a little bit, as you can see, we can see that there are 3. And if I keep zooming in, we can see that there is one in Dublin where I live. And if I click on it, I'll get more details. You can see in this ATM, we can only buy Bitcoins. We cannot sell, but that's what I want to do. So that's fine. We can buy Bitcoins and Ethereum. That's another cryptocurrency. And we can only buy these currencies with euros. So what they mean here by fiat is the actual real life currency that you can exchange for crypto. Now, if we click on view details, you'll get more details about this particular ATM. You'll see reviews, you'll see their email, you'll see the location, you'll even see a comparison between it and the close by ATMs. And obviously you can see its location in here. Now, before going to the ATM, it's a good idea to create another wallet because the wallet that we created previously, like I said, it uses the SegWit address, which is the latest type of address that you can use with Bitcoin. But I actually mentioned in that lecture that not all websites, and I should have said not all ATMs, accept that kind of address. So they won't be able to transfer money to that address. So it's a good idea to create 2 wallets, one with the legacy option and one with the SegWit, and bring the QR code of that wallet so you can transfer money to it. So I'm going to go to Tails real quick to create a legacy wallet. So as usual, I'm going to start Electrum, double click it. And instead of logging in to our existing wallet, the one that we created before, I'm actually going to type a new name here for a new wallet. And I'm going to call this one John Wick Legacy because it's going to use a legacy address. I'm going to click on next. We're going to keep this at a standard wallet. And we're going to choose that we want to create a new seed. And in here, instead of keeping this at SegWit, we're going to change it to legacy so it creates a legacy address for us. Now, again, it's going to give us the seed. I'm going to copy this and I'm going to put it in a text editor. And I'll copy it again. So in the next window, I'll paste it here. Click on next, set a password to encrypt the wallet. And perfect, that's it. Now the wallet is created. It's called John Wick Legacy. And like I said, the whole point of this is to have a legacy address in case we're receiving money from a website that doesn't support the latest SegWit addresses, or if we're transferring money from an ATM that doesn't support the latest SegWit addresses. So if we go on receive, you can see the address in here, and note that this time the address starts with number 1. This means that it is a legacy address. In the previous lecture, when we created a SegWit address, you'll notice that the address starts with B. So if it starts with 1, that means it's a legacy address. If it starts with B, then it's a SegWit address. Now, what's really important for us in here is the QR code. So I'm going to click it and either take a picture of it with your phone or take a screenshot and send it to your phone, because you're going to need this in order to transfer money to this wallet. So now that we have the QR code of our wallet and we already have the address of the ATM, all we have to do is go to that ATM and transfer money to our wallet. Okay, so now I'm at the shop and at the ATM that we found on atmradar.com. Now, keep in mind, using the ATM might be slightly different, but the general idea is the same. It's actually very, very simple. Similar to using any ATM. You tap on the screen, you follow the instructions, and everything should work as expected. So, as you can see on the top right, it's showing us the current exchange rate for both Bitcoin and Ethereum. Like I said, Ethereum is just another crypto that this ATM allows you to buy. So I'm going to tap the screen to start. And I'm going to choose Bitcoin because I want to buy Bitcoin. And I'm going to choose buy because I want to buy, not sell. And I'm going to select the first option on the left to buy up to 250 euros because I only want to buy 20 euros worth of Bitcoins. Now it's asking me to provide the address of my wallet. Like I said, to do this, we're going to use the QR code of the legacy wallet that we created. As you can see, I already have a picture of it here on another phone. And all I have to do is just scan it in here. So it scanned the code properly. If the code was not scanned, it'll show you an error. And now it's telling me that I should put the cash money that I want to exchange for Bitcoins. So again, you can see the LED light on the top right for where you should put the money. I'm going to put my 20 euro note in here. And as you can see on screen, it's telling me that it detected 20 euros and that will be exchanged for 0.001544 Bitcoins. So in our wallet in micro Bitcoins, this will be equal to 1.544 micro Bitcoins. That's fine. We're going to click on the green button to buy the Bitcoins. And perfect. That's it. As you can see, it's telling us that the transaction is complete. You can click on send receipt to receive a receipt, but this will ask you for a phone number or an email to receive a copy of the receipt. So you might not want to provide that if you want to stay as private and anonymous as possible. And that's it. Now you want to give it a few minutes and the money should appear in your Bitcoin wallet. And as you can see in here, I'm in my John Wick legacy wallet, the one with the legacy address. And as you can see in the history, we can see that we got a transaction. It's a plus on here. So that means money went into the wallet, not outside of the wallet. And the amount of it is 1.544 micro Bitcoin. So again, at the balance in here, it's 1.544 micro Bitcoin, not Bitcoin. And obviously the final balance, because we had 0, again, it's 1.544. So now we can actually use this wallet to send money to other addresses, to other sellers, and so on. You can even use this tab in here to send money to our other wallet, to the wallet that uses the SegWit, not the legacy address. Another method of getting Bitcoins anonymously is using peer-to-peer services. Now, peer-to-peer services, as the name suggests, remove the middleman or the middle entity that facilitates exchanging fiat or normal currency with cryptocurrency. So with Coinbase and all of the other exchange websites, there is a middleman or an entity or a company or a bank that is acting in the middle. We give this entity our fiat currency or normal currency and we get crypto instead. And usually these companies and entities would require extensive information about us, would require us to verify our identity and so on. Therefore, they're great in terms of security, but they're not very private or anonymous. On the other hand, with peer-to-peer, it really depends on the person that is selling you the Bitcoins. So you might be able to find a seller in your area that is willing to give you Bitcoins without verifying your identity. A lot of sellers also accept cash in person, so you'll literally be able to walk in, give them cash, and then get your Bitcoins in your wallet. This is great. So this is similar to using an ATM, but there is no cameras, there is no shops, so it can be even more anonymous. Now, if you go on bitcoin.org and look at the exchange page that I have in here, we already discussed the exchange websites, like I said in here, like Coinbase and all of them. If you scroll down, you'll get to the peer-to-peer section that shows you the most common and most popular peer-to-peer services that you can use to get Bitcoins. Now, the top 3 services in here, they are peer-to-peer, so there is no middleman, but they either require you to verify your identity to sign up, or they only accept payment methods that would require an ID, such as transferring money using Western Union and other services where you have to show your ID when you're transferring the money. The last 2 in here, Local Bitcoins and Paxful, are slightly better because they offer a large number of payment methods, including cash in person. Now, Local Bitcoins does not offer cash in person anymore, but it used to. Paxful still does that, and I'll show you how to use it in a minute. But before using Paxful, I want to give you a quick look on Local Bitcoins. I already have it open in here. And using this website is very, very simple. You type the amount that you want to exchange for Bitcoins. For example, we can type 25. You select the currency that this amount is in. You select the country that you are in. And you select the payment method that you want to pay with. And as you can see, there is a lot of payment methods in here. You can pay by cash at ATM, you can do a cash deposit, you can do a bank transfer, and so on. Now, as you can see, a lot of them would require you to present an ID, or at least verify your ID when using these services. And like I said, this website used to offer cash in person, but it doesn't anymore. So you can actually just keep this on all online offers and search, and you'll see all of the offers that's available in your area, in your country, in which you can get Bitcoins with. So as you can see, we have a seller here that accepts add of cash. You can see these guys accept bank transfer, and you can just look for whichever is best for you and pick it from here. Now, one more thing that I'd like to note, keep in mind that in here you're using a peer-to-peer service. So it's similar to buying stuff from eBay. You want to make sure that the person you're buying Bitcoins from has a good rating. So if you look in here, the first number that you see between the 2 brackets, this is the amount of exchanges that he's done. And as you can see, he has 100% positive feedback. This guy right here has done more than 20,000 exchanges, and he has 100% positive feedback. So he is a really, really good seller to get from. Now, once you find a seller that you're happy with, all you have to do is literally click on buy, and the website will take you through the steps that you need in order to get your Bitcoins. Now, using this is very, very simple and intuitive. That's why I'm not going to spend time on it, especially that this website does not offer cash in person, which, like I said, is the most anonymous payment method. Instead, I'm going to show you how to use a website called Paxful. Like I said, it's the second website that we have in the list in here. The reason why I want to focus on this website instead of Local Bitcoins is because this website has cash in person, and again, as you know, this is more anonymous. Now, I have this loaded in here in my Tor computer, and as you can see, again, very simple to use. From the left here, you can pick the payment method that you want. And as you can see, we have bank transfer, PayPal, Western Union, and a lot of other payment methods. You can even see gift cards, Uber gift cards, and so on. So things that you can't even think of. But what we're looking for is cash. And as you can see, we have in here cash in person. So that's what we want. The amount that I want to transfer, I'm going to put it in euros because I live in a European country. So let's put 20, and that's going to be euros. It's telling us how much that will be equivalent to in Bitcoins. And we're going to click buy Bitcoin now to search for all the sellers that exchange cash to Bitcoin and accept cash in person. Now we have no script here detecting a potential cross-site scripting attack. It's not really an attack, it's just this website is using Twitter's API. I'm going to keep this at block anyway. We're going to click on OK. And because we're using Tor, right now the website did not get my correct location. Therefore, I'm going to scroll up and I'm going to select the country from here manually. So by default, the website should automatically get where you are. But because we're using Tor, we appear like we're coming from a different country. That's why the results will not be relevant to us. So I set this to Ireland. We're going to search. And perfect. As you can see, we only have one result, but that'll do. You can see this result has more than 1,168 positive transactions. So that's all good. It's in Dublin, so it's in the same city where I live. So it's perfect. So you can either click on buy to go ahead and go through the buying process, or you can click on the seller to get more information about him. So again, you can see the amount of positive reputation or positive reviews. We have 1 neutral review and 0 people saying that they had negative feedback with using this service. Now you can see again in here, the email and the ID of this person and the phone number have all been verified, so that's good. You can see the amount of trades he's done, the trade volume, the amount of people that trust him, and you can see the amount of blocked people. Now this should not put you off from a seller if you see some blocked people. This might be just people that this seller blocked because they were conducting fraud. So it's nothing scary. If you're buying from someone, you should focus on the positive feedback that you see in here. Now again, in here, you can see the payment methods that this seller accepts. So they accept cash in person, they accept cash by email, they accept Uber gift card, and so on. But I'm going to close this because what we were interested in is cash but in person, which we already clicked on. So you can see it actually automatically loaded in this tab. But if we go back to where we were and literally just click on buy here, the website will take us through the buying process. Now, before buying Bitcoins using this website, we'll have to make an account with them. Now, the nice thing about this, it's not going to ask you for a lot of personal information. So as you can see, it's asking us for the email. We've already created an email that we'll only use on the darknet anyway. So I have it in here. It's johnwick@elude.in. So I'm just going to paste it here. It's going to ask you to set a username. We'll set the same username as the email. And we'll set a password. We're going to agree to the terms and conditions. Now again, you might want to go through this in details, but for me, it's fine. I'm going to create the account. Okay, so the account has been created as you can see in here, but before we can buy Bitcoins, we have to go and verify our email. So I'm going to go to my email in here. I'm going to refresh my inbox and we have a new message. We're going to click on it. We're going to load the verification link that we have in here. So that's it. My email has been activated successfully. So I'm just going to go back to the page that we were in already. And as you can see, the verification message have disappeared. So right now we've already set the amount that we want to exchange for Bitcoins. We know how much we should get. We've already checked our seller. So I'm going to click on buy now to initiate the process. You'll get a nice message explaining to you how this is going to work. So we're going to say got it. And basically what you want to do is pay the money here. Once you do, you click on paid and wait for the money to arrive in your Bitcoin wallet. If for any reason you don't wish to continue with this, you can just click on cancel and all of this will be cancelled. Now on the right, as you can see, we have instructions on how this will work, and this might vary depending on the seller you're buying Bitcoins from. Now as you can see in here, it's saying we have 1 hour to make the payment. If we don't, then the trade will expire. So I'm just going to send him a message asking where we should meet. Now I've actually waited for this seller to get back to me, but as you can see, I got nothing here. So I communicated with him using one of the methods shown in here. Now, obviously, Telegram is anonymous enough if you install it on a phone that has followed proper OPSEC, that is not used for personal use, that does not contain any personal information. So I communicated with him, and the minimum they do is 3,000 euros. So the minimum I can transfer into Bitcoins is 3,000 euros. Now, that's a bit too much. I don't want to transfer that much. I'm only doing this for this course. Unfortunately, in my country, as you can see, this is the only seller, so there is no other options for me. In your case, if there are other sellers, you can go ahead and try to start a trade with them. As you can see, the process is the same. You communicate with them. You meet up, you give them the money. Once you give them the money, you click on paid and you wait for the money to arrive in your account. Now, the money will automatically arrive in your wallet in here because when you create a Paxful account, it automatically creates a Bitcoin wallet for you. And as you can see right now, there is no transactions in mine. So once you go ahead and pay them and come back here and click on paid, the money, they should transfer the money into your wallet in here. Now, as you can see, you even have the address of the wallet here if you just want to use it for normal use. And because you're communicating directly with that person through this chat or through one of the other methods of communication that they list here, you might even be able to give them the address of your Electrum wallet. So as we've seen before, all you have to do is go to the Receive tab, copy this address or QR code and give it to them, and they might agree on transferring the money directly into your Electrum wallet. If they disagree, that's fine. You're going to get the money here and you'll be able to send it from here into this wallet, again, simply using this address. And I will actually cover transferring Bitcoins from one wallet to another in the next lecture anyway. Okay, so now that we know how to create a wallet and how to transfer money into that wallet, in this lecture, I want to show you how to transfer Bitcoins from one wallet to another. Now, this is useful in so many scenarios. You might want to transfer from one wallet that you own to another for various reasons. You might want to transfer money to a friend. You might want to transfer money to a website or to a person for a service that they're going to give you. So in this lecture, we're going to see how to transfer money to and from an Electrum wallet. Now, one thing you should always keep in mind when using Bitcoins, the Bitcoin ledger or the whole blockchain is public. So all the transfers on the blockchain are visible to anyone in the world. Therefore, you should never transfer money to and from an account that you do not want to be linked to. Whether this account is a suspicious account or if it's an account that ties into your real identity, regardless of what the reason is, never send or receive Bitcoins from accounts that you do not want to be linked to because the ledger is public and all transactions are visible to anyone in the world. So, let's go to our Electrum wallet. As you can see here, now I've already logged in to the two wallets that I created previously. So on the left, we have my legacy wallet, which I transferred money to using the Bitcoin ATM. And on the right, I have the original wallet that I created. And as you can see, the balance in here is 0 micro Bitcoins. So I've touched on this before. If you want to receive money into your wallet, you go to the Receive tab and you either share the QR code or the address in here. Both can be used to send money into this wallet. Now, there is nothing wrong with sharing the address. People cannot take money out of the wallet using your address. They can only send money to it. So it's perfectly fine. The only thing that you should never share is the seed. So I'm going to copy this address. And we're going to go to the wallet that we want to send the money from. We're going to go to the Send tab. And we're going to set the Pay to address to the address that we want to set the money to. You can also use this icon right here to pick a picture for a QR code. But we're only using an address, as you can see here. So there is no need for the QR code. You can set a description for this transfer. We'll just say test. You don't have to set this. Next, you need to set the amount in micro bitcoins that you want to transfer. So as you can see in my balance, I have 1.544 micro bitcoins, and let's say I want to transfer 0.544. Next, you want to select the fee. This will decide how much you will pay for this transfer to take effect. The more you pay, the quicker the transfer. So you can use the slider to adjust it. And as you can see, as you move it, right now we selected the minimum amount of fees to pay for the transfer, but our transaction will be added within the next 25 blocks. So it'll take a while until the money arrives into the destination wallet. Obviously, the more you pay, the quicker the transaction is. And as you can see, if we set it to the highest, you can see that the transaction will be added in the next block. So this guy right here will receive his money very, very quickly. So this is nice, but it doesn't tell us exactly how much we will pay for the transaction. We just know that we'll pay the most possible amount. If you want to know exactly how much you're going to pay for the transaction, you can go to Tools, Preferences, and in the Fees tab, make sure you check Edit Fees manually. I'm going to close this. And as you can see right now, it's showing us how much exactly we're going to pay as a transfer fee. So when the slider is set to the highest, we're going to pay 0.2 micro bitcoins for the transfer. I'm going to reset this to the middle. And as you can see, our transaction in this case will be added within the next 5 blocks. And we're going to pay 0.14 micro bitcoins. Once you're happy with all of the parameters, you can click on Preview to get a summary of the transaction of all the information that you filled, or you can just click on Send to send the payment. Now, before it allows you to send this, it's going to ask you for the password that you set when you created this wallet. And as you can see right now, it's telling us that the payment is sent. And if you look in here and in here on the top, you can see that we got a new transaction, and we can see it here in the history. The only problem is right now it's telling us that it is not confirmed. That means that the payment has still not been verified yet. Give it a few minutes and it should change into confirmed. Now, as we mentioned before, the Bitcoin ledger or the blockchain is completely public and anybody can read it and analyze it. Now, we also mentioned that in the blockchain, in each entry, there isn't a lot of information about the people transferring money, but you'll see the addresses of the senders and receivers. So this is fine as long as these addresses are not linked to identities. Now, there is a number of scenarios where you wouldn't want your address to be linked to another address. For example, let's say you purchased your coins using a coin exchange that requires ID verification. In that case, the address that the money will come from will be linked to your real identity, and you'll be sending it to your Tails wallet. That way, if anyone analyzes the blockchain, they'll easily be able to link your exchange address, the one that you used to purchase the bitcoins and verified your ID with, to the ID of the Electrum wallet that you created on Tails, and that way this address is linked to your identity, and then any transactions you make or receive will be linked to your real identity. Other examples would be if you're sending money to another address that you're not sure if the user is practicing proper OPSEC, or if you're not sure if the user is using his money legally. We can't really know what people do in their personal lives. So breaking the link between the sender and the receiver is not easy when it comes to bitcoins because the blockchain is completely public. This is where tumblers and mixers come in play. The idea of this is very simple. First of all, you send your coins to a server or a service that's available to a number of people, not only you. And then this service will send your money to a different wallet. This way, you're breaking the connection between the sender and the receiver, and you can actually link a number of mixers if you want. So you can send this to mixer number 1, mixer number 2, mixer number 3, and then to your wallet or to someone else's wallet. And you can even do this to send money to your own wallet to hide the connection that you actually own both wallets. For example, let's say you purchased money from an exchange that required you to verify your identity. You transfer that money to a wallet in here. And then, so this wallet will not be linked to your identity, you send the money to a mixer, and then the mixer will send the money or the coins to another wallet that you control. And this way, it is very difficult to link the transaction that happened here with the transaction that happened here. Now, the way mixers mix the coins differ depending on the mixer that you use. So some of them will literally just randomly select an equal amount of money that you sent from their own wallet and send it to you. Others will be mixing the money that they have with different exchanges and send it to you. There is others that will literally sell the money or the coins that you give them in coin exchanges. They'd use crypto stock exchange to buy coins and then send you the new coins that they bought. So again, making it very, very difficult to track. Some of them will split the payments and send it to you in a number of transactions instead of sending it in one transaction. Some of them will add a time delay to make it even more difficult to trace. So there is a lot of techniques that can be used, but the whole idea is the same. You send the money to the mixer and you wait for the money to arrive in the second wallet. Now, because there are a lot of mixers, I can't really cover all of them. You can simply look in DuckDuckGo or Google or any of the other search engines that I showed earlier in the course for Bitcoin mixers and see all the options that you have and see how they work and compare them and then use the one that's most suitable for you. But in this lecture, I want to show you 3 examples that are slightly different from each other. Therefore, they can be useful in different scenarios. Now, all of these mixers have a darknet and a clearnet address, and if you scroll down on all of them, you'll see both the clearnet and the darknet addresses at the bottom. For some reason, this one that I'm using right now, the bitcoinlaundry.com, their darknet address is not working. That's why I'm accessing it over the clearnet address. Now, the cool thing about this one is it's actually very cheap. It doesn't charge you any fees. You only pay for transaction fees, but it doesn't really do a lot of complex operations when mixing the coins. You literally send the coins and then it sends you coins back into the other wallet, breaking the connection between the sender and the receiver. The next one is BitMix. The way this will work is you send the coins and they store all of the coins in one wallet. They mix the coins in that wallet and then they give you different coins into the second wallet. Now, these guys do charge a little bit more, but again, they're fast enough. I should have also mentioned that BitLaundry is pretty quick. It's pretty instant, so it's much faster than a lot of other services. Now, you should keep in mind the more complex the mixing process is, the longer it takes to get your money because obviously there would be more operations involved. This leads us to Mixtump.io. This is the most expensive service between the 3, but it is the most anonymous because when you send the coins to them, they don't simply just mix it and send it back to you. They will use this to buy crypto from stock exchange and then send you brand new coins that they bought from stock exchange and from investors. Now, with this, the amount that you receive can also be split into a number of transactions. A time delay can also be added to make it more difficult to trace these coins and link them between the sender and the receiver accounts. Last but not least, I should also mention that there are a number of mixers that are related to darknet markets, such as Helix. Now, this is supposed to be a really good mixer. The only problem I see with it is the fact that it is related to a darknet market. So the fact that you're going to be using this mixer, sending or just receiving money from an address that's related to this mixer could raise a lot of question marks on why you're using a mixer like that. Therefore, depending on your situation, it might make more sense to use one of the ones that I'm showing you right here. And like I said, there are lots of mixers out there. You should do your own research and see which ones fits your scenario best. Using them is pretty much the same. And in the next lecture, I'm going to show you how to use Mixtum just as an example so you get an idea on how they work in general. Okay, so now that we understand what mixers are and why we might want to use them, in this lecture, I want to show you how to actually use one to break the connection between transactions and use Bitcoin in a more anonymous manner. I'm going to use a mixer called Mixtum in this example, but using these mixers is pretty much the same. So by the end of this lecture, you should be able to apply this knowledge to use any mixer you want. So we're going to click on Mix My Coins to start mixing. And as you can see right now, it's asking us for the address that will receive the payments. So this is the address of the second wallet, of this wallet right here. And this is an extra option that we have here in Mixtum where we can actually add another address. So we receive the coins in two different addresses, again, making it even more difficult to track. But I'm just going to use one address. So I'm sending coins to this wallet. As you can see, the balance is 0. And in order to receive coins in here, as shown before, we go to the Receive tab and we copy the address here. I'm going to paste it and send. And as you can see right now, it's telling us that we should send the money to this address. Now this is the address of Mixtum, the address of the mixer. So what we're doing right here, this is the address of this right here. And what we're going to do is we're going to transfer money from our first wallet to the mixer, and then the mixer will do its magic, mixing our coins, and finally forward the coins to the address that we already gave it, the address of the first wallet. So what I need to do right now is copy this and go to the wallet that I want to send money from, which is this wallet right here. As you can see, the balance is 2 micro Bitcoins. We're going to go on send. We're going to set the pay to address to the address of the mixer. You can set a description. It doesn't really matter. I'm going to send the maximum possible amount and I'm going to keep the fee the same. Now you want to keep in mind, you send more than the minimum allowed amount. So if we go up to our mixer, you can see the minimum allowed amount is 0.001 Bitcoin. So multiply that by 1,000 and that means 1 micro Bitcoin is the minimum amount that you can mix. If you send less than that, it'll either be lost or considered as a donation. The minimum amount differs depending on the mixer you're using. So whenever you're using a mixer, make sure you're always sending more than the minimum amount. So now that we're happy with everything, I'm going to click on send. It's going to ask me for the password. And the payment is sent right now. So if we look at my history, you can see that the balance of this wallet is going to go down by -2 micro Bitcoins. But if you look at the history here, we still don't see the unconfirmed transaction. Remember, previously when we transferred money between two wallets, we immediately saw that the receiving wallet received an unconfirmed transaction, and after a while this transaction became confirmed. Now we don't see it in this case because what we did right now, we didn't send money directly from this wallet to this one right here. We sent the money to the mixer right here. The mixer is going to do its magic. It's going to mix the Bitcoins, make it harder to trace, and then and only then it'll send it back to the receiving wallet, which is this one right here. Now the time of mixing differs depending on the mixer and depending on how it works. With Mixtum, it can take a maximum of 6 hours, so you want to be patient with it until you receive the amount. You might also receive the amount in smaller chunks, so you might not receive the whole amount in one transaction. So just be patient with it until you receive the full amount that you transferred, and keep in mind that there is a transfer fee and there is a fee taken by the mixer, again depending on the mixer itself. Okay, now I'm back at my Tails machine. Now this is actually after about 20 hours. But if you look at the legacy wallet in here, you can see that we received our coins here from the tumbler. So first we received 1 micro Bitcoin, and then we received 0.7 micro Bitcoin. So as you can see, it did not come as one full payment. Now, I know I said I'm back after more than 20 hours, but if you look at the time of receiving this, it's only about 3 hours after the time when we sent the coins to the mixer. So it took about 3 hours. Like I said, it can take a maximum of 6 hours for mixdom, but the time vary depending on the mixer that you're using. So right now, the coins that we have in here in our John Wick wallet have been mixed and have been cleaned and will be harder to trace than normal coins because we broke the connection from the previous wallet that sent these coins. Like I said, this will make it harder to trace and make us more anonymous, but it's still not the best and the most ideal coin to use if anonymity and privacy are very important. A better solution would be to use a coin that's designed from the ground up to be private and anonymous, and we'll talk more about that in the next lectures. I just wanted to cover this here because a lot of people and a lot of websites still use Bitcoin because Bitcoin is the most popular cryptocurrency, as we all know. So, as we learned before, the entire ledger used in Bitcoins, the whole blockchain, is public. So the ledger contains all transactions done using Bitcoins. For each transaction, anybody can see the sender address, the receiver address, and the amount. Now, if the sender and the receiver are using proper OPSEC and obtain their Bitcoins anonymously, then these addresses will not be tied to their identities, but like I said, there are a number of ways that these addresses can tie to a person's identity. The easiest is if the person bought Bitcoins using a coin exchange that requires identity verification, or if the person or the entity you're sending coins to has made their address public and is linked to an actual identity. For example, if you're sending money to a known store or to a known market. Therefore, based on this information, anyone can analyze the blockchain. They can know exactly the balance of each address by tracing the amount of money sent to this address, so they can know how much money is in your wallet. They can track your spending habits, and based on that, they can profile you and serve you more things, more ads, and so on. Not only that, but if you have a considerable amount of coins, then you'll become a target because people know that you have a lot of coins in your wallet, again by tracing the amount of coins sent to your address. Not to mention the fact that if you're sending money to an entity that is linked to an actual identity, or if your actual identity gets linked to your address, then this will reveal even more information that you might not want to be public. All of this was the incentive to making a more private cryptocurrency. There is a number of private cryptocurrencies. The most popular at the moment is Monero or XMR. Now, it's similar to Bitcoin. It's decentralized, so there is no single entity that controls it. But unlike Bitcoin, it is private. So if you analyze the whole blockchain, you won't be able to get useful information on who is sending money to whom and the amount sent. So you can see addresses, but the addresses used are temporary and secured. Therefore, you can't see the actual sender, you can't see the actual receiver, and you can't see the real amount being transferred. Therefore, what you analyze is not very useful, the transactions are untraceable, and the sender and receiver are not linkable. All of this is achieved using ring signatures, ring confidential transactions, and stealth addresses. The exact way how all of this works is a little bit complex, and it dives too much on how blockchain and cryptocurrencies work. Therefore, I'm not going to cover it in this course, but I will include useful resources in the resources section of this lecture, which you can read for further information. Now, unfortunately, Tails does not come with a Monero wallet. We have to manually install it, but installing it is very, very easy. So let's go to Tails and see how to do that. First of all, you need to go to the download page of the official Monero website. I'll include its link in the resources of this lecture. And you want to scroll down to the Linux download link. Now I have the 64-bit version of Tails installed. Therefore, I'm going to click in here to download the 64-bit version of the Monero wallet. Now, just like any other download, you want to click on Save File and select the location where you want to download it. So by default, it goes into Amnesia Tor browser. And as you can see, I've already downloaded it in here. So I'm not going to click on Save, but in your case, you want to click on Save and wait for it to fully download the wallet for you. I'm going to click on Cancel because I've already downloaded it before this lecture to save time. And as you can see, I already have it here in my Tor browser directory. And before interacting with this file, just like any file we download from the internet, we need to make sure that this file did not get modified as it was being downloaded, because as explained before, anything that you download from the internet can be edited and modified at a number of locations as it's being downloaded. So previously, we saw how to verify downloads using their PGP signature. The verification process really depends on the information the developer is giving us. So as you can see in this case in here, the developer is not giving us a PGP signature. Instead, it's giving us a SHA-256 hash. So to verify a downloaded file with its SHA-256 hash, we need to go to Applications, Accessories, and we're going to use an application called GTK hash. I'm going to open this application, and in the file field in here, I'm going to select the file that I want to verify its hash. This is the file that I just downloaded. So I'm going to click in here and I'm going to go to Tor browser. And this is the file that we just downloaded. I'm going to click on Open and I'm going to click on Hash to calculate its hash. Now we have the SHA-256 hash in here. And what I'm going to do is I'm going to copy all of this and compare it to the hash that the developer is giving us here on the download page. Now, as you can see, the hashes match. This means that the file did not get modified as it's been downloaded, because if a single bit is changed in that file, the hash that I just calculated manually on my local computer will not correspond to the hash that we have on the web page in here. So because the hashes are matching, this means that the file did not get modified since this hash right here got calculated. So we can interact with this file now safely as long as we trust the developer that gave us the file. So I'm going to right click this file because it's a package, and I'm going to click on Extract here to extract it. Okay, perfect, that's done. So you can leave it here, but if you leave it here, as you know, Tails is amnesic, so when we restart the computer, these files will not exist. Therefore, I'm going to copy it and I'm going to paste it in my persistent directory. So right click and paste. And if we navigate inside it, we'll actually see another directory for the application itself. So I'm actually just going to cut this and paste it outside just to make it easier to access. And I'm going to delete the empty one. And I'm going to rename this one to just Monero GUI, again, just to make it easier to access. And if we navigate inside this directory, you'll see we have a number of files that's needed by the wallet application. And the main file that starts the wallet is this file right here, the startgui.sh. Now this is a bash file, which means that it can only be executed from the terminal, from the Linux terminal. Now, if you've done any of my other courses, this will be very, very easy for you. If you haven't, then don't worry about it. In the next lecture, I'll show you how to run it and create our first Monero wallet. Okay, so now that we have the wallet application downloaded, verified, and extracted in our persistent directory, in this lecture, I'm going to show you how to run this application and use it to create a Monero wallet. Now, as I said in the previous lecture, the file that runs the wallet application is this one. It is a bash file, therefore it needs to be executed from the terminal. To do this, we can start a terminal in the current working directory by right-clicking the directory that we want to open the terminal in and click on Open in Terminal. As you can see, you'll get a terminal window, but this terminal is already in persistent Monero GUI, which is the directory that we requested the terminal in, which is again persistent Monero GUI. Now we can use the ls command and hit enter to see all of the directories and files in the current working directory. And as you can see, all of these files and directories are identical to what we see in here. And what we want to do is we want to execute this file right here, the startgui.sh. Again, we can see it in here. And to execute it, all we have to do is type // followed by the file name, which is startgui.sh. Hit enter, give it some time, and the wallet graphical interface will start for you. You can use the language here to change the language, or click on continue if you're happy with English. Now we're going to have to use the advanced mode in here because we're going to use this wallet on Tails, and we'll have to manually configure it to use an Onion service to sync with the Monero blockchain. So I'm going to click on advanced mode. And as you can see now, the steps that we're going to go through are very similar to the steps that we went through when we created the Electrum Bitcoin wallet. So the first option will allow us to create a new wallet. The other options will allow us to restore an existing wallet. You can restore from a hardware device, from a wallet file, or from a seed or a key. Now we don't have a wallet yet, so we're going to click on create a new wallet to create a new wallet. Now the first thing it's going to ask us for is the wallet name, and I'm going to call this John Wick Wallet. Next, you'll have to set the wallet location. Keep in mind, on Tails, everything gets deleted every time you restart the computer. Therefore, if you keep this to the default location, your wallet will be deleted once you restart Tails, and you'll have to restore it using the seed in here. If you don't want this to happen, if you want to always be able to access the wallet from your Tails installation, click on Browse and change the location to somewhere within the persistent directory. Now, as we know, everything within the persistent will not be deleted when the computer restarts, and therefore you'll always be able to access the wallet from within your current installation. So you'd want to navigate to the persistent directory, and as you can see, we already have a directory called Monero GUI. This is the directory that contains the wallet GUI that we're using right now. So it'll make sense to place our wallet inside it in here. So I'm going to click on this icon in here to create a new directory, and I'm going to call this directory wallets. And I'm going to click on choose to store my wallet inside this directory. So my wallet is going to be stored in home, amnesia, persistent, Monero GUI, wallets. And as you can see, we have the directory here created because we created it within this working directory. Now, it's also a good idea to copy the seed, which you can use to restore the wallet in case the file got deleted, or if you wanted to use the wallet from a completely different computer, you can restore your wallet using this seed. And you can use this number in here as the block number when restoring your wallet, and using this number will help you restore the wallet much quicker. Once it's done with everything, click on next. Now it's going to ask us to set a password for the wallet. It's going to ask you for the daemon settings, so you can keep this to the default, which will start a node automatically in the background on your system. This option will download the whole Monero blockchain on your computer. This is the most private way of using Monero, but keep in mind the size of the blockchain is more than 25 gigabytes. So you'll have to wait. So first of all, you need to have enough storage. Second, you'll need to wait for all of this data to be downloaded. Keep in mind the download speed is reduced when you're using Tails because everything is going through the Tor network. Third, this is a resource hungry process, so you need a powerful enough computer to do that. Alternatively, you can click on connect to a remote node. With this option, we're going to use a remote node to sync with the Monero blockchain. This means that we'll be able to instantly use the blockchain, we'll be instantly able to send and receive funds, and we won't need to download the whole blockchain. So, in order to use this option, we need a remote server that we'll sync with. And I'm going to include links in the resources to a website where you can get Onion services that can be used as nodes. All you'll have to do is literally copy the server in here and paste it in the server location and set the port to the port that we have in here, which is 18099. Hit next. It's going to show you a review of all the settings that you selected. We're going to say yes, that's fine. Open the wallet for me, please. And as you can see, this will show us the interface of the wallet. Now, as you can see, it's telling us that we are disconnected, but now it's trying to connect, it's trying to sync with the remote node that we gave it. And you'll see that this will be very, very quick. Unlike the other option where you start the node locally, in which you'll have to wait for the whole blockchain to be downloaded, which, like I said, is over 25 gigabytes. And perfect, as you can see, the wallet is synchronized, the daemon is synchronized. If we click on the account in here, we'll be able to access our account page. And as you can see, we have 0 funds because we literally just created the wallet. And that's it. Right now we have our Monero wallet created. Using the wallet in here is very similar to Electrum. As you can see, we have the accounts page, which shows a summary of the account. We can use the send to send funds, receive to get the receive address and receive funds, and transactions to see our transactions. Don't worry about all of this. We will use this more in the next lectures and you'll get very comfortable with it. Now, before moving on, I just want to show you how to log back into this wallet after restarting Tails, because logging in is slightly different than what you're used to with Electrum and other wallets. So I'm going to close everything and I'm going to restart Tails. And now that I'm back and logged in, I'm going to go to the location where I stored my wallet GUI, which is in persistent. So I'm going to go to home. I'm going to go to persistent and it's stored in here in Monero GUI. And as you know, we need to execute this bash file from terminal. So I'm going to right click this, open in terminal. And to execute this file, we're going to type // followed by the file name, which is startgui.sh. This will start the wallet GUI, but as you can see, it starts it as if it's the first time. So unlike Electrum, it wasn't able to detect that I already have a wallet on the system. So we're going to click on continue, that's fine. And at the next step, we're going to say we want to go with the advanced mode. And instead of creating a new wallet, we want to restore our existing wallet. You can use the last option to restore it using the seed, which you should have stored. Or you can click on open a wallet from file and select the file where you stored the wallet. So we're going to click on browse file system. And I'm going to navigate to the location where I stored my wallet. So if you remember, we stored it in our persistent directory inside Monero GUI. And I should have stored it inside wallets. That's why I created that directory. But I accidentally stored it in this directory. So we can see we have a file called John Wick Wallet. This is the name of my wallet. And inside it, I have the wallet keys. So we're going to select that and click on open. I'm going to put the wallet password. And this will log me back into the wallet. Now we're still not ready because as you can see, the wallet is not connected because the daemon did not start. I'm going to click on use custom settings in here because remember, we want to use custom settings to connect through a remote node. So we'll have to do this manually again. We're going to have to click on remote node in here. And we're going to use the same remote node information that we used when we set up the wallet. We actually have to do all of this because the settings of the wallet got deleted after our restart. So again, you'll need to go to moneroworld.com/nodes and copy the node hidden service in here. Remember the port 18099, paste the URL, put the port, and connect. And as you can see now, it's going to start connecting to the node, synchronizing with it so that you can go ahead and start using your wallet. And right now the wallet is synchronized and the daemon is synchronized. So if we go to our account, we'll be able to retrieve the amount that we have, which is 0, as you can see in here. And we can send and receive funds, like I said, and like I'm going to show you in the next lectures. Now that we know what Monero is and why it's so anonymous, in this lecture I want to talk about how we can buy Monero anonymously. Now this task was much more challenging when we were talking about Bitcoin because, as mentioned before, Bitcoin's ledger or the blockchain is entirely public. Therefore, if our identity is linked to an address, any transaction sent to and from this address will be linked to our identity. This is not the case with Monero. As mentioned in the previous lecture, Monero uses ring signatures to hide the source of funds and stealth addresses to hide the receiver. Therefore, if the blockchain is analyzed, there will be no useful information regarding the senders and the receivers. Not only that, even the sender, once the money is sent from the sender doesn't really know where the money is going, again due to the use of stealth addresses, which are not the real address. So when you give a receiving address to a sender, this address is only used once and it's not your real actual address. It's only an address to be used for a transaction. Therefore, if you think of it, you can actually buy Monero using any method, and this method will be much more anonymous than using Bitcoins. So even if you verify your identity when buying Monero, once you transfer your coins from the website that you bought it to your own local wallet, this money becomes untraceable and unlinkable to the account that you used to buy Monero. The only way that this can be linked to you is if you make a mistake, an OPSEC mistake, and someone hacks into your computer, or if you're forced by a law enforcement agency to give information about where you use that Monero. So they'll be able to see that you bought Monero on X website, but they won't know which wallet this Monero went to and what it was used for unless you go ahead and give them the information yourself. With that being said, there are some methods that would be more private and more anonymous because sometimes we just don't want to share our identity and our private information with online websites. Even if this identity will not be linked to our wallet, it's just not ideal. What if that website gets hacked? What about the employees working in it? And the list goes on, again, similar to any privacy concern. So, just like Bitcoin, the most anonymous way of getting Monero is to mine it yourself. Use a powerful computer, help maintain the Monero blockchain, and with doing that you will be awarded XMR or Monero coins, and then use that to purchase or send funds to friends and family. Now doing that is not simple. I can actually make a full course on that, and it's not feasible to everybody. That's why I'm not going to cover it in this course. The other option is, again, something that we discussed when we were buying Bitcoins, is to use an exchange. So you can use any exchange you want. Like I said, even if the exchange requires you to verify your identity, that's fine, because once the funds leave the exchange, they will be untraceable and they won't be able to link your actual identity to your Monero wallet. Not only that, but some exchanges will not even require you to verify your identity if you're buying small amounts. Now, these exchanges change their policies all the time, so the ones that don't require identity verification now will probably require it in the future, and others that require it right now might not require it.
Therefore, the best thing to do is to come to Get Monero, go to exchanges. I will include this link in the resources of this lecture, and go over them, see which ones are allowing people to buy Monero without verifying identity. And if you can't find any, again, it's okay to verify your identity and buy Monero, because like I said, your identity will still not be linkable to your wallet. Some popular ones in here are Bittrex, Binance, Bisq, and Bitfinex. Now, there are other good ones here. Like I said, go over them, read their policy before using them, but most of the ones that are listed here are pretty good anyway. And using them is very, very easy. It's usually the same. You click on the website, you sign up, you buy Monero, and then you transfer it to your wallet. And I will explain how to transfer funds to and from your wallet in the next lectures. I'm not going to cover that though, because like I said, it is not ideal. At the end of the day, you still might have to verify your identity. And even though it's not linked to your wallet, a lot of us might not want to share our identity with third-party websites. Another really good option is to exchange an existing cryptocurrency with Monero. So with this option, we can use our Bitcoins that we already obtained anonymously using a P2P service or a Bitcoin ATM or one of the other methods that we discussed earlier, and then exchange it to Monero. So we already obtained our coins in an anonymous way, and then we're buying Monero, which is even more anonymous because it hides information about the sender, receiver, and the amount. Therefore, the coins in our local Monero wallet will be very, very anonymous. This is a really good option and can be used in so many scenarios. You can even use it if you have coins that are not anonymous and exchange them to Monero to increase their anonymity and become more private. Therefore, I will spend a full lecture talking about how to do this. So stay tuned for that. Another option is to use an ATM, similar to what we did with Bitcoin, and you can actually use the same website to find ATMs that sell Monero. So the same website, coinatmradar.com, you scroll down or you put your country in the search box, and you can uncheck everything here in the left and only keep Monero checked to get the ATMs that only support Monero. Now, as you can see, there aren't many. There are much less than Bitcoin. And in my country, in Ireland, there aren't any. So this option might not be applicable to everybody. But if there is a Monero ATM, then this is a really good option if you can buy it with cash. All you have to do is just go put the receiving address of your wallet and you'll receive the funds in your wallet. Very similar to what we did with Bitcoin ATMs. Therefore, there is no point of covering it again, but you can go and revise the lecture where I use the Bitcoin ATM if you want more information about it. Last but not least, you can use a peer-to-peer service. Again, we showed off a similar service for Bitcoin. For Monero, it's exactly the same. You just need to use a different website. The website is called localmonero.co. The way it works is very similar to the Bitcoin website. All you have to do is put the amount that you want to buy. For example, let's say I want to buy 25 euros worth of Bitcoin. You put the country, in my case it's Ireland, and we're looking for all online offers. So from this drop-down list, you can list all of the payment methods. As you can see, you can pick cash, which is very, very anonymous. You can do cash by mail. You can do cash at ATM. So there are a number of methods. Once you're happy with all the options, you click on search and you'll get all the local sellers that will allow you to buy Monero using the payment method that you selected. Now, as you can see, again, in my country, in Ireland, unfortunately, there aren't any local sellers. But if you pick a bigger country, such as the United States, you will actually see a number of sellers that will sell you Monero by cash by mail and other anonymous payment services. Again, using this is very simple. All you'll have to do is click on buy, follow the instructions, send the money to your local Monero address, which I will show you in the next lecture. And that's pretty much it. You'll have the money in your wallet. And because you're using Monero, the money is untraceable and unlinkable to previous transactions.
So that's it for this lecture. Just wanted to list the main methods that you can use to buy Monero anonymously. And in the next lecture, we'll talk about how to exchange it with other cryptocurrencies, and we'll see how to send and receive Monero. In this lecture, I want to talk about crypto exchanges. These are services that allow us to exchange one cryptocurrency to another. These can be very useful because you might want to get a certain crypto, for example Monero, but you can't find any peer-to-peer sellers in your area, or there are no ATMs which you can use to get that cryptocurrency. Therefore, you can get a more popular cryptocurrency such as Bitcoin and then exchange it to Monero. Right now, I'm only talking about Bitcoin and Monero, but there are a lot of different types of cryptocurrencies that you can exchange. So learning how to use exchanges will open the door to so many possibilities. For example, what you can do is you can use cash, so use an anonymous method to buy Bitcoins. So you're already anonymous at this point, and then to increase your anonymity, use a crypto exchange to exchange Bitcoins to Monero, and then you're very, very anonymous and very hard to trace. Alternatively, let's say the end goal is you want Bitcoins because you're sending money to a person or a seller that only accepts Bitcoin, but you want to be as anonymous as possible. Then you can buy Monero with cash, again using one of the methods I explained in the previous lecture, and then convert this Monero to Bitcoin using a crypto exchange. Now, as you know, cash is anonymous. Transferring the money into a Monero wallet will make it even more anonymous, like we said, because it hides the sender and the receiver and it's not linkable. And then sending that to Bitcoins will make your Bitcoins very, very anonymous and very hard to trace and tie to your identity. Alternatively, let's say you tried everything and you could not buy a cryptocurrency with cash with an anonymous method. That's fine. You can use an exchange service such as Coinbase and others that would verify your identity, and then the money you use will be tied to your identity. But you transfer that money to a Monero wallet. Again, once you do that, that link is broken because Monero hides the sender and the receiver using ring signatures and stealth addresses. Therefore, once you send that money to a Bitcoin wallet, it's very anonymous, and the Bitcoin address that you're gonna use will not be linked to your identity, even though you verified your identity when you bought the cryptocurrency, when you bought Monero for the first time. You can do the same, again, use a service that verifies your identity because these are available in everywhere in the world, so you can always use them as a last resort. And again, buy Bitcoins. Now, at this stage, the Bitcoin address will be linked to your identity because Bitcoin is not anonymous. But once you convert that Bitcoin into Monero, the link is broken, and this wallet right here will be very private and will not be linked to your identity. All of this is possible thanks to exchange services that allow us exchange one cryptocurrency to another, and the anonymity is possible because of the way Monero is implemented, because of the way it uses ring signatures and stealth addresses. Now, to go even one step further and become very, very anonymous, what you can do is you can use what's known as churning, and basically whenever money arrives into a Monero wallet, you can transfer it between multiple Monero wallets before sending it to another place or before converting it to another currency, or you can literally send the money to the same wallet. Again, with Monero, sender and the receiver are not linked, so every time you send money from one address to another, even if you send it to the same wallet, that increases the distance between the wallet and the source of the funds, therefore making it very, very difficult to trace. So, in order to be able to do all of this, you'll have to use a crypto exchange. Now, there are a number of crypto exchanges. If you just go on Google and type crypto exchange, you'll get a lot of services. If you go to Get Monero Community,
You will see a number of services here as well, and I will include this in the resources of this lecture. And like I said, the policies of these services change often, so always stay updated on what's new. Always stay updated to see which ones will require to register and verify ID or not. But at the time of recording this lecture, a really good service is Morph Token right here. It doesn't require us to sign up, and it doesn't require ID verification. Using these services is pretty much the same. Therefore, in the next lecture, I'm going to show you how to use this one just as an example, but you'll be able to apply the same steps when using other similar services. Okay, so now that we know what crypto exchanges are and how they can be used to convert one cryptocurrency to another, and why you might want to do this, in this lecture, I'm going to give you an example of using a crypto exchange called Morph Token. Most of these exchanges are very similar anyway, so this will give you a good idea on how to use any crypto exchange really. Anyway, in general, these websites use very intuitive and easy to use interfaces. So for this one right here on the left, you have to specify the deposit currency. So as you know, we want to transfer from Bitcoin. So if you're depositing a different type of coin, you can pick it from here, but I'm leaving it at Bitcoin because we want to actually deposit Bitcoin and we want to transfer that. We want to receive Monero. Again, if you want to convert your Bitcoins to another coin, all you have to do is click in here and select the other coin. Next, you want to specify the amount of deposit, the amount of Bitcoins that you want to convert to Monero or to the destination currency. Now, for this website, the minimum amount that you can convert is 5 micro Bitcoins, so 0.005. You should read the frequently asked questions of whatever service you're using to make sure that you send more than the minimum amount, because sometimes if you send less than the minimum amount, it will be considered as a donation. So this is similar to what happens with Bitcoin mixers. Now, if we go down into my wallet, I have my Electrum wallet right here, my Bitcoin wallet. You can see that my balance is 5.6 micro Bitcoins. So this is 0.0056. You divide this value by 1,000 to convert it from micro Bitcoins to Bitcoins. So I have more than the minimum amount. So that's fine. So I'm going to set this to the minimum amount. Now remember, like I said, this is in Bitcoins, not in micro Bitcoins. So 5.6 micro Bitcoins will be equal to 0.0056 Bitcoins. Now I actually don't want to send all of this. I'm just going to send 5 micro Bitcoins. So it's 0.005. The receive is already set to Monero, so we're good to go. You can also use the weight in here if you want to convert the deposit coin to a number of different cryptocurrencies. So you can click on the plus in here to add more entries. And when you do that, for example, in this case, 50% of my Bitcoins will be converted to Monero and 50% will be converted to Ethereum, which is another cryptocurrency. And you can keep clicking on the plus and split your Bitcoins into a number of different cryptocurrencies if you want. Now, in my case, I want to keep everything for Monero, so I'm going to click on the minus here and we're going to click on Morph to start the process. In the next page, it's asking us for the refund address. This is the address of the wallet that will send the funds. As the name suggests, the only reason you need this, in case something goes wrong, the money will not be lost, it will be sent back to the wallet that it came from or to the address that you specify in here. So I'm going to go down and this is the wallet that will send the money. And I'm going to set it as the refund wallet. So I'm going to click on receive as usual, copy its address and paste it here. That's done. The next step is to give the address of our Monero wallet, which will receive our Bitcoin coins after being converted to Monero or XMR. So again, we're going to go down and this is my Monero wallet. You'll notice that using these wallets is actually very, very similar. If you want to receive money, you click on receive, similar to what we do with Electrum. Now, in your case, you'll probably only have one address in here, the primary address. I have 2 other addresses here because I created them manually, and it's actually a very good idea to always create new addresses for every transaction you make. Therefore, this is a new transaction. I'm going to click on create a new address. You can set any label for this, so I'm going to call it test3, and I'm going to click on OK. And now when I click on this, you'll see that the QR image changed. This is the QR image for address 3 for this wallet, and I can click on this icon right here to copy this address to my clipboard. As you can see in here, it's saying the address is added to the clipboard, and I'm going to go back to my website and I'm going to paste it here so that this will be the address that will receive the coins after they're converted to Monero or XMR. Once we're happy with setting the refund address and the receiving address, I'm going to click on start to start the process. And perfect, now the process has started. We have our ID right here. If you go down, again, you can see it's telling you what's the minimum amount that you can transfer. It's 0.005. This is what we picked anyway, so that's fine. And then it's giving us the address of the wallet of this website. So we should transfer our coins to the address that we have in here. This website will convert our Bitcoins to Monero and then transfer it to the address that we gave as the receiving address, which is the address of this wallet. So right now I need to go to the wallet that I'm sending money from. I'm going to go to the send tab as we've seen before. We're going to set the pay to address to the address that we got from here, the address of the wallet of this website. You can set a description for this, but I'm going to leave it blank. That's fine. The amount, we're going to set that to 5. Remember, this is in micro Bitcoins, so it's equal to 0.005, which is what we picked in here when we initiated the process. I'm going to keep the fees as they are, and I'm going to click on send to send the Bitcoins. I'm going to put my password, and perfect. Now the payment is sent. And if we look in our history tab, you can see that it's sent. It's still unconfirmed, so you want to wait for this as usual. And if we go to the website, you can see that it's waiting for confirmation, but it received my 0.005 Bitcoins. So all we need to do right now is literally wait for these guys to receive my Bitcoins, convert them to Monero, and then they will transfer it to my Monero wallet right here. Now I've actually paused the video for a bit, and right now, as you can see, I received the funds in my Monero wallet. If you click on account, you should see the amount that you transferred in here in your wallet. And as you can see right now, this is in XMR in Monero. So we basically converted our coins from Bitcoin to Monero XMR. And like I said, once we do this, we basically broken the link between all of the previous transactions and the coins in this wallet. So right now, if I go ahead and use the coins in this wallet for anything, it'll be untraceable and unlinkable to the Bitcoin wallet that sent the money to this wallet right here. So even if the Bitcoin wallet was linked to my identity or compromised, it's still safe to use this wallet in here because it is not linked to the previous wallet. And therefore, it's not linked to my real identity. Now, before wrapping up this section, I want to draw your attention to something that is very, very important. In many countries, using darknet markets is illegal even if you buy legal goods or if you're paying for legal services. The reason for this is a lot of darknet markets also include illegal goods and illegal services. So if you're using a market that offers illegal services, in many countries, using this market is illegal even if you're buying legal goods. And the reason for that is you'll be considered that you're aiding a criminal organization or an organization that is involved in criminal activity. Now, this is not the same for all countries, like I said, so you want to check with your country. And you can always just use normal darknet markets that just don't offer illegal services and illegal goods. Unfortunately, these are hard to find, but I just wanted to get this idea across. Now, throughout all the previous lectures and sections, we learned a number of things, and I tried to cover them as isolated modules so you can plug them in whenever you need to use them. So we learned how to access the internet anonymously, we learned how to access the darknet, we learned how to discover darknet services or hidden services or onion services, we learned how to communicate privately and anonymously using anonymous email providers, using private instant messaging, we learned how to add end-to-end encryption, we learned how to use PGP, we learned how to share files anonymously, and so on. So you can use any of these skills depending on the situation that you're in, because I can't imagine all of the possible uses that you want to use these skills for. For example, you can be a security researcher, simply researching what's happening on the deep net, or you can be a journalist trying to communicate with your colleagues anonymously because you have some sensitive information. So the possibilities are endless, but in my opinion, the skills that I covered so far can be used to do pretty much anything that you want to do on the darknet. So you should even be able to use them to buy goods if you wanted to, as long as what you're doing is legal in your country. Because I've taught you how to create an email, and you will need an email when you're signing up with marketplaces. I taught you how to communicate using PGP, and you will need to use that when you're communicating with sellers. And I taught you how to obtain cryptocurrency, send it and receive it. And again, you'll need that to pay for services and goods. So like I said, again, this is one example, one use of the skills that I taught you, but they can be used to pretty much do anything you want on the darknet, or if you just simply want to use the internet in a more private and more anonymous manner. In the previous sections, we learned how to use a number of programs and a number of services that help us improve our anonymity and privacy. We also learned how to access hidden services or onion services, or what's known as the darknet, and we learned how to use some of these services and some of these websites. In all of these sections, we used an operating system called Tails, and as mentioned, this is a live and amnesic operating system that is based on a fully patched and hardened Linux distro. It routes all traffic through the Tor network, so it's relatively secure and it's relatively private. We installed it on a USB stick, so we use that USB stick to boot into it from any computer. And then as soon as we shut down that computer or pull the USB stick out, everything will be wiped from that computer and it will remove all traces. So all in all, it's a pretty nice package. It's very portable, very convenient, and that's why I chose to use it in all of the previous sections, because it provides relative security and good privacy and anonymity as long as you don't make any OPSEC mistakes, such as logging into an account that is tied to your identity or interacting with other accounts that can be linked to your real identity. Now this is all great, but note that I said relative security. I said that because we can do better. See, the problem with Tails and most operating systems is the fact that everything is running under one domain. So if a hacker manages to hack into this computer, whether it's running Tails or any other operating system, they'll get access to this whole domain. And first of all, they'll be able to bypass whatever anonymity measures you're using, and they'll be able to easily de-anonymize you. And they'll also have access to all of your files and be able to control the computer and do anything that you can do as a user. So even if you're using the greatest anonymity methods and you're using different proxies and Tor and VPNs and all of that, if somebody hacks into your computer, it's game over. All of that can be bypassed easily. That's why security is very, very important, and that's why it's linked to privacy. You can't be private or anonymous if you're not secure. A good solution to this problem that can improve our security is to use different computers for different tasks. For example, use one computer for work-related tasks, use one computer for your personal-related stuff, use another one for the untrusted stuff whenever you're just browsing through websites and opening attachments and so on. Use one computer that is not connected to the internet to store your passwords and keys. This way, if somebody manages to hack into one of these computers, they'll only get access to one computer, and it'll be very difficult for them to move from this computer and compromise the other computers. Not only that, but the fact that you have an untrusted computer that you don't do any personal or work stuff on means that this will be the computer that will probably be hacked, not the other ones. So all of your important stuff in work and personal will not be hacked, and the hackers will not be able to gain access to them. Also, if you're using a separate identity on this untrusted computer, then your real identity or the identities that you use on work and personal, again, will not be compromised. So this is a really, really good solution. The only problem is it's not cheap. You need a number of computers, and it's also not easy to achieve. So imagine having to use a different computer every time you want to do a different task. You can make this slightly easier and use one computer, but use multiple Tails USB sticks, and again use each one of them for a separate domain, one for work, one for personal, one for untrusted. But again, this is not very usable because let's say, for example, you are using the work USB stick and you opened your work email, you're reading an email and there is an attachment, and you really want to open that attachment, but you can't really trust that attachment because it could be anyone. It could be a hacker pretending to be a friend, or it could be someone who gained access to your friend's account. So if you want to follow this model and if you want to be secure, you need to boot into the untrusted distro or the untrusted USB stick and open the attachment there. Then once you open it and read it, if it's fine, you need to turn this off, boot back into your work USB stick, your work domain, and then reply to the email. So you can see that if you're doing this every day, it's not very practical and it's going to become very, very annoying. This is where the idea of Cubes came from. Cubes is an operating system that is designed to improve security by compartmentalization. So as soon as you boot into this operating system, it boots into Zen, which is a hypervisor. And then once the operating system starts, everything inside this operating system is separated into different domains. You'll have a domain for work, a domain for personal, an untrusted domain, and so on. And each one of these domains is a completely separate virtual machine. So you can think of these virtual machines like completely separate computers, and hence the name virtual machine. So each one of these virtual machines has its own RAM, its own CPU, its own file system, and so on, and is completely unaware of the other virtual machines. So just like running different computers, if your untrusted virtual machine or the untrusted domain gets compromised or hacked, it is very difficult for a hacker to move from there to your work or to your personal virtual machine. Not only that, but Cubes also separate other system components into virtual machines. So you have your networking, your file system, your USB controller, and your firewall, all running inside their own virtual machines. So if a hacker manages to exploit a vulnerability in any of these components, then only get access to this isolated virtual machine that is not even aware of the existence of your work and your personal domains and so on. And with this, you won't need to have multiple computers and you won't need to keep restarting and booting into different USB sticks. You'll always be using the same operating system and the different virtual machines will be running inside this one single operating system. Now, these nice features come at a price. Cubes is very resource hungry and has specific requirements. I'm going to include these requirements in the resources of this lecture, so please go through them before attempting to install it. Now, before moving into the next lectures where I'm going to show you how to install Cubes and use it, I know right now you're thinking, do I really need to install Cubes? And the answer really depends on you and your threat model. With Cubes, we're not going to be using any other magical methods to become more anonymous. So you'll still be using Tor, you can still use a VPN and multiple proxies. Nothing that you can't do in Tails. The only difference is the added security that Cubes allows by compartmentalization. Therefore, if someone targets you specifically trying to de-anonymize you, they're less likely to be able to hack into your computer or to gain access to it and therefore de-anonymize you. So Cubes is only more anonymous and more private because it is more secure. It makes it more difficult to hack into your computer and therefore more difficult to de-anonymize you. So, whether you should use Cubes or Tails really depends on your threat model. If you think there are people that will actively try to hack into your computer in order to de-anonymize you, then obviously Cubes is a better solution because it's a more secure operating system. Other than that, Tails is good enough as long as you don't make any OPSEC mistakes, such as communicating with accounts linked to your identity, and as long as you use it within one domain. So you don't need to use Tails for work, personal, and for browsing. You're only using it to access the darknet for research or for other reasons. Then in that case, Tails can be good enough. So just like anything else in this course, go through the Cube section, understand how it works and why it's useful, and at the end, based on your threat model and based on what you want to do, make a decision on what's best in your case.
Okay, so now that we understand what Cubes is, why it's so secure, and why you might want to use it, if you're ready to take on this challenge and if you have a computer that can support Cubes, then you can follow the instructions that I'm going to show you in this lecture and the next lectures to learn how to install Cubes. Now we have two options. We can first of all install it as a main operating system on the built-in storage of your computer, or we can install it on a USB stick as a live operating system. So for now, we're gonna need a USB stick with at least 8 GB of storage. We will also obviously need to download Cubes. We're going to use Etcher, which is the same program that we used to flash Tails. So we're going to use it to flash the Cubes ISO image to the USB stick. And that way we're going to have a bootable USB stick that contains the Cubes ISO image. At this stage, we have two options. We can either just simply connect it to a computer and install Cubes on that computer, on the built-in storage of that computer, just like any other operating system, so we'll be able to use it without even connecting the USB stick. Or you can use another USB stick of minimum size 32 GB, and what we'll do in this case is we will flash a live version of Cubes to the new USB stick. And then we can use this new USB stick to boot into Cubes from any supported computer, regardless of what operating system this computer runs. So we can connect it to a Windows computer or Mac or Linux, and we'll be able to use Cubes on any of these computers. And once we disconnect the USB stick, the computers will be back to normal, running the default operating systems that they used to run. Now the installation steps are identical for both options except for one small change, and I will highlight that change once we get to it. So let's go back to the start. Everything that I'm going to show you from now on will be done on a Windows computer, but you can follow the exact same steps and use the exact same software that I'm going to use on Windows to install Cubes from any other operating system. So you can follow these steps from OS X and from Linux using the exact same software. If you face any issues, then please post them in the Q&A section and we'll respond to you within 15 hours. So I have the Cubes official website open in here and I'm already in the download page. I will include this in the resources of this lecture, and I'm going to scroll down and I'm going to download this version right here. So all you have to do is just click on the ISO button in here. Now clicking on this will start the download for you. This is a 4.6 GB file, so it's pretty big. That's why I've already downloaded it before this lecture. As you can see, I already have it downloaded here. The next thing that you want to download is the signature that's associated with the ISO image. We're gonna download this because we're gonna use it to ensure that the ISO image did not get modified by a third party as we downloaded. Because as we said before, whenever you download something from the internet, it passes through a number of hops and it can be modified by a number of entities. Therefore, we're gonna download the signature in order to use it to verify the integrity of the ISO image and make sure that the ISO image did not get modified since the developers of Cubes created the signature. So to download the signature, we're going to right click it and click on Save Link As. I'm going to put it in my downloads and I'm just going to click on Save. And if I look in my downloads right here, you can see we have the signature file that we can use to verify the integrity. Now, the steps that I'm gonna follow right now to verify the integrity are very similar to the steps that we followed to verify the integrity of Tor browser when we downloaded Tor. To do this, you can use PGP4Win. I already showed you how to download and install it in the lecture where we downloaded Tor browser and verify it, so I'm not gonna do it again. You can go back to that lecture and revise it and see how to download it and install it. I already have it downloaded and installed, and as you can see, the icon in here shows a lock icon, which means that the software, the PGP software, is already installed on this computer. Now, like I mentioned in that lecture, you can use a graphical user interface to verify the signature in here, but in my experience, the graphical interface is a little bit buggy. Therefore, I'm going to do it using the command prompt. Not only that, but the command prompt commands are identical to the commands that you'd use if you're using OS X or Linux. Therefore, you can follow the next steps on an OS X computer or on a Linux, and they should work exactly the same. Again, if you face any issues, post them in the Q&A and we'll respond to you within 15 hours. So let's go ahead and just make this window a little bit smaller. And I already have my command prompt open in here. If you don't remember how to open it, you just go to Start, type CMD and run it. And in order to verify this file, first of all, we need to download the master key for the Cubes developers. To do that, we can actually just click on the question mark in here beside the verify, and this will actually open a page with detailed instructions on how to verify the Cubes image. But like I said, the steps in here are very, very similar to what we followed when we verified Tor browser when we downloaded it. So, like I said, the first step is to add Cubes master key to the keyring. And to do this, we're going to use this command right here. So I'm literally just going to highlight it all, right click, copy, and right click in here to paste it. We're going to hit enter to download it. You might need to give this a little bit of time to download the key for you, so be a little bit patient with it. And perfect, as you can see now the key is imported. Next, we want to make sure that the key that we downloaded is actually the key for the Cubes developers. To do that, again, this is going to be identical to what we did with Tor browser. So first of all, we're going to copy the key here. So we highlight it, we hit enter to copy it, and then we're going to use GPG, the same command. We're going to say, I want the fingerprint of the key that I just copied. I'm going to hit enter, and we will get the fingerprint of this key. And we're going to scroll down on this page and compare it to the fingerprint that we have on the page itself. As you can see, the two fingerprints are identical. Therefore, we know that the key that we just downloaded is a valid key for the Cubes developers. Next, we need to download the release key, so the key that is used to sign this particular release. And as you can see in the file name in here, it says Cubes R4, so this is the fourth release. So we can go down in here to get the command to download the release key, which is this command right here. So again, we're going to copy all of this and paste it in here. And you'll need to modify the X in here. So as you can see in here, it says X. You'll need to remove this and replace it with the release version. So again, this says Cubes R4. This means it's the 4th release. Therefore, I'm going to type 4 and hit enter to download the key used to sign this particular release. Perfect. As you can see, this key is imported now. So right now, you can literally go ahead and use this file to verify the integrity of the image, but we can go further. This is an optional step, but it's good to just make sure that everything we're doing so far is valid and we haven't downloaded any wrong keys. So you can use this command right here to make sure that the signing key that we just downloaded, the second key, is a valid key for the master key, for the first key. So to do that, again, we're just going to paste the command that I just copied. And just like we did before, we're going to replace the X with number 4. I'm going to hit enter. And as you can see in here, this is the signature of the master key. So you can see in here, this is signed with Cube's master signing key. And if we scroll up all the way to the top, you can see that this is the same signature for the master key. So far, we've imported the master key, we verified it using the fingerprint, then we imported the signing key, and we verified it by comparing its signature with the signature of the master key. So at this stage, we're sure that the keys that we downloaded are valid keys that belong to the Cube's developers. The last step is to use this signature file that we initially downloaded to verify the integrity of the Cube's image that we will actually use to install Cubes. So as you can see, these two files are stored in my downloads, and right now I'm in users ZAID. So I need to navigate to my downloads directory. We can do that by doing cd downloads. And if I do dir to list all files and directories in the current working directory, you can see, first of all, I have the Cube's ISO image, and then I have the signature file. So we're going to use the signature file to verify that the image is valid and did not get modified by a third party. And again, the command that I'm going to use is identical to the command that we used when we were verifying the integrity of Tor browser. So we're using gpg --verify, followed by the name of the signature file, which is this file right here. So I can just type Q followed by a tab, and it will auto-complete for me, and I'll just need to add the .asc. I'm gonna hit enter, and give this a little bit of time to check the integrity of this image right here. And perfect. As you can see in here, it's telling us this is a good signature from Cube's OS developers. This means that this file did not get modified since this signature was created by the Cube's developers. Therefore, we can go ahead and install it on our system, knowing that it did not get modified by any other third parties since it was released by the Cube's developers. Now, in the next lecture, I'm going to show you how to flash this to a USB and continue with the installation steps. Right, so now that we downloaded Cubes and verified its integrity, so we're sure that it did not get modified by anybody else since it was released by the Cubes developers, the next step is to flash Cubes to a USB stick so we can use that USB stick to install Cubes. Now, we're going to use a program called Etcher. This is the exact same program that we used to flash Tails to a USB stick. So, as we know, this program runs on Windows, Linux, and OS X. I have its download page in here. All you have to do is just go to it. It'll automatically detect what operating system you have, click on download, and install it. You can also use this drop-down menu to download it for other operating systems if it did not detect your operating system properly. Now, I will not show you how to download and install it because I've already showed you how to do that previously. If you don't remember how to do that, please go back to the lecture where we flashed Tails to a USB. So, what I'm going to do right now, I'm just going to run Etcher and use it to flash Cubes to my USB stick. Now you'll notice using it is identical to the way that we used it with Tails, but I'm just going to do it again for the sake of completion. So first of all, you want to click on select image to select the image that you want to flash to a USB stick. So we're going to navigate to my downloads where I downloaded cubes, and I'm going to select the cubes ISO image that I downloaded in the previous lecture. We're going to click on open, and that's it selected. The next thing is we need to select the drive that we want to flash this cubes image to. Now I haven't connected my USB stick yet, so I'm just going to connect it to my computer. And as you can see, it will automatically get detected by Etcher. If this wasn't the correct USB stick that you want to flash cubes to, you can click on change and select the USB device that you want. Keep in mind the USB stick that you're going to pick in here will be formatted. Everything stored on it will be deleted. So if you're sure this is the correct one, you can click on flash to start the process. We're going to click on yes to continue. And all we have to do right now is just wait for Etcher to flash the image that we selected, which is the cubes image, to the USB stick that we selected. Okay, perfect. So now the process is complete. As you can see, the image was flashed successfully. So now the USB stick that we selected can be used to boot into the Cubes installer. So in the next lecture, I'll show you how to boot into that and how to use it to install Cubes as a main operating system, or use it to install Cubes on another USB stick so that we have a USB stick with a live Cubes installation that we can use to use Cubes on any supported computer regardless of what operating system it runs. Now that we flashed the Cubes image to a USB stick, we can connect this USB stick to a computer and install Cubes as a main operating system on that computer, or we can use another USB stick, flash Cubes to it, and then use Cubes as a live operating system using this second USB stick. So we'll be able to connect it to any computer we want, regardless of what operating system it runs, and then we'll be able to use Cubes. And when we're done, the computer that we used will be back to using its default operating system. Now, as I mentioned earlier, Cubes is a complex operating system. So unlike the Tails USB, which we connect to pretty much any computer and boot into Tails, in order to boot Cubes image, we have to modify the BIOS settings of the computer that we're going to use. Entering the BIOS settings varies depending on the computer that you have and depending on the motherboard. On the right here, I have a table of the most common computers, along with the buttons that you need to press in order to enter the BIOS settings. So as soon as you turn on the computer or restart it, you'll need to press the button relevant to your computer in here in order to enter the BIOS settings. Once you're there, you want to make sure you enable virtualization. In most cases, you'll also need to disable secure boot and set the boot to legacy. This is optional, but to my experience, I had to do that in a number of laptops. Then you can finally configure your boot order to boot from USB first, or you can just restart and enter the boot menu like I showed you before with Tails and choose to boot from USB. So let me show you how to do this on a real computer. Okay, so this is a Lenovo computer. Therefore, based on the table that I just showed you, I will need to press F2 as soon as I turn on this computer in order to enter into its BIOS settings. So first, I'm gonna hit the power button to turn it on, and as it's being turned on, I'm gonna keep pressing F2 to enter the settings. And perfect, as you can see, I am in the BIOS settings right now. Now keep in mind, depending on your computer, the settings might look different than what I have in here. The main thing that you want to keep in mind is to modify the 4 settings that I mentioned earlier: enable virtualization, disable secure boot, enable legacy mode, and set it to boot from USB first. Like I said, you might find these settings under different categories or under different windows, but just make sure you modify these settings.
So as you can see, for me, the first window that I see is just an information window. It doesn't really allow me to modify anything. Now you can use the keyboard to navigate between these windows or these tabs. So I'm gonna press the right arrow to go to the configuration window. And in here, the only thing that I want to modify is Intel virtualization technology. So I'm going to use the down arrow to navigate to that. And I'm going to hit enter to change the setting, press down to set it to enabled, and hit enter again to select it. Now, if you're not sure about how to use this interface, because like I said, you might actually get a different interface, keep an eye on the instructions that you see at the bottom, as they tell you exactly how to navigate and modify the settings. Now, I'm done with the configuration window. I'm going to press the right arrow again to go into the security tab. In here, again, we have another option that we want to change, which is secure boot. And like I said, this is optional, but in my experience, this can interfere with booting into cubes and prevent you from installing cubes. Therefore, I'm gonna scroll down to secure boot, again, hit enter to change the setting, change it to disabled, and hit enter again. We're done with this window. Now that these are two settings done, we have two to go. So we're going to press right to go to the boot window. And in here, as you can see, the first option is the boot mode. We want to change that from UFI to legacy. So again, I'm going to hit enter and select legacy. You might not get this, but as you can see now, I got an extra option here. The second one, the boot priority, it's set to UEFI first. Again, I'm going to hit enter and change that to legacy first. And finally, you don't even have to do this. I'm going to change the boot order so that it boots from USB first. You don't have to do this because you can exit this and just manually choose to boot from USB. I'm just going to do it here so that when I restart, I won't even have to enter the boot menu. So I'm just going to scroll down to the USB and I'll bring it all the way up. Again, I'm looking at the bottom of the BIOS screen to see how I can move items up and down. So based on that screen, it's telling me that I can use F5 and F6 to do so. Okay, now we're done with all the settings. So we enabled virtualization, we disabled secure boot, we disabled UEFI and we set the boot to legacy, and we set it to boot from USB first. We're done with everything. We're going to go to the exit. So again, I'm going to press the right arrow again. And I'm going to select the first option, exit saving settings. It's going to ask me, do I really want to do this? I'm going to say yes. And before hitting enter, because once I hit enter, it's going to restart my computer, I'm going to connect the USB device that I flashed the cube's ISO image to. I'm also going to connect a second USB device. This is the one that I showed you in green, and this is the one that I'm going to install cubes to. So I'm not going to install it as a main operating system on this computer. I will install it just to this USB stick so that I can use this second USB stick to run cubes on any computer that can support cubes. So I'm going to use it as a live operating system, similar to the way that we were using Tails. And now that we are ready to restart, I'm going to hit enter to save the changes and restart the computer. Now, as you can see, it automatically booted using the USB stick into the cube's image that we flashed to our USB stick. If this didn't work for you, if it didn't boot automatically into this, then enter your boot settings as the system is starting, similar to what we did with Tails, and force it to boot from the USB stick that we flashed cubes to. So now we're ready to go ahead and install cubes, and I'll show you how to do that in details in the next lecture. Okay, so now that we configured our BIOS properly to boot into the USB stick that has the cube's image, as you can see, we managed to successfully boot into cubes and we have the installer right here. So as you can see, right now we have two options. We can select the first option to go ahead and install cubes straight away, or we can go with the second option to test the hardware that we have first and then install cubes if everything is fine.
So I'm going to go with the second option. So I'm going to press the down arrow and hit enter to first test the hardware that I have. And if everything is fine, we will go ahead and install cubes. Perfect. So we have the installer here, which means that we passed all the tests so far. Now, the next steps are actually going to be pretty simple. First, it's asking us for the language. I'm going to keep it at English. You can change it to whatever language you want. So I'm just going to click on continue here on the bottom right. Next, we have a window that allows us to change a number of settings. You can change the keyboard, the time, the language. I'm actually going to keep everything the same. The only thing that I want to change is under the system category in there, which is the installation destination. This is the location where Cubes is going to be installed to, and this is the only difference that I've always been talking about between installing Cubes to as a main operating system or installing it on a USB stick. So we're going to click on this to change this setting. And this will show us a window that will list all the storage devices connected to this computer. So the first storage device that I have there on the left, you can see the size of it is 931 gigabytes. This is the built-in hard drive inside my computer. So if you want to install Tails on this hard drive as a main operating system on this computer, you'll need to select this hard drive. Alternatively, if you want to install Cubes on a USB stick and then use it as a live operating system, similar to what we were doing with Tails, so you'll be able to connect it to any computer that supports Cubes and use it on that computer, and then when you remove it, the computer will be back to using its default operating system. If you want to do this, then connect a second USB device to this computer. The minimum size of this USB device should be 32 gigabytes. As you can see, I have one connected to it and its size is actually 57 gigabytes, so it's over the minimum. So all I'm going to do right now is literally just click on the storage device that I want to install Cubes to, which is my USB device right here. As you can see, it's ticked right now, so it's telling me that this is where Cubes is going to be installed to. And again, keep in mind that when you select a device in here, everything stored on this storage device will be removed and Cubes will be installed there. So make sure you don't have anything important to you because it will be erased. So I'm going to click on done there on the top left. Now Cubes by default will encrypt the storage device that you pick. So right now it's asking me for a passphrase to use for this encryption. We'll be using this password to unlock the storage device that we picked in the future when we want to use Cubes. So I'm going to put my password in here and I'm going to click on Save Passphrase. Now in general, you should go back to the main menu at this stage. In my case, the USB device that I picked is not formatted properly. I intentionally did this just in case you face this issue. So if you're back at the main window, this is perfect. If you got the same warning that I have right here, then follow what I'm going to do in order to properly format this storage device and install Cubes on it. So we're going to click on Reclaim Space here at the bottom right. We're going to click on Delete All. And we're going to click on Reclaim Space. And that's it. We're back at the main window and we're good to go. So we're going to click on Begin Installation on the bottom right here. Now, like I said, this will take some time, so be patient with it. It will even take longer time if you're installing it to a USB stick like I'm doing right now. So I'm going to pause the video and we'll resume once the installation is finished. Okay, so now the installation is complete. We will need to create a user in order to boot into Cubes using the USB stick. So I'm going to click here on User Creation. I'm going to set a username and then I'm going to set a password. And I'm going to click on Done. And right now I'm going to click on Finish Configuration on the bottom right. Okay, now the configuration is complete. And as you can see here at the bottom right, I can click on Reboot to reboot the computer. And then if I keep the second USB stick connected to the computer, it will automatically boot into Cubes. because I changed the boot order, or if I disconnect all the USB sticks, it'll boot into the default operating system that this computer runs on. So I'm going to click on reboot, and as soon as the computer restarts, I will disconnect the first USB stick, this one. This is the one that I used to install the cube's image, and I kept the second one, the bigger one, connected to the computer in order to boot into the cube's operating system. And as you can see, it's automatically booting into cubes. So it's very important to distinguish between the two USB sticks. We use one of them in order to install cubes, either to the built-in hard drive as a main operating system or to another USB stick. And then if we installed it on another USB stick, the second one will be the one that we use when we want to boot into the actual operating system. Right now it's booting into the operating system. Be patient with it. And as it's booting, as you can see, it's asking me for the disk password. This is the encryption passphrase that we chose when we installed cubes. So I'm going to enter it and hit enter and just wait for the operating system to start. Now we're going to click on Cubes OS to set some final options. I'm going to keep everything to the default settings. You might want to enable this option if you want to download updates over the Tor network. I'm going to keep it unchecked because that will slow it down. Downloading updates is usually not banned, so you can just keep this unchecked. So I'm just going to click on Done and wait for Cubes to configure the virtual machines needed to run the whole operating system. Okay, so the configuration is finally complete now. This did take some time again, and it actually seemed like it froze at some stage there. So you will get this during the installation process. If it seems like it's stuck at a certain point, as long as the mouse is moving, then don't turn off the computer. Just give it its time, be patient with it, and it should finish the installation. So now everything is done. I'm going to click on Finish Configuration here at the bottom right. And perfect. Now we have the normal login screen for cubes. So now in the future, all you have to do is connect the second USB stick to the computer that you want to boot cubes from. Boot from USB, and you will get to this screen. You won't go through the configuration every time. So put the password that we set, hit enter. And perfect, now we are inside the cube's desktop. Now you can see this is very similar to a basic Linux interface. If you have some experience with that, you'll be able to easily navigate this. If you don't worry about it. We'll talk about it in details in future lectures. But right now we finished installing cubes as a live operating system to a USB stick. Now to turn it off, we're going to go to the top right, click on Shutdown, and click on Shutdown again. Now just to show you, so if I disconnect my second USB stick, this one right there, this is the one that we installed cubes to. So if I disconnect it and start my computer, you'll see that it's gonna boot into Windows, into the operating system that it used to run before by default. So this is the whole point of installing cubes to a USB stick. We'll be able to connect it to any computer that can run cubes, use cubes on that computer, and when we're done, the computer will be back to its original state, and we'll be able to take this USB stick with us anywhere we want and use cubes from it. Okay, so now that we have cubes installed and we booted into it and we logged in this lecture, I want to give you a very basic overview of the operating system, and then we'll get to use it more and more as we go through the course. So as soon as you log in, you will probably see this window right here, which is a configuration window for the Whonix gateway. This is the gateway that will direct all the data that we send to the internet and force it to go through the Tor network. Now, before configuring this, I want to give you an overview of the operating system, like I said. So I'm going to keep this to the side because I want to connect to the internet first before we configure this. The first impression, you'll probably notice that this looks very similar to a lot of Linux operating systems. You have a status bar in here that shows the running applications. And on the left here, you have a menu which allows you to run various applications in this operating system. You'll notice we can run a terminal in here, which is very similar to Linux terminals, like I said, and runs a lot of Linux commands, plus some Cubes specific commands. Other than this, you will also notice that we have System Tools menu, which allows you to access different applications related to the operating system. The one that you'll be using the most is the Settings Manager. Again, this is very similar to the settings application you get on a lot of Linux distros, and it allows you to change the various settings of the operating system. You can change the appearance, the desktop, the background, the windows, the mouse and keyboard, the languages, and so on. I've actually used this to modify the font size and the icons and even the theme here on top. So you'll notice the theme that I have right now is slightly different than what you see on your desktop if you just install Cubes. The reason why I did this is just to make it a little bit more readable and easy for you to see what I'm doing if you're watching this from a small screen or from a phone. So, very simple settings. You can click on whatever setting you want to modify, and then you can modify the different settings just like any other operating system. So it's very, very intuitive, and there is no point of wasting time on this. Again, in the System Tools, other than the Settings Manager, you will find various settings and various applications that you can use to configure your system. So you have the Package Manager, where you can install different programs in different packages. You have the Updater, where you can check for updates and update the system. You'll have your Cubes Manager, and we'll talk about that in details later on. You'll have the global settings for the operating system. Again, we'll talk about that later on. You have your backups, you have your updates, again, screensaver, and so on. So you can spend some time with this, trying to familiarize yourself with it, or just keep this in mind that you have the System Tools in here in case you wanted to modify any settings related to your system. Other than this, everything else you see in this menu will allow you to launch applications, and all of these applications are categorized or grouped based on different security domains and different virtual machines. And we'll talk about that in more details later on. Now, moving on to the right on the status bar, you will see that we have 4 different boxes. Each box of these is a desktop. So again, this is similar to a lot of Linux distros and even OS X. So you can have multiple workspaces where you can launch different applications and manage your windows, and you can easily navigate through them using this status bar in here by simply clicking on the workspace you want to go to, or using the Control-Alt right or left, so Control, Alt, and arrow to navigate between them. So for example, we already have this window open in here, and if I go to the second workspace in here, I can open my terminal, and I can easily navigate between them in here by simply clicking at the workspace, or by doing Control Alt left to go back to the first workspace, or Control Alt right to go back to where I have the terminal open at my second workspace. Moving on to the right, again, we have our time and date, a calendar, we have the audio settings. Beside that, we have the network settings. So if we click on this, you can see, first of all, we have the Ethernet network, which is saying disconnected. This is because I don't have a wire connected to the computer. If you want to connect to an Ethernet network, just plug the Ethernet cable into your computer, and you should be able to see the network in here. And all you have to do is literally click on the network and connect to it. Alternatively, if you want to connect over Wi-Fi, again, for me, you can see it's saying disconnected, but it's listing all the Wi-Fi networks around me. Now, if you have a wireless card in your computer, but you're not seeing any networks, that means that you need to install the drivers for your card. And this really depends on the chipset used in the card. So you'll have to go and Google and research the chipset used and see if it's compatible with Cubes. If it is, you'll have to see how to install the drivers. In my case, I was lucky. Qubes is able to detect my Wi-Fi card automatically without having to install anything. So all I have to do is literally click on the network that I want to connect to, put the Wi-Fi password, and perfect. As you can see, the icon in here changed to an icon that is showing me the signal strength, and it's also saying the name of the network that I connected to. And if I click on it, we can see that we are connected to this network, and we can click here to disconnect. So right now I should have internet connection on this computer, but I'm not going to open any websites. We'll talk about that later on. So we're just going to move on, just talking about the basics of Qubes. And the next icon that we have in here is the clipboard icon. And this is basically where you'll see whatever you have copied, because copy and pasting in this operating system is slightly different than what you're used to in other operating systems, again, to improve the security of the system. Next, we have the device manager. So in here, you have all of the devices connected to this computer right now. And using this menu, you can select where do you want to connect each of these devices. So as we mentioned, Qubes is designed to improve the security by separating and isolating the different components of the system. Therefore, when you connect a USB device or any type of a device, you'll have to explicitly say which domain you want to connect this device to. Now, I know this sounds a little bit vague right now, but we'll use it in the future, and you'll see how you can connect different devices to specific security domains, and you'll understand how this actually improves our security. Next, we have the storage manager, and you can see the storage devices connected to this computer. Right now, we can also see the disk usage of our system. Next, we have the Qubes manager, which is something that we will spend a lot of time talking about, again, later on. Basically, what it does is it shows you the amount of resources each cube or each virtual machine is using at the moment. And by hovering over any of these virtual machines, we'll be able to enter its settings, we'll be able to pause it, shut it down, or run a terminal inside the virtual machine. If you just go down to the last option in here, Open Qubes Manager, you'll get the Qube Virtual Machine Manager, which allows us to modify various settings of all the installed virtual machines and see their status, update them, and all of that. And like I said, we will spend a full lecture talking about this, so don't worry about it for now. Just wanted to show you where it is and how to enter the Qube Manager. Finally, we have the update icon in here. You'll only see this if there are updates available. Again, you can click on it and launch the updater to update your installation. We have the power settings beside it. And finally, we have our user, which is in my case, John. Clicking on this will allow you to lock the screen, suspend, shut down, or log out. So as you can see, very simple and intuitive interface. You're probably able to figure out most of the things that I was speaking about earlier by yourself, but I just wanted to make sure that I cover everything in here before we dive deeper into this operating system. And I also wanted to cover how all of these are virtual machines in here so that you get an idea of what's coming in the next lectures. Now, I'm going to go back to the window that I said you'll see as soon as you log into the computer. So like I said, this Windows is related to the Unix gateway. This is the gateway that will force all traffic to go through the Tor network. So this is something that we actually do want to configure. And you can see the options in here are very similar to the options that we see when we first launched the Tor browser. So we can leave it at connect to just connect simply to the Tor network. We can click configure if you want to use a bridge or a pluggable transport. Now, if you don't remember what bridges and pluggable transports are, please go back and revise the lectures where I covered them, because I covered them in details and I covered multiple ways on how to get bridges and pluggable transports and why you might want to use them. Therefore, I'm just going to keep this at connect at the basic setting, and I'm going to click on next. And this is just showing us a summary that we're going to be connecting to the Tor network. The bridges are disabled and we're not using any proxies, so that's fine. We're going to click on next. And perfect. As you can see right now, it's telling us that we are connected to the Tor network. Now, keep in mind, please don't go and start browsing straight away. Not all web browsers in this operating system will forward traffic through the Tor network. So don't just go and access dark web websites right now. Wait for the next lectures, and I will explain to you the different web browsers and the different gateways inside this cool operating system. Now that we had a basic overview on cubes as an operating system, in this lecture, we're gonna dive deeper. We're gonna learn about the structure of the operating system and how to launch different applications and use them in a secure manner. So in the previous lecture, I said we can access all the applications from the top left menu in here. And other than the tools, like I said, each entry in here is actually a virtual machine, and then each one of these virtual machines contain different applications that you might want to use. Now, like we said before, basically a virtual machine is another completely separate operating system that runs within our current operating system, within this computer right here. So each one of these entries in here is another operating system, and hence the name virtual machine. It is as if it's a completely different computer. It has its own storage, it has its own RAM, its own CPU, its own resources, and therefore this implementation is very, very secure because none of these virtual machines can communicate with each other. So if one of them gets hacked or an application that is stored in one of these virtual machines gets hacked, it will not be able to compromise the other virtual machines. Now you'll notice there are different types of virtual machines in here. We have disposable virtual machines, domain, service, and template. The disposable virtual machines are amnesic virtual machines. So these machines are designed to be used to run untrusted files or files that you think might be malware or viruses, because once you run these files in them, even if these machines get hacked, the virus or the backdoor cannot move, or the hacker cannot move and compromise other machines, because like we said, everything is a completely separate machine. Not only that, once you turn off this disposable machine, everything that was stored on it, including the virus or the backdoor, will be removed. So when you start it again, it will start a completely brand new machine. Next, we have the domain virtual machines, and you can see these have different colors. And the idea of these machines are normal computers or normal virtual machines that can be used for normal usage. So you have one that's called personal. You should use this for whatever personal use you use a computer for listening to music, watching YouTube, watching my videos, whatever you usually do on a personal computer. You have an untrusted domain. This is a virtual machine that is designed for you to do untrusted things. For example, doing the normal web browsing. If you are searching for something and you're not sure if you're gonna land in an untrusted website, then you can use this untrusted machine. Don't open your email or any accounts on this because it's untrusted. You're gonna be doing untrusted tasks and opening untrusted websites. Therefore, even if this machine gets hacked, your personal data on your personal computer will not be compromised because they are two completely separate virtual machines. We have a vault domain, and this domain is a virtual machine that is not connected to the internet. And the whole idea of this is you store your most important and most secretive files or data. So you can store your secret keys, you can store your passwords, you can store documents that are very important and you can't risk them being leaked. And again, the whole idea is this is not even connected to the internet, and it's a completely separate computer, completely separate virtual machine. Therefore, it is very, very, very difficult or next to impossible to hack into. Finally, we have a work domain. Again, this is just another virtual machine that is designed for you to use for your work tasks. So you can open your work email, you can log into your work if your work needs you to log into a certain platform. And again, this is a completely separate virtual machine. So if any of the other machines get compromised, your work, whatever you have in this virtual machine, will not be compromised because it is a completely separate virtual machine, a completely separate computer. Now, this whole idea of separation between domains and between virtual machines is what Cubes is made of, is what Cubes is designed to do. And even if you think this is a little bit vague, don't worry about it. I'm going to give you examples in the next lecture where I'm going to have different virtual machines and the whole idea will become very, very clear. Other than the domain virtual machines, we have a number of service virtual machines. Now, these are virtual machines designed to carry out system services. So even though these are virtual machines, you don't usually use them to carry out different tasks. So we don't use them to access the internet, or we don't use them to store files. The idea of these virtual machines is to provide services for the operating system. For example, the sys firewall right here is literally the operating system firewall, but to improve the security of the operating system, the whole firewall is stored in a completely separate virtual machine. Same goes for the sysnet. Sysnet is basically a virtual machine that is designed to encapsulate your networking, the networking of this computer. So if for any reason, if someone manages to exploit your networking, it will be very difficult for them to escalate their privileges and gain access to the other virtual machines. We also have another networking virtual machine, which is the syshunex. This is the Hunex gateway, which basically forces all traffic to go through the Tor network. And we'll see how we can configure virtual machines to use this gateway. And basically, we'll have an operating system very similar to Tails. And finally, we have a number of template virtual machines. These are machines that the other virtual machines, such as the domain virtual machines right here, are based off. So, for example, the work virtual machine and the personal virtual machine are both templates of the Fedora 30 virtual machine. So, if you update the Fedora 30 virtual machine right here or install Pigeon on it, automatically personal and work, because they are based on this template on the Fedora, they will automatically get updated and they will automatically get Pigeon. And we'll talk about that in more details later on. Now, I know I spoke about a lot of different types of virtual machines and domains. Don't get confused and don't worry, we will be using them a lot in the next lectures, and as we use them, the difference will become clearer and you'll find it very, very easy to understand. The main idea to keep in mind is the only virtual machines that you will actually be using for your day-to-day use are the domain virtual machines, the ones that colored in here, and start with the word domain. Everything else is either a service virtual machine, so it's running a system service, or a template virtual machine, so it's a virtual machine which the domains are based off. Now that we covered the basics of cubes and we covered the basic structure and how all the applications are isolated into different virtual machines and the meaning of each of these virtual machines, in this lecture, I want to actually go ahead and start using applications so that it's easier for you to understand what we mean by the different domains, how do they work, and how to use them to carry on your daily tasks. This will also make the whole concept of isolation and the different security domains easier to understand. So, as usual, we're going to go to the top left menu to launch an application. And like I said in the previous lecture, the actual virtual machines that you'll be using to carry out normal day-to-day tasks are the colored ones, the ones that start with the word domain. So let's go to the personal virtual machine or the personal domain, and let's launch one of the applications in here. So we have a files manager, we can launch Firefox, we can launch the settings or a terminal. So let's click on Firefox because we want to access the internet. And you'll notice here on the top right, it's going to say that it is starting the personal virtual machine or the personal domain. So the first time you launch an application within a domain, you'll notice that there will be a little bit of a delay. The reason for this is, like I said, each domain is its own virtual machine. So the first time you launch an application within that domain, the first thing that Cubes will do is start a virtual machine, start a completely separate computer, and then launch the application that you requested within this domain, within this new virtual machine. Once done, as you can see, you'll get your application, which is Firefox in this case, and let's see if it's connected. So let's go to Z Security. And perfect. As you can see, we have a normal internet access. Everything is working as expected, and you can use this browser the same way that you use any other web browser. Now, let's go ahead and go to the personal again, and this time I'm gonna launch my files. And you'll notice that this will be almost instant because the virtual machine is already running. Therefore, I can open the file manager within that virtual machine, so there is no need to start the virtual machine from scratch. Now in here we have a normal file manager that you can use to navigate through your file system and access your files. We have our downloads in here, your music, your videos, and so on. Double click to enter, right click to copy, paste, cut, get properties, and so on. So using this is very similar to using any other file manager. Now let's put this here to the side, and what I'm gonna do is I'm gonna go back to my applications, and this time we're gonna go to the work domain or to the work virtual machine, and again let's go ahead and launch a Firefox instance. Now again, this is the first time we launch Firefox from within the work domain. Therefore, this will take a bit of time to boot the work virtual machine first and then open Firefox. And perfect, as you can see, we have Firefox running in here, and let's go to Google this time. And as you can see, we have internet access. Now keep in mind, this window right here, the Firefox window, the blue one, it is a completely separate virtual machine than the yellow window right here. This is a work computer, a work virtual machine, a work domain that is completely separate from the personal domain. Therefore, if this personal domain gets hacked, or if the work domain gets hacked, the hacker will not be able to navigate to the other domain because these are two completely different and isolated virtual machines. They use their own resources, they use their own RAM, their own CPU, their own file system, so it's as if you're running two different instances of Firefox on two completely different computers. Now, in order to make it easy for users to distinguish between the different domains and different virtual machines, every time you launch an application within a domain, it'll have a specific color. So, if we go back to the menu in here, you'll see that the personal domain has this greenish kind of yellow color. You'll also notice that this is the same color in here in the window, and you will notice that at the start of the title bar, it says personal. This is the same for the personal file manager that I opened. Again, it's this greenish yellow color, and it also starts with the word personal. If you look at the work domain, you'll see that it is blue. If we look at the entry in here in my applications, you'll see the lock is blue as well. And you'll see that it says work at the title bar before the name of the application. So if I go ahead now and open my file manager in work, you will also see that the window is going to be blue, as you can see in here, and again, it starts with the word work. Therefore, when you're using cubes, it'll be very easy for you to know which security domain or which virtual machine you're running in. Now, if you've done any of my other courses, or if you have any experience with using virtual machines, you're used to the way that when you start a virtual machine, you will see a new desktop. So if you're starting a Linux virtual machine, for example, you will see a new Linux desktop within your current operating system. This is not the case with cubes because at any instance, you could have 4 or 5 virtual machines running at the same time. Therefore, it would get very confusing and very hard to manage. Instead, they use this coloring scheme and the titles that you see in here to help the user understand which security domain or which virtual machine they're running in. And this design is really nice in my opinion because it is seamless. You don't actually see new desktop every time you launch an application. You only see the application window and the color indicates what security domain or what virtual machine you're running in. Now, to make this virtual machine idea stronger and to help you understand it better, let me give you an example. So let's say I wanted to download this image right here in this page. So I'm just going to right click the image, save image as, and we're going to save it in my download. So I'm just going to click on save. Now this is just an example of downloading a file. Regardless of what it is, I'm just downloading an image as an example. So the image is downloaded to my downloads directory, and if I go to my file manager, the yellow file manager, because remember we downloaded it from the personal web browser, so it gets downloaded to the personal file system. So I'm in the personal file system, and if I click on my downloads, I have the image right here. So that's perfect. Now, if we go to the other file manager that we opened, the work file manager, which is in blue in here, if I go to my downloads, you'll see that I don't have the image. And the reason for this is, again, this is a completely separate virtual machine that has its own resources, that has its own file system. So whatever I do in here, whatever I do within the personal domain, even if I run any viruses, even if it gets hacked, this is a completely separate computer. Therefore, whatever happens in here cannot move and affect this machine, and vice versa. So even the history, for example, we access DevsWiki.org in here, so it should be in my Firefox history. So if I do Control H in here and look at today, you can see that we access DevsWiki. Now, if we go to the Firefox web browser in here and we do Control H to see our history, you will not see DevsWiki because, again, this is a web browser that is running in my work virtual machine, and this is a completely separate machine that does not know what happens outside of it. And it is through this separation that Qubes excel and improves our security because, like I said, the idea is you use the separate domains to carry out separate tasks. So you use the work domain to do your work stuff, you use the personal domain to do your personal stuff, and you use the untrusted domain to do all of the other stuff that does not involve logging into accounts and that you might be opening untrusted websites and files. And this way everything is separated, and if any of these domains gets compromised, it does not affect the other domain. Now, once you're done with using a certain domain, for example, let's say I'm done with my personal tasks and I closed my browser and I closed my file manager as well, and I don't want to do anything personal anymore. If you want to free up some space, you can click on the Qubes icon in here on the top right. This will list all of the virtual machines running at the moment. So if you want to free up some space, we can see that the personal virtual machine is using 842 megabytes of my memory. So if I wanted to free up some space, if I'm not going to use this virtual machine anymore, you can just click on shutdown in here to shut it down. So this is it for this lecture. I just wanted to show you an example to help you understand the way Qubes separates the different domains. I wanted you to understand the different virtual machines and how they cannot interact with each other and how that improves our security. And in the next lectures, I'm going to show you how to carry out different tasks within this operating system, and the separation will become clearer and you'll see how Qubes can really improve our security. Now, in this lecture, I want to show you how to use Qubes to carry out two important tasks that you're used to use on other operating systems. And as I do this, again, the idea of the separation and the different domains and virtual machines will become even clearer. So right now, I have an instance of a file manager in my personal domain. And on the left here, I have an instance of the file manager in my work domain, in my work virtual machine. Again, as you can see, it's in blue and it says work at the start. So as I showed you in the previous lecture, when we downloaded something in my personal virtual machine here, the image, it doesn't exist in my downloads directory in here because, like we said, these are two separate virtual machines using two separate file systems. Therefore, they're completely separate and they do not share anything. Now, what I want to show you is copy pasting. So let's say I wanted to copy this file. I can right click copy, or you can do Control C just like any other operating system. And then because this is a picture, we can go to my pictures in here and just do Control V or right click paste, and we will have the picture. So this is perfectly fine. It's perfectly normal. But if I do this again, so let's do right click copy, and let's say I want to put it in my downloads in my work file system in my work domain. If I do right click in here, you'll see that the paste is grayed out. I cannot paste. And if I do Control V, you'll see that nothing will happen. And the reason for this is, again, it goes back to the whole idea of the separation of the different domains, which are completely separate virtual machines. So you can think of them as if they are two different computers. Therefore, what we did right now, it's as if you go to a computer, you right click and a copy image, and then you go to a completely different computer, to another laptop, and then you're trying to paste that image in that laptop. Obviously, that's not going to work because these are two separate computers. They use two different storage devices. Therefore, the second computer is not even aware that you actually copied something. Now, because these two computers or these two domains are running within cubes, within one hypervisor, we can actually copy and paste between them. It's just slightly different. So, if you want to copy something within the same virtual machine or within the same domain, it's fine. You can right click and copy. But if you wanted to copy between two different domains or virtual machines, you'll have to right click this, and instead of clicking on copy, we're going to click to copy to other app VM. Clicking on this will show us a window that will ask us which VM or which domain we want to copy this file to. Now we want to copy this to our work VM, to our work domain. So I'm going to type work and I'm going to click on OK. Now you'll see that this will not appear in here, but if we go to the home directory, you'll see we have a new directory in here called cubes incoming. And this is where you will see all the files that you copy from other domains or other virtual machines. So if we double click this, you'll see we have a directory called personal. If you copied stuff from another domain, for example, if you copied it from the untrusted, you'll have a directory called untrusted. So inside the personal directory, you'll see we have the image that we wanted. If we double click it, you'll see that the image is fine. This is the actual image. It did not get corrupted. And you can now right click it and copy it and paste it to anywhere you want within this operating system within the work domain. So this is how to copy files within a domain or between two different domains. Now what about copying text? So let's just type something simple. I'm just gonna click on the search in here just so that I have a text box that I can type in, and I'm just gonna type this is some text to copy. Now, if you want to copy this text within the same operating system, again, it's exactly the same as any other operating system. You select all the text that you want to copy. You can do right click copy or Control C from your keyboard. And then if we remove this and then open the search bar again and do Control V, this will paste it in here for me. So identical behavior to any other operating system that you're used to. Again, the tricky part is trying to copy this text from one domain, from one virtual machine to another domain. Because this domain right here is a completely separate computer, it doesn't even know that you copied this text. So to get around this, you'll have to first select the whole text. You'll have to do Control C or right click copy to copy it. And then we're going to do Control Shift C. Doing this will copy the text into the global clipboard. So right now, the text that I just copied is available for all operating systems, for all domains to capture. And if you go here to our clipboard, you can see that we have 25 bytes of data are copied from the personal domain. Now, if we want to paste this in here in my work domain, before we can do Control V, which is the shortcut for pasting, you have to first of all get the global clipboard, get the text that we copied to the global clipboard. To do that, you have to do Control Shift V first. And as you can see now, it's telling us that the global clipboard has been wiped and it's in my work domain clipboard now. So now I can paste it exactly the same way that I paste anything else. I can just do Control V, and as you can see, we have the text pasted in here. So this should show you how separated these virtual machines are, and this is what makes cubes so cool, because they are so separated, but they can also communicate with each other if the user wants to. But if a hacker gains access to one of these machines, he doesn't have access to the global domain, and therefore they can't move from one domain to the other. So if one machine gets hacked, it's very difficult for a hacker to go and compromise the other machines. Now, another task that you'll probably be performing a lot is connecting a USB device to your computer, whether it's a mouse, a camera, or a storage device. When you connect a USB device to cubes, it doesn't get connected to any domain or to any virtual machine, which is great because it is very hard to trust USB devices. I actually cover this in my conference in Orlando. You can weaponize pretty much any USB device, even a USB lamp or a mouse, to execute commands on the computer that it gets connected to, and this way it'll allow a hacker to gain full control over that computer. I will include a link to that talk if you're interested. But the cool thing here in cubes, when you connect a USB device, it will not allow that device to register itself as a keyboard first, and it won't connect it to a virtual machine. It'll detect the device, but it'll wait for you, for the user, to select which domain or which virtual machine you want to connect this to. And then even if that code gets executed, it'll only hack into the machine that you connected to, and it'll be very difficult to move from that machine and compromise the other machines. You can even connect it to a disposable virtual machine to do untrusted tasks in. We'll talk about untrusted virtual machines in the next lecture, so stay tuned for that. Now, first of all, before I connect my USB device, if you go in here to the top right, you will see all of the devices connected to the Cube's operating system right now, and a lot of these right now are built-in devices in my computer. I haven't really connected much via USB. So we're gonna remember what's in here now. I'm gonna close this window, and I'm gonna connect my storage device. And as you can see, we get a notification that the device is ready to be used. But if we look in any of these machines, you'll see that we don't have access to this device. To connect this device to a virtual machine or to a domain, we're going to go to the devices in here again. And you'll see we have the device in here. This is the name of the device that came up in the notifications. It's also the extra device that didn't exist before when we opened the list. And if we hover over it, you'll see that it's going to list all of the running domains, all of the running virtual machines that we can connect the device to. So right now we only have the personal and the work running, the ones that we can actually use. And let's say I want to connect this to my work virtual machine or to my work domain. All you have to do is literally just click on this, and you'll get a notification telling you that it's going to connect it to the work domain. And give it just a little bit of time, and then we're going to go to our other locations. And as you can see, we have it right here, my 8 GB volume. We can double click it to access it, and then interact with its files exactly the same way that you would in most other operating systems. Again, double click to open, right click to get the options, copy and paste like I showed you, and so on. So that's it for this lecture. I just wanted to show you some of the tasks that you're going to be using a lot. And through that, I also wanted to help you understand how these domains are completely separated from each other and how this separation can make the whole operating system more secure or help us improve our security. Now, before moving on and talking about the other security domains, such as the disposable and the vault, in this lecture, I want to talk about another task that is very essential and that you'll probably need to do often. This task is basically installing software. So if you look at the machines that we have right now, for example, the personal or even the work machine, they don't really have a lot of software. We have Firefox, we have the files manager, a terminal, and that's pretty much it. We don't have a word editor, we don't have Pigeon, for example, for instant messaging, and so on.
So you can do the simple tasks such as opening images, playing music and videos, and accessing the internet, but anything outside of that, you'll probably need to install software to do that. Now, as we do this, you'll also get a better understanding on the structure of cubes, and you'll have a better understanding of the template virtual machines, the ones that we have right here. Now, as I said before, the template virtual machines are machines that you're not supposed to use to run your day-to-day tasks. These are machines which the other machines, such as the domains that we have here, are based off. Keep going through this lecture and you will understand exactly what I mean. So, right now I have my work machine running right here. As you can see, I have my file manager. And as we've seen before, if we store stuff within our home directory, so we are in home right now, as you can see, and anything we store in here will be persistent and will be maintained after we restart or shut down the domain or the virtual machine. But if you store anything outside of this, which is where applications, libraries, and packages get installed, they get installed outside of your home directory. Anything that gets installed outside of the home is not persistent. So every time you restart or shut down the computer, anything outside of the home directory goes back to its original state. This is done for security reasons. For example, if someone manages to hack into this domain and they install some malware that'll start every time you start your computer, this will automatically be removed because it'll be installed outside of this home directory. So anything outside of the home goes back to its original state every time you restart or shut down the computer. This original state is stored in your template virtual machine. So let me show you. If we go here to the cubes and we click on the cube manager, you'll get a program similar to a task manager. And in here, you'll see all of the cubes, all of the virtual machines that you have. And it'll show you important information about each one of these machines. Now again, you'll notice the domains are the ones that have colors in here, and these are the ones that we use for our day-to-day tasks. And then we have the template and the system virtual machines in black. Now you'll notice for each of these domains, for example, for the personal, in the template column, it's telling us what template it's running or what operating system it's running. So you can see the personal is running Fedora 30. You can see the untrusted, the sysnet, the work, all of them run the template that is called Fedora 30. Now Fedora is a Linux operating system, and basically each one of these virtual machines or security domains are based on the Fedora 30 template. So when we start the work virtual machine, it uses the Fedora 30 template, so we can see the Fedora 30 in here. It creates a virtual machine that uses this virtual machine as a template, and the only thing that it replaces is the home directory. So the only thing that it replaces is what we see in here, which are the user files that they use in their day-to-day tasks. Now, because every time we start the computer, it pulls everything outside of the home from the template virtual machine, this means that if we install software on the template virtual machine, it will be installed on all of the virtual machines that use this template as a template. So if I install Pigeon, for example, in my Fedora 30 template, work, personal, untrusted, all of these virtual machines use the Fedora 30 as a template, and therefore all of these virtual machines will automatically have this software installed on them. Now this can also be dangerous because keep in mind, if you install malware on your template virtual machine, all of the other virtual machines based on this template will inherit the malware. So you want to be very careful on what you install on your template virtual machine. Now, as an example, I actually want to install LibreOffice, which is a program that allows us to open the different Office files in Linux, because I want to open this Word file in future lectures. So I want to be able to use LibreOffice in my work domain. And based on this, we know work is based on the Fedora template. Therefore, we're going to install LibreOffice on Fedora 30 and it will automatically be available for all of the other virtual machines that use the Fedora 30 as their template. Now, before doing so, before going and installing anything on this, we need to enable networking on this virtual machine because by default, to improve its security, the template virtual machines are not configured to be connected to the internet. So you can right click and go to settings, you can click on the icon in here, or you can go from the top left, go to the template virtual machine and click on the cube settings, not its settings. So we're going to enter the cube setting, the virtual machine setting, and what we want to do is modify the networking. As you can see, by default it's set to none, and we want to set this to sysnet so that it gets connected to the internet. We're going to click on OK. And now we're ready to go and install software on this virtual machine. So again, we're going to the top left, we're going to go to the virtual machine, and we're going to click on the software in here to launch the software manager. Now, first of all, this will start the Fedora 30 template virtual machine, and then only when it starts, it'll launch the software manager. So similar to starting any application within any virtual machine. So now you can look for the program that you want to install from the list here, or you can click on the search and search for it. So I'm just going to search for Office. And the program that I want to install is LibreOffice Writer. So we're going to click on it and click on Install. So it's very intuitive and very similar to installing software on most operating systems. Now you want to give this some time depending on your machine. Sometimes, again, it seems like it's stuck at one stage, but it's not, it's loading. So just be patient with it, and once it's done, you'll have the software installed. Perfect, now the installation is complete. So right now we have installed this software, the LibreOffice Writer, on the Fedora 30 virtual machine. So I'm going to close my software manager, and I don't want to use this virtual machine anymore because, like I said, we don't use the template virtual machines for our daily use. Therefore, we're just going to go to my cubes and I'm going to shut it down. Now you'll notice we have a new icon in here beside all of the virtual machines that use the Fedora as its template. And if we hover over this icon, you'll see that it's telling us that once our template is stopped, once we shut down the Fedora machine, the changes that we made to the template will be reflected on these machines because these machines use the Fedora as their template. Now I'm also going to go ahead and turn off my work computer. So the software that I installed should be available in my work and in all of the other machines that use Fedora as a template. So let's go ahead and start my work. And I'm just going to go to my file manager. And I'm going to go to my downloads because I've already downloaded a Microsoft Word document in here just for testing. So let's right click this and open with LibreOffice Writer. As you can see, we have a new option in here. This wasn't available. This is only available because we installed Office Writer, and the only reason why it's available in Work because Work uses the Fedora 30 as its template, and since we installed this in the template, it's going to be available to all virtual machines that are based on this template, such as the Work virtual machine or the Work domain. So if I click on this, it'll load the program and I'll be able to read this document. Now, one last thing that I want to show you before we wrap this up, I'm going to close this. And if I go in here and go to my work, you can see that I have some of the programs that are installed in the Work domain, in the Work virtual machine, such as the files, Firefox, and my terminal. But I still don't see the LibreOffice Writer, which is what I just installed. So it'll be really nice if I have it here and I'll be able to access it directly from here so that it'll automatically start the Work domain and then from there launch the Office Writer, similar to what happens if I just click on Firefox. Now doing this is very simple. Again, we're going to go back to our Cubes Manager. We're going to click the machine that we want to modify, which is my work in this example. We're going to click on its settings in here. And we're going to go to Applications.
and this will list all of the applications available on this virtual machine. We're going to click on refresh applications first to get a list of all of the applications available. This will have to start the template in the background, as you can see, and it will automatically shut it down once the refresh is done. And then in here in the left side, we have all of the programs installed on the work virtual machine. So we're going to look for the program that we want to add to the menu that we have in here. So I'm going to scroll down, and you can see I have my LibreOffice Writer in here. So I'm just going to click on the right arrow, and we have LibreOffice added now in here. So I'm going to click on OK. And now if I go to my menu and go to work, you'll see that I have a new entry for the program that I picked, and I can just simply click this from here to start LibreOffice whenever I want. So if the virtual machine is running, this will instantly start the program. If the virtual machine is off, it'll first start an instance of my work virtual machine, and then it'll automatically launch the program that I selected, which is LibreOffice in this case. So that's it for this lecture. Now you know how to install software in Cubes and use it in the different domains. So you can use this to install any program you want, not only LibreOffice, whether you want to install Pigeon or any other software that we used before or any other software that you're used to. You can follow the exact same steps to install it on Cubes and then make it available to any domain or to any virtual machine within your Cubes installation. In this lecture, I'd like to talk about a really cool virtual machine type in Cubes. The final type that we haven't spoke about yet is the disposable virtual machines. Now, as the name suggests, these machines are designed to allow you to run any files or any data or any websites that you really want to run, but at the same time, you're not sure whether you should trust this data, whether you should trust this file or website or not. The whole idea is when you start a disposable virtual machine, Cubes will create this virtual machine. Unlike what happens with all of the other machines, Cubes will start an existing machine. In the case of the disposable virtual machine, when you start one, Cubes will create a new virtual machine. You will use it, and then when you're done, when you turn it off, Cubes completely destroys this machine. So the next time you start a disposable machine, you will start a completely new virtual machine. Now, just like all of the other virtual machines, this virtual machine is completely isolated. So if it gets compromised, if it gets hacked, it uses different resources and different file system. So it is very difficult for a hacker, even if he manages to hack into the disposable virtual machine, to move on and hack into the other virtual machines that you have inside Cubes. Not only that, as soon as you turn off this virtual machine, like I said, the whole virtual machine is destroyed. So even if they have some kind of a persistent malware, or even if they're trying to exit the disposable virtual machine and move somewhere else, their connection will be completely disconnected because the whole virtual machine will be destroyed. So, hovering over this, just like any other virtual machine we have inside Cubes, you can see that we can launch a number of programs, mainly Firefox and the terminal, and then you can enter the Cube settings. This is pretty much everything you'll need. So for example, let's say you're using your work virtual machine right here. So I have a Firefox instance in my work domain, as you can see here. And let's say you got an email that appears like it came from an address that you trust, whether it's a friend's address or an address of your boss or an address of a company that you work with. So you really want to click on a link that's inside this email, but at the same time, you're not sure if this link is safe to click on or not. Because keep in mind, hackers could have hacked into your boss or into your friend and then sent you that email. Or they can actually send emails that look like they're coming from other people. And I actually show how to do this in my social engineering course, and I showed it off in my talk at the Global Cybersecurity Summit in Orlando. I will include a link to the talk in the resources of this lecture, and if you're interested in my other courses, check out the bonus lecture, the last lecture of the course. Anyway, so you can get an email that looks like it's coming from an address that you trust, and the email could ask you to click on a link. Now, clicking on this link could result into you getting hacked, but at the same time, because you trust this address, you actually want to click on the link. So the best solution for this is to go and start Firefox inside a disposable virtual machine. Like I said, this will create a completely new virtual machine, and inside this completely new virtual machine, it will start a Firefox instance. And perfect, as you can see, we get a normal Firefox browser. So what you want to do is, let's pretend that this is the email that you got. All you'll have to do is copy the link that you want to open. You don't want to open it in here. You just want to click on copy link location. This will copy it within the clipboard of this virtual machine of the work domain. So you'll have to do Ctrl-Shift-C to put it in the global clipboard. Go to the virtual machine where you want to paste it. Again, I covered this in details before, so I'm doing it quick. If you don't remember how to do it, go and revise that lecture. So we go to the virtual machine where we want to paste this text. We're going to do Ctrl-Shift-V to paste it in the clipboard of this virtual machine, and then Ctrl-V to paste it in my URL in here, as you can see. And I have the link right now in here, so all I have to do is just hit enter, and that'll load the link for me inside this completely isolated disposable virtual machine. So let's assume that this link exploits some kind of a vulnerability that will allow the hacker to hack into my computer. They will gain control over this disposable virtual machine. On the X in here, the whole virtual machine will be shut down and it'll be destroyed. So the next time I run a disposable virtual machine, I'll actually be running a completely new virtual machine that does not contain the malware, even if it was downloaded using the previous session. So that's really cool, but it doesn't stop there. Let's assume that you really want to open this file, but at the same time, this file is downloaded from the internet or from an email, so you can't really trust it, even if it's coming from a trusted email. Like I said, someone could have hacked into the account that sent you the email, or someone could be pretending to be that email, but they're not. So if you really want to open this file, all you have to do is right-click the file. Instead of clicking Open with LibreOffice, you want to go to View in a disposable virtual machine. Clicking on this will create a completely new virtual machine like we've seen before, and then opens the file inside this disposable virtual machine. And once you close it, the whole virtual machine will be destroyed, the file will be removed from the virtual machine, and even if the file contained malware, the malware will not be able to exit that virtual machine and affect your work computer in here, because again, they are two completely separate operating systems. Now, I'm not going to show you that because it's very simple. All you have to do is literally click on View in a disposable virtual machine and it'll work as expected. What I really want to show you and what I think is really cool is the Edit in a disposable virtual machine option. So with this option, again, it'll create a new disposable virtual machine, but it'll open the file for editing for me. This way, not only I'll be able to read the file, I'll also be able to edit the file, save it, make changes to it. For example, if I was asked to fill something or to sign the file, I'll be able to do that. So for example, let's just type test, and I'm going to do Ctrl-S to save it. We'll keep it at Microsoft Word 97 format. And now I can go ahead and send this file back, knowing that even if this file contained malware, it did not affect my domain. Now, just to show you, you're not supposed to do this, but just to show you that the changes were saved, I'm going to double click this file just to open it here, just to save time. And we have it here. And as you can see, what I added in here, test, it's saved and it is contained within the document. So this way, not only that you can view documents safely, you can also edit them safely without affecting the security domain that you're working in. And if this wasn't enough, there is another really cool feature that you can do for images and for PDFs. This really cool feature allows you to not only view the file in a different disposable virtual machine, but you can also convert the file to a trusted PDF. So again, regardless of how you got this PDF, whether you got it from a friend, from an email, from the internet, let's assume that you have a PDF that you really want to run. What you can do is you can right click and view in a disposable virtual machine. That's fine. Or you can click on convert to a trusted PDF. What this will do is it'll first of all create a new disposable virtual machine. It'll copy the PDF to this new virtual machine. It'll use a complex process in order to make sure that the PDF contains no malware, and also completely destroy the PDF and convert the data in this PDF into images. At the end, you'll notice we have a new file in here. This is called sample.trusted.pdf. So it added the word trusted to our PDF. And this PDF right here is a completely clean version of the original PDF. So not only that we can open this PDF in our current domain safely, knowing that it contains no malware, but you can also go ahead and send it to others. So let's assume you need to send this to a colleague or to a friend, but you're not sure if this PDF is clean. Then this way you can clean the PDF and make sure that it contains no malware. At the same time, you can find the original PDF. If you go to Home and scroll down, you'll see we have a new directory called Cube's Untrusted PDFs. And in here, you'll see the original PDF that we converted to a trusted PDF. So that's it for now. I think this is a really cool feature in Cubes, and it can really prevent a lot of attacks because, like I said, hackers can hack into your friends or into your colleagues or into other companies' accounts and then social engineer you into clicking on links or downloading files. And this happens all the time in companies. And like I said, I showed off a lot of these scenarios in my Global Cybersecurity Summit. So if you're interested, go have a look on that. I will include a link to the video in the resources. And basically at the end of it, a lot of people were asking, so how can we prevent this? Well, the only solution is, first of all, educate the employees. But at the same time, like I said, you might get a file, a document, or a link from someone that you trust. And even though you might think that this could be suspicious, at the same time, if you're getting this from your boss or if you're getting this from a company that you do business with, you really need to open the file anyway. Or if you're a security researcher, again, in many cases, you want to open the file anyway. So this is a really good way of handling untrusted files. We've seen so far how great Cubes is at improving our security. It improves our security through the different security domains by isolating them inside individual virtual machines that use their own resources. We saw how cool the disposable and the vault virtual machines are, and more. All of these features make a really secure operating system, and they also improve our user experience and force the users to use their operating system in a more secure manner. So that's the security part covered, but we still haven't covered how to become anonymous and how to improve our privacy while surfing the internet using Cubes, because all of the virtual machines that we've seen so far access the internet directly and therefore are vulnerable to trackers and so on. Now, all of these operating systems use the same networking virtual machine, which is the sysnet right here. Like I said, this routes the traffic directly to the internet, and therefore they're not anonymous or private. However, Cubes also offer another networking service, which is the syshunex. This is a networking service that forces the traffic to go through the Tor network. Therefore, when a machine is configured to use the syshunex as the gateway, this machine's traffic will be forced to go through the Tor network, therefore improving our privacy and anonymity. Now, by default, we have a domain called Anonymity. This is something that I haven't covered so far. And as usual, because this is a domain, this means that this is a virtual machine designed for us to use to carry out day-to-day tasks, to carry out normal tasks. And this virtual machine is a template of the Hunex workstation right here, and is configured to use the syshunex as its gateway. Therefore, all of the traffic going out of the Anonymity virtual machine will be forced to go through the Tor network.
Let me show you real quick before we run this machine. So I'm going to go to my Cubes Manager, and in here, you'll notice that we have the Anon Whonex right here. This is the virtual machine that we can use for our day-to-day use because it is a domain. And if you look under the NetVM right here, you'll see that it is configured to use the syswhonex as its network virtual machine, which means that all of the traffic in this virtual machine will be forced to go to the syswhonex, which will force that traffic to go through the Tor network. Now, if you look at all of the other virtual machines, you'll see that they're configured to use the sys firewall. For example, the work right here, you'll see that it is configured to use the sys firewall as its networking virtual machine. And if we follow this, we have sys firewall right here. You'll see this will redirect the traffic to the internet. So any traffic in my work domain and all of the other virtual machines will go to the sys firewall and then to the sysnet and to the internet. Therefore, it is not anonymous and it's not private. So let's go ahead and use this virtual machine. So we're just going to go again, as usual, to the virtual machine we want to start, which is Anon Whonex. And you can see a list of all of the programs that you can run inside this virtual machine. First one is an IRC chat client that you can use to communicate over IRC if you want. You got your settings, you get your file manager, you have the Tor browser, which we've been using inside different operating systems. So using it in here is identical. You have a wizard that will allow you to download and update Tor. Using this is very simple. You can just click it to run it. It'll check what's the latest version. And if there is a new version, you can install it from here. You can run the Whonex check right here to check the whole Whonex operating system, the whole Whonex virtual machine. Make sure that it's up to date, make sure that it is configured and it's running as expected. This actually runs the first time you run Tails. If you remember, when we got the Whonex wizard, then we went through it in the first basics lecture of this section. So there's no need to run this again. And you also have your terminal where you can execute commands inside this virtual machine. So right now, let's just go ahead and run the Tor browser. Obviously, as usual, this will start the Whonex virtual machine first, and then as soon as it starts, it'll launch an instance of the Tor browser. And perfect, as you can see, we have the Tor browser running inside the Anon Whonex domain. Notice the color, it's different than all of the other domains. Again, this will help you to easily know which domain you're working in or which virtual machine. And you can navigate to check.tor.com or just click on the IP check in here. And you'll see that this machine is configured to use the Tor browser properly. So we are accessing the internet through Tor. So right now you can go ahead and access Tor hidden services from this browser. You can also change its settings in here from the same places that you're used to. So this is the exact same browser that we're using. The only difference is right now it's running through its own isolated virtual machine. And as usual, if this virtual machine gets compromised or hacked in any way, it is completely isolated. So it is very difficult and highly unlikely that the hacker will be able to exit this and compromise other virtual machines. Now, just to confirm, I already have a web browser here running in my work domain. And let's just go to Google and check what's my IP. You'll see that my IP, my actual real IP in here, is completely different than the IP that we see in here inside the Tor browser, because inside the Whonex virtual machine, like I said, everything's being forced to go through the Tor network, whereas my work virtual machine, if we look at the Cubes VM in here, the work virtual machine is using the sys firewall as its virtual machine, which forwards data directly to the sysnet and therefore goes directly to the internet. Now, another really cool virtual machine that we have in here is the disposable Whonex workstation. So we already covered the normal disposable virtual machine, and we saw how this can be very useful to run untrusted applications, untrusted files, or open untrusted websites, because like we said, every time you start a disposable virtual machine,
cubes create a completely new virtual machine, and then when you stop it, this virtual machine is completely destroyed. Therefore, even if it contained any malware, this malware will be destroyed along with the actual virtual machine. And because this is a completely isolated virtual machine, it is very difficult to compromise the other machines. So right here, we have another disposable virtual machine. The only difference between the Whonex and the Fedora one, the Whonex one, as the name suggests, will force all of the traffic to go through the Whonex gateway, which forces all the traffic to go through the Tor network. So you can think of this like a disposable virtual machine that will force all the traffic through the Tor network. So you can use this virtual machine to run any untrusted darknet links, and there are a lot of untrusted darknet links, so this is very, very useful. And you can also use it to run any untrusted files that you get through the darknet. Now, usually you shouldn't trust any files you get even on the clear net, but if you're receiving files or if you want to open files that you download from the darknet, then you should definitely run it inside a disposable virtual machine. Now, using this is similar to any other virtual machine. You can run the application that you want from here. And because it is disposable, like I said, when you click on an application, a virtual machine will be created specifically to run this application only. And when you close the application, the whole virtual machine will be destroyed. Now, with these two virtual machines and with the way Cubes is structured, you can do so much more. You can actually create a different virtual machine for every identity that you want to use on the darknet. So for example, you can have a number of domains similar to the way we have work and personal and untrusted here that all go through the clearnet. You can have a number of virtual machines that force their traffic through the Whonex gateway through Tor and use each one of them for every identity you use on the darknet. Or, for example, use one of them for chat, use one of them to only include your crypto wallets, and use the other for surfing the internet or for surfing the darknet. So you can really structure this any way you want, and doing that is very, very simple. Let me show you. So again, you need to go back to your Cubes manager, and all you have to do is right-click the machine that you want to clone or create a copy of. And in this case, let's say you want to make a copy of our Anon Whonex because this is the virtual machine that forces traffic through the Tor network. And all you have to do is right-click it and click on Clone Cube. This will create a new virtual machine that is identical to Anon Whonex, and then you can use this for any other reason you want. So this is really, really cool and can be tailored to fit so many scenarios and so many uses. Now, installing software on the anonymous Whonex Cube is slightly different than installing software on the other virtual machines because the others were based on Fedora, and as we've seen, Fedora comes with its nice package installer. So if we go on the personal or on the work, they're all based on Fedora. So if we want to install something on any of them, we go to the Fedora template and we click on software. This will launch a really nice graphical interface that allow us to install software, and anything we install in here will become available to work, personal, untrusted, and so on, because they're all based on the Fedora 30. Now, because the Anon Whonex and the disposable Whonex that we use are based on the, if you look in here, you'll see they're based on the Whonex 15. You'll see that installing software on the Whonex 15 is a little bit different than Fedora because it does not have a nice package manager, a nice graphical interface. Therefore, we're going to have to install software from terminal. Now, don't worry about this. I'm going to take you through it right now. If you've done any of my other courses, then this will be very easy and very familiar to you, but I still suggest you watch this lecture as you might learn a trick or two. Now, to do this, we're going to have to, let me minimize this. We're going to have to go to the template that we want to install software on. And like I said, there is no graphical user interface that allows us to install software. Therefore, we're going to have to do it from the terminal. Okay, now this will start a nice terminal for us. I'm just going to clear its screen. And the first thing that you want to do when you start this terminal is update the sources from which you can download packages and software. we need to do this with admin privileges. So to run a command with admin privileges, we have to first type sudo and then type the command that we want to run. And in my case, I want to update the sources like I said, so the command will be apt-get update. So apt-get is the program that we use to install software on Debian-based operating systems such as Unix, and what we want to do is literally just update the sources from which we can download software. We're not updating anything, we're literally just updating the list of packages that we can install. Once this is done, we can search for packages and install them. So let's say, for example, you want to install Pigeon. If you remember, we used Pigeon before for instant messaging in Tails. So let's say you want to install this. To do that, first of all, let's say you don't really remember the program name, or you want to search because you're not sure what the name of the Pigeon package. So let's say you want to search for this program. We're going to do sudo again, and we're going to do apt catch, and we're going to say I want to search for a package called Pigeon. Now this will list all of the packages that has the word Pigeon in them. So you'll see the package that you want, plus a lot of other packages, maybe related, maybe not even related. So for example, let's say you're looking for a chat program or messaging program, you can just do apt catch search message. In my example, as you can see right here, I have the name of the package that I want to install, or the name of the program, Pigeon, and I also have the description of it, which is a graphical multi-protocol instant messaging client. So all I need to do is basically install a package called Pigeon. Now to do that, again, we're going to do sudo because we need to run this under admin. We're going to use the same program, apt-get, and instead of updating the sources, we're going to say I want to install a program called Pigeon. Very, very simple. We're going to hit enter. And because I've actually downloaded and installed this before, it's automatically downloading and installing it for me without asking me. But for you, if you're installing software or a package for the first time, it's going to ask you to confirm, and you're just going to have to type Y and hit enter to continue the process. Now once this is done, Pigeon is installed now on my template virtual machine, my Unix workstation 15. Like I said, we never use the templates to run the actual software. We only use them if we want to update or install software. So this is done, this is installed, we're happy with it. I'm going to close it and I'm going to shut down my Unix workstation. Wait for it to fully shut down. And once it is off, I'm going to go to my cubes manager again. I'm going to go to the machine that I want to use the program from. So for example, the Anon Unix right here, we're going to go to its settings. So you can click on this, or we can right click and go to settings. We're going to go to applications. And as you can see, we have the Pigeon Instant Manager available for us in here. Now you want to make sure that the machine is off when you're doing this. Otherwise you won't see it. If you don't see it, try to click on refresh applications and it should become available. Now once we have it, we're going to click on it here to make it available in the drop down menu in here, and we're going to click on OK. So now I can go in here and I can go to my Anon Unix, and I have Pigeon Instant Messenger right here. So I can click on it, wait for the virtual machine to start, and it'll start Pigeon for me once the virtual machine is working. And perfect, as you can see, now I have Pigeon working inside my Anon Unix domain, and we can use it exactly the same that we learned with Tails. You click on add, you create your user, or you log into your existing account, and then you start communicating, sending messages, and so on. Now in this example, obviously I literally just installed Pigeon, but you can follow the exact same steps if you want to install any other program or any other package. Now I highly recommend you get comfortable with using the terminal and installing programs through the terminal through apt-get. But if you really want to have an easy way of installing programs, a graphical user interface, then you can install a program called Synaptic, which basically interacts with apt-get and allows you to install software through a nice graphical user interface, similar to what we did when we were installing programs inside the Fedora 30 virtual machine. Now to do this, we'll have to install Synaptic. We'll have to install this graphical interface. So let me turn off my Whonex machine again. And we're going to go back to the terminal of our template, which is the Whonex workstation. And we're going to clear the screen. And this time, instead of doing apt-get install pigeon, we're going to install a program called Synaptic. We're going to hit enter. It's asking me if I really want to do this. I'm going to say yes, please install it for me. And like I said, this is literally just a graphical user interface that allows us to install packages if you really don't want to use the terminal. Perfect, now it's installed. And usually we don't use any programs inside the template virtual machines. Like I said, we use them inside the domains. This is what we did literally with Pigeon and with everything else. But because Synaptic, the program that we installed, is a program that allows us to install other packages and other programs, it only makes sense to use it inside the template so that all of the other virtual machines that are based on this template would inherit these programs. Therefore, we'd want to use this inside our template virtual machine. So back to the Cube Manager, we're going to select our template, which is the Whonex Workstation 15. We're going to go to its settings, applications. We're going to scroll down. We're going to look for the package manager. We're going to add it here to the right. We're going to click on OK. And now if we go to the drop-down menu over in here, you'll see we have a new entry, which will allow us to launch this graphical interface for the package manager for apt-get. We're going to close this warning, and perfect. As you can see, we have a program that has a nice graphical user interface. You can use the search button in here to search, and then if you want to install any package, you literally just tick it in here from the list, mark for installation, and mark, and then click on apply to apply the changes and install the package. Like I said, I highly recommend getting used to using the terminal. It is much better, and if you know how to use it, you can use it across multiple platforms. You're also installing less packages, so there is less attack surface. And finally, there are people reporting issues with Synaptic inside Whonex. They're saying it creates a lot of problems. So you can see whatever suits you best and just go with it. Now finally, before we wrap this up, I'm going to close this, I'm going to quit. I just want to show you how you would update any virtual machine or any template. I've touched on it before, so you can actually start the template, whether it's a Fedora or Debian, or even if it's another operating system, literally look up how that operating system gets updated and follow the steps. So usually for Linux, you do apt-get update, apt-get upgrade, and then apt-get dist upgrade to upgrade for another distro if there is a new release. Alternatively, you can actually just do it in here from your Cubes manager. For example, again, let's say you want to update your Whonex workstation. Right click, click on update. This will automatically start the virtual machine if it's off. In my case, it was already on. It'll start the terminal. It'll check the sources. And once it gets a list of all the updates, all you have to do in here, it's asking us to confirm. You'd hit Y, hit enter, and it'll update it for you.